So what exactly is React? React is a JavaScript library for building user interfaces. So you as a developer, when you use React, you are actually using a library that is based on JavaScript, or in other words, vanilla JavaScript, alright? It's also called vanilla JavaScript. The term vanilla JavaScript simply means that you are using plain JavaScript, so it means plain JavaScript, the core language itself, without any libraries or frameworks, alright? And when you use React, you are using a library which is based on vanilla JavaScript. And then you use React to create websites, specifically the UI or the user interface of the website. Now let's understand why it's more efficient and easier to use React to create the user interface of websites instead of using vanilla JavaScript. First, React creates a single page application. Let's understand what does this mean. Let's say you open the browser and you are visiting a website, right? So this website is hosted on a server. And you open that website, so the browser will make a request to load the home page from the server, and the server will respond with the HTML, CSS, and JavaScript files to render the home page. Now let's say you visited the profile page in that website. So in that case, the browser will make another request to load the profile page, and the server will respond with the HTML, CSS, and JavaScript files to render that profile page, alright? This is a traditional way of how websites are loaded in the browser. Now let's say we're gonna do the same, but this time we're gonna visit a single page application website, alright? Let's see how this will be done. So we still have a browser and a server. This time we're gonna visit a website that's created with React, and it's a single page application, alright? So in that case, the browser will make a request to load the home page, and the server will respond with HTML, CSS, and JavaScript files. But this time, not only for the home page, it's for the entire website or the entire application, alright? So it's a bundle of HTML, CSS, and JavaScript files that will render the entire website, alright? So in that case, when the browser makes that request to load the home page, the server will do some computations or some operations to output that single page application bundle, alright? But the advantage of doing this is, now if you go to another page like the profile page, for example, the browser doesn't have to make a request to the server anymore, alright? It will load that page from that single page application bundle, alright? So here, the advantage is we reduce the number of requests to the server, alright? But the disadvantage is the additional computation that the server will initially make to create that bundle, that single page application bundle. But usually servers are or have good resources, good processing resources, so we don't have to usually worry about this. And also if the scale is huge, so we can have multiple servers serving one website, alright? So here the advantage is more beneficial for the efficiency of loading this website, alright? So that's the advantage of using React, or one of the advantages of using React over vanilla JavaScript, by creating a single page application and making the website more efficient and quicker. One other feature of React is a virtual DOM, alright? It's a lightweight in-memory representation of the actual DOM, alright? But first, what is the DOM? Alright, let's understand this. So any HTML code you write is first converted into a data structure, a tree data structure called DOM, or Document Object Model. This DOM, alright, which is a tree data structure, each node is an element in the HTML code you wrote, alright? So if you have, for example, the HTML tag, and inside the HTML tag you have some divs and lists, alright, buttons, all these elements are converted into nodes in that tree, alright? Then the browser loads that DOM, alright, and renders the page, alright? And any updates you make in the HTML page, like for example, if you use JavaScript to modify the text of a label or a paragraph, for example, in that case, this DOM object will be recreated, and the browser will have to load it again and re-render the HTML page, alright? And this operation is expensive. So let's say an example, let's say you have a list and you wanted to update one item in that list. In that case, when you do this update using JavaScript, the DOM will be updated, but in that case, the entire DOM will be updated. So the entire UI, or the entire, in that case, list will be updated and re-rendered, alright? But now let's see how this is done using React Virtual DOM. As you can see, React uses another lightweight representation of the DOM, which is called Virtual DOM. This is an in-memory data structure, and it's more efficient and quicker than the actual DOM, right? So whenever you do any update to the UI, in that case, React will create another virtual DOM object, alright, with the updated, or with the updates you have done, and it will compare this new updated virtual DOM with the already existing virtual DOM, right? And we'll try to find the minimal required changes to make that update, alright? This is called reconciliation. Then when it finds that minimal updates required, it will update the actual DOM, alright? And that's very efficient because you don't have to update the entire DOM anymore when you make an update to an element in the UI. Instead, you will update only that element, alright? For example, if we have again the list and we wanted to update one item from that list, in that case, the item is the only re-rendered or updated element in the UI, alright? Instead of updating the entire UI or the entire list. So that's the advantage of using virtual DOM with React. So now, to summarize, what is the advantage of using React over vanilla JavaScript? First, React lets you build reusable and modular UI components or pieces, and that makes the website or the application easier to maintain and scale. Also, the efficient updates to the HTML page using virtual DOM instead of the actual DOM, as we saw. Also, React has rich ecosystem and tools, so you will be able to find many libraries and many other tools and components that are created by other developers to do something specifically. You don't have to reinvent the wheels, and you can reuse these components, alright? And that makes the development easier and quicker and more efficient. Now we will install the required tools to be able to develop with React. First, we will download and install Node.js from the official Node.js website. You can find the URL in the resources or the description. And after the installation finishes, you can verify that everything is successfully installed by running those commands in the console. You should be able to see the version of Node and npm if the installation is successful. Then we will have to download a text editor. In this course, I am going to use Visual Studio Code, which is a very popular text editor, and you will find also the download link in the description or the resources. But if you have any other preferred editors, feel free to use them. And that's it. So now we are ready to start developing with React. Now let's create our first project in React. Open the command line and type nbx, then this create React app command, which is basically a tool that will set up a new React project with the necessary configuration automatically. Then space and the name of the project. So let's name it my first React app, and dashes between each word. And that's it. So after the project is created, let's open it in our text editor, which is Visual Studio Code, or any other text editor that you prefer. If you are using Visual Studio Code, you can click on the file, then open folder and select the project folder. Let's take a look at the React project structure. The public folder, which contains the website public assets, including index.html. Then the source folder, which includes all the React components and styles. So whenever we create a new component, it's going to be in this folder. Finally, package.json, which contains all the project dependencies. Now let's start the development server to see our new React application in action. To do that, we have to open the command line and go to the project folder, then type the following command. This will start the development server and automatically open your browser to localhost colon 3000, which is the address of the React application that we created. And now, as you can see on the browser, the React application is running. Now let's create our first component in React, which is a simple component that will print a welcome message to the user. As we learned, we add all the React components that we create in the source folder. So let's create a new file there and name it welcome.js. And this will be the file that will have the implementation of our component. Then let's create our function component. So we will type function, then the function name, which is actually the component name. So let's name it welcome. And as we learned, function components in React return JSX. So let's type return and add the JSX code of our component between two brackets. And let's create a div, then inside this div, an h2 header, then the text welcome. And that's it. So let's export the component, and now we want to render this component in our application, which is represented by the app component. So open app.js and import our new created welcome component. Then render it here after this component and save the file. Now to observe this change, we don't need to restart our development server. It automatically refreshes whenever any file is changed. So we can directly go to the browser and we will be able to see our new component rendered here. Now let's take a closer look at the code that was generated by the create react app command and understand what is a function component in React. So here is a project that we have created. Let's open app.js and we will be able to see this app function component, which renders the UI that we see in the browser when we started the development server. In React, a function component is a JavaScript function that returns JSX. And JSX, or JavaScript XML, is a syntax extension for JavaScript that allows us to write HTML-like code in JavaScript. This app function here is a function component that returns this JSX code. Finally, here in this line, we export the app function component. And to see where we import it, open index.js, which renders the root component of our React application. Here you can see the app function component rendered. As we learned, every React application is built on the foundation of React components. And for each React application, there is a main component, which is app component, alright? In the project, this is located in the source directory here in app.js. So as you can see, this is the app.js file. Here we have a function named app. This is the component, alright? So basically any component in React is a function component. That means it's basically a function, alright? And its name has to be defined in Pascal case, as you can see. So the first letter is capital for each word, right? So here we have only one word, so we have only one capital letter, the first one. If we have another word, right, so it has to also be in capital case, like that, for example, right? But for the app component, we have only one word, so only the first letter is in capital case. This is called Pascal case. So this function component is a modern way of using components in React, right? There is also a legacy way, and we will see that in the course. As you can see, the function actually returns an HTML code, right? This might be confusing. It's called JSX. So this is a syntax or an extension of the JavaScript that allows you to write HTML in the JavaScript code, right? And we will learn about this later in this course, alright? So the traditional way was to write the HTML code in HTML files and the JavaScript code in JavaScript files. But now with React components, you combine both the JavaScript and HTML code into one entity, which is React component, right? So here we have a function that returns an HTML code. Finally, we export that function, right? So this function is the main component of the React application, right? The app component. We can also say that this is the root component of the application. So any other components that we will create and render in this application have to be rendered here in this component, all right? And that's how the component is written. That's the syntax of creating a component in React, a function component more specifically. First, we import what we will use in this component. Here we used the app.css file and also logo.svg. Then we create the function component, right? This is a function that represents that component. Eventually, it has to return JSX, right? Which is basically an HTML code written within the JavaScript code, right? And we will understand more about this soon in another lecture. Finally, we export that component, all right? So now let's see how this component is rendered. Here in the project, in the source directory, let's go to index.js and check its code. As you can see, we have some imports here, like we imported React and React DOM. That React DOM component is responsible for providing some APIs to interact with the actual HTML DOM. We also imported index.css, and here we imported app component, alright? This is the main app component that we were discussing previously. And then we also imported this report web vitals. It's a utility tool that helps with doing some performance metrics like load time, for example. Then here in this code line, the React DOM.createRoot function will create a React root element, right, to render the React application. All right, in this case, it's document.getElement by ID root. So this is a div with ID root in the index.html file that will be rendered by the browser. So if we want to see that index.html file, you can find it in public here. So if we open that file, as you can see, this is the title and this is the body, and here we go. So this is the div, the root div, right? So the entire React application will be rendered here in this div, right? So let's go back to app.js, sorry, to index.js. So after we create the React root element, right, we store it here in this variable, then now we have a root element available. So we can use the render method to render the app, alright? Here we pass the app component, right, between or nested in another component called React.strict mode. This is just a development only component. It's used to catch some issues during development that may arise. So let's not care about it now. But here, as you can see, that's how we render a component in React, alright? So between angle brackets, we type the component name, alright? Similarly to how we create HTML elements, but we pass the component name, alright? And here we call this report web vitals method. This is an optional method if we want to use it to log some measurements about the performance. We can use it like here. For example, if we pass console.log, we will be able to see these measurements on the log, alright? We don't want this for now, so let's not care about it. So as you can see, this is auto-generated code, alright? When we create the React project, we don't have to manually create it ourselves, but of course it's important to understand. As we learned, all React components return JSX code, alright? And we have learned that JSX is JavaScript code combined with HTML code. But under the hood, React converts this JSX code into only JavaScript code, right? Let's see an example. So let's say we have this app component. As you can see, it's a function component that returns this JSX code. A simple div that displays another header with the text hello React. This JSX code will be converted by React into JavaScript code. So the output will be this code, alright? As you can see, the JSX code is converted into another JavaScript only code that returns React.createElement. So this is a function call to create element from React library. And as you can see, the function takes 3 arguments. The first argument is the element that we want to create, which is a div. And the second parameter is something called props. We will understand more about this later in the course. So here we don't pass any props, so we pass null. And the third parameter is the children element, alright? So here again we make another nested call to the create element function to create an h1 element, right? With the text hello React. So this JavaScript code is the output that React will create as a result of converting this JSX code. As you can see, it's much more concise and easy to write that JSX code than to write that JavaScript code, alright? Now let's see how can we write JavaScript code combined with HTML code. So here, for example, we have a constant, right, called title, and its value is React, right? And we wanted to display or use this constant in the HTML code in the JSX file, right? So how do we tell React that this is not HTML, this is JavaScript, this is a variable from JavaScript, for example, or a constant or whatever? So to tell React that, we add 2 curly braces, alright? So whatever we add between 2 curly braces, that means this is JavaScript code. So either JavaScript code or JavaScript constant, variable, whatever. It means this is a JavaScript block of code, alright? So for example, here we have this title, right? And when we mentioned it or when we used it here in the HTML block of code, we added 2 curly braces, as you can see, alright? That means use this as a JavaScript block of code, alright? In that case, we use the title constant. So that's how we write JavaScript inside the HTML code in the JSX syntax or in the JSX file, alright? Now let's add some styling to our welcome component. First, let's create a CSS file in the source folder. As we learned, the source folder contains the source code of the components and the styles as well. So we will create the CSS file here in the source folder. And let's name it welcome.css. Then let's add a class and name it welcome-heading. And this will be the class for styling the header in our welcome component. So let's change the color and the font size, and that's it. Now let's go back to the source code of our welcome component and import the CSS file. And then let's add the class name attribute to our header here and assign its value to the class name in the CSS file that we created. And as you can see, in JSX we use class name in camel case to set a CSS class for a component, unlike in HTML where we use the class attribute. And that's because JSX is not actually HTML code. Instead, it's an HTML-like code that's written in JavaScript code. Alright, so now let's open the browser after saving the file, and as you can see, the font color and the size are now changed. Now let's say we have a list of names and we want to display it in a React component. Let's see how we can do this in React. First, let's create a new component by creating a new file in the source directory and name it names.js. Then create our function component and name it names. And let's create a list of random names here before returning the JSX code of the component. Then now we want to return a JSX code that displays this list. To display a list in HTML, we use the UL tag. And inside it, for each item in the list, we use the li tag. So basically, we want to convert each item in the list that we have to an li tag, right? So we want to create a ul tag and inside it, create li tags for each item in the list that we have. In JavaScript, there is a function that iterates through each item in a list and converts it to something else, which is the map function. So we will use this function to convert the list items to li tags. So let's write names.map, then pass an arrow function that takes an item as an argument, and this function will return an li tag that displays this item. And now we want to display all the returned li tags or the list of the li tags that were returned by the map function here in the ul tag. So we will move this line here. But this still won't work because it's a JavaScript expression, not JSX code. So to insert a JavaScript expression in JSX, we put it between 2 curly brackets like this. Then finally, let's export the function component. And that's it. So now save the file and let's go to app.js and import this component and render it here. And let's remove this code to display the list only. Then save the file and go to the browser. As you can see, now the list is displayed. Before we start with this lecture, I hope you're enjoying the course so far and finding the content helpful and engaging. Your feedback is very important to me as it helps me understand what's working well and what can be improved. So if you have been enjoying the course and have found value in it, I would really appreciate if you could leave a review because your feedback helps other students discover this course and also allows me to continue creating high quality content for all of you. Thank you so much for your support and let's get started. Conditional rendering is a technique to render different UI elements or components based on certain conditions. For example, if the user is logged in, we want to display a greeting message. Otherwise, we print a message to ask the user to log in. So the condition here in this example, if the user is logged in, and based on that condition, we decide which component or element to render. That's what conditional rendering means. So let's open our React project and implement an example of conditional rendering. Let's start by creating a component that will print welcome back to the user if they are logged in. Otherwise, it will print please sign in. Let's create a new file in the source folder and name it greeting.js. Then let's create the component function here, and let's create a Boolean constant and name it is logged in, and this will indicate if the user is logged in or not. For now, let's hard code its value to true. And now we will conditionally render an element based on this condition. One way to do that in React is using an if statement. So let's type if is logged in, then return a header that displays welcome back. Else, that means the user is not logged in, so return a header that displays please sign in. And that's it. So finally, let's export the component and go to app.js and import it. And let's delete this code and render the component here. If we go to the browser now, we can see that the welcome back message is displayed because we set the is logged in constant, which is the render condition, to true. If we go back to the code and set it to false, and now go back to the browser again, we can see that please sign in message now is displayed. And that's conditional rendering. Another way to do conditional rendering in React is by using the conditional ternary operator. So instead of using if statements, we will let the component return a div, and inside this div we will add a JavaScript expression between two curly brackets and type is logged in, then question mark, then the header that displays the welcome back message, then column, then the header that displays please sign in. As you can see, this approach is more concise than using if statements, and it does the same thing. If we go to the browser now after saving the file, we can see that the please sign in message is printed. And now if we change the value of the is logged in constant to true, we will be able to see that now the welcome back message is printed instead. One more thing to talk about displaying lists in React. Let's continue on the previous example where we had an array of names and we displayed this array here in an unordered list, alright, in the HTML code from the JSX file. So inside the unordered list, we added this JavaScript block of code between two curly braces, and we called the map function from that array to map each element in the array with a list item, right? So in more details, this map function takes one argument, which is an anonymous function, and it will apply this function on each element in the array, right? Then it will return the result. So in this anonymous function, we return a list item, alright, and between curly braces we add the name, alright, which is the actual value of the element in the array, right? So the output of calling this map function is list items for each element in the array, alright? This code works fine, but there is a problem that won't show up now, alright? But later, if we do some updates to that array, it will show up. Let's see it. So for example, if we have this list, right, and we wanted to change the first name to name1 instead of name then number1, right? Now what will happen is that this new updated value will not update the already existing value. It will be appended to the top of the list, right? And the remaining elements will stay the same, as you can see, right? That's not what we want. So how do we fix this issue? We have to set a key, alright, for each element in this array, alright? Or in other words, in each element in the unordered list. Whenever we use the map function to display a list, we have to set a unique index or a unique key for that element, alright? That will help React when this element value is updated to identify the element and update it. Without the key, React will not be able to identify which element is updated, and it will add this new updated value to the current already existing elements as we saw, alright? So here is the updated code. As you can see, we pass now also the anonymous function to the map function, but we have now added this to the second argument, which is index. This represents the index of the element, alright, in the array. the index is of course unique for each element, alright? So we can set the key attribute here for each list item to that index, alright? This is because we have a list of strings, but if we have if we do an API call and we have a list of objects and each object has a unique ID, for example, then we can use this ID here as a key, right? The most important thing is it has to be unique. So now this fixes the issue. So if we now have this list and we wanted to update the first name to name 1 instead of the number 1, then React will be able to identify this element, alright, using the key, and will update this element, alright? So now we will have 3 elements and the first element is updated. Now let's see how to handle events in React. This event can be clicking on a button, typing in a text box, or submitting a form. Handling the event is executing some code when this event occurs. For example, to handle a button click event in HTML, we type onClick and assign it to the name of the function that will execute when the user clicks on the button. In React, the approach is almost the same, but the only difference is that we use camel case for the event name. Now let's open Visual Studio Code and see event handling in action. Here we have our project in Visual Studio Code, and let's go to the app component and add a button here. Then let's assign its onClick event to this function. Then let's declare this function here as an arrow function and just log a string that says button was clicked. And that's it. So let's test this code and go to the browser and let's display the console. Then click the button. As you can see, the string is printed on the console. And that's how a button click event is handled. Let's see how to handle form submissions in React. First, let's create a new component and name it myForm. Then let's create its function component and basically return a form that contains an input of type text and a submit button. Then let's configure the event handlers for each element in this form. First, onSubmit for the form, which is the event that it's triggered when we click on the submit button. Then the onChange event for the text input. Let's assign it to this function. And then let's start implementing those event handlers functions. So let's start with the handle submit function. We have to understand that the default behavior of a form when submitted is to send a request to the server, then reload the page. So we have to prevent this default action of reloading the page by calling the function prevent default in the event object. Otherwise, when we click on the button, it will refresh the page. Then let's log the message form submitted. And that's it for the handle submit function. Now let's implement the handle change function. Let's log the current text in the text input whenever the user types anything. This is done by logging event.target.value, which is the value of the input. Then finally, let's export this component and let's go to app.js and import it there. Then render it here in this header. Then save the file. And that's it. Now let's go to the browser and test our code. As you can see, when we click on the submit button, we observe form submitted text on the console. And whenever we type in the text box, we can see its value printed on the console. Props in React are used to pass data from a parent to child component. And they are read-only data, so the child component cannot change their values. Only the parent component can set their values. Let's go back to our previous example. What if we wanted to print the username in the welcome message? And we wanted to pass this username from the parent component, which is the app component, to the child component, which is the greeting component. In this case, we can use props and pass the username within the props from the parent component to the child component. You can imagine props as a container that the parent component sends to the child component, and it can send many things inside this container. So in our example, we will send the username inside the props container. Let's open app.js and add the username attribute that we want to pass to the greeting component. To do that, we simply type the attribute name that will be sent to the component within the props. In this case, we will name it username, then assign a string to it. Let's hard code any random value for now. Then let's modify the greeting component code to retrieve the username from the props. Props are simply passed as an object parameter to the function component. So to use it, we have to type props here. Then let's modify this code to print welcome, then the username. And that's it. So if we go to the browser now, we can see that the username is printed. Now, if we wanted to change the username, we can simply change it from the parent component like this. Once we save the file and open the browser, we will see that the new value is printed. Now it's time to apply the skills that we have gained and create our first project with React. It's going to be a simple personal profile card that displays a name, a short bio, and a profile picture. This is how it will look like after we finish its implementation. Alright, so let's get started. Let's begin by creating a new React project and name it profile card. After the project is created, let's start the development server. Then open the project in Visual Studio Code or your preferred text editor. Now let's start with the coding. Let's begin with the styling. So create a CSS file in the source directory and name it profilecard.css. Then add the styling code by copying it from the Git repository of the project, because CSS is not relevant in this course and not covered because we are focusing mainly on React. Then after you copy and paste the code, save the file and create a new JS file to implement our component and name it profilecard.js. First, import the CSS file, then create the function component. This component will return a div, which is the actual profile card. So we will set its class name attribute to profile-card, which is the associated CSS class for the profile card. Then in this div, an image whose source is passed through the props in a variable called image URL. So let's add it here between two curly brackets. Then an h2 header that will display the name, which is also in the props in a variable called name. Then finally, a paragraph that will contain the bio, which is in the props in a variable called bio. And that's it. So let's export the component. And now let's go to app.js and import it. And let's remove all this code and render the profile component here. And let's pass the props to this component. So the first prop is the name. Let's type a random name here and the same for the bio. And for the photo, let's use a random free image from the internet. So you can copy this URL from the Git repository as well, or you can use any other image that you prefer. And that's it. So now save the file and go to the browser. And here is our cool personal profile card component. Alright, now we are going to talk about a very important topic in React, which is the props validation. So what exactly is props validation? Props validation is ensuring that props received are of the correct type and have the expected format. And this is very important because it can help with preventing bugs and ensure that the components receive the correct type and shape of the data or the props they are expecting. And also it helps with the documentation because it acts as a form of self-documenting code, and this helps other developers understand what props are required and their types. And also it's helpful as a development tool because it provides helpful warnings during development to catch the issues early. Let's take a look at an example to understand it better. So as you can see here, we have a user profile component which receives the username and the age and the hobbies via the props. Now, if we want to do a props validation here, we have to use the prop types library, and we will see in a moment how to install it and use it in our project. So we imported it here, and this is how we use it. As you can see here, after the component definition, we specify the prop types property on the component, which is the user profile, and we assign it to an object that contains each prop as a key, and the value is the type of this prop. For example, here the name is string and is required, and same for the edges, but the type here is number, and for the hobbies it's an array of string and also is required. So if any of these props are passed in the wrong type or are missing, React will log a warning in the console during development. We can also set a default value for a prop, as you can see here, we have the same component. And let's say we wanted to set a default value for the hobbies. So we want to initialize it to an empty array. That's how we do it. So we set the default props property of the component to an object that contains the props as a key, and the value is the default values that we want to assign to each prop. And we can also create custom validation for our props in case of complex scenarios. Like for example, here we are forcing the age to be more than 0. So in this case, we specify the prop types property of the component to an object that contains the props as keys, and the value is a function that validates this prop. And it takes 3 arguments, as you can see, the props and the prop name and the component name. So here we check in this if statement, if this prop, which is the age, is less than 0, we return this error that says invalid prop and age cannot be negative. Alright, now let's see the props validation in action. So we're gonna modify the profile card project that we implemented previously to add props validation to it. So here is the project, and we have this profile card component which receives 3 props, the image URL and the name and the bio. So we are going to validate those 3 props. But first we have to install the prop types library. So let's go to the command line and install it. So here I am at the project folder, and I'm going to type npm install, then prop dash types. Hit enter. Alright, and after it's installed, now we are ready to use it. So now let's start the development server and go back to Visual Studio Code to start our development. So first we are going to import the prop types class from the prop types library. Alright, and now after the definition of the component, we're gonna type the component name, then dot prop types, and assign it to an object. As we learned, the keys are the prop names, so we're gonna type the first prop, which is the image URL, and the value, which is the type of this prop. So we're gonna type prop types dot string, because the image URL is a string, and also it cannot be null, so we're gonna type is required as well. Alright, and that's it for this image URL. So we're gonna go for the name and also do the same. So it's gonna also be a string and is required. And the bio, so it's also gonna be a string and also is required. Alright, now let's go to the browser. We can see here that the component is rendered with no issues. So to be able to see any warning related to props validation, we have to check the browser console. So if we open the console now, we can see nothing. Now let's go back to Visual Studio Code, and here let's go to app.js and, for example, delete the name prop and save the file and go back to the browser. As you can see here on the console, there is a warning, says that failed prop type. The prop name is marked as required in profile card, but its value is undefined. So since we set the is required value of the prop name, this warning is triggered because we didn't pass this prop. Alright, so now let's go back to Visual Studio Code and undo this and keep the name prop, but let's pass an integer. For example, let's pass 5 like this. Alright, so now if we go to the browser, we will see another warning, says that failed prop type, invalid prop name of type number supplied to profile card, and the expected type is string. Right, so because we passed a different type than the expected type, now this warning appears. So you see how this is helpful to prevent any bugs or issues before deploying the application to production. And also it's a kind of documentation for developers. When they see the code like this, they understand what are the expected props and what are the expected types of each prop. State is a built-in object that allows React components to store dynamic data and render it when the data changes. For example, let's say you have a login form which contains username and password inputs. You want to store the values of those inputs whenever the user types their username and password, right? In React, you can create a state variable for the username and another one for the password, and whenever the user changes their values, those variables will also get updated. Let's start implementing this use case in React to understand states. First, let's create a React project and name it user-login. Then After the project is created, let's start the development server and open the project in Visual Studio Code. And let's begin by creating a new component and name it login form. Then import the useState function from React, which is the function that we will use later to create the state variables. This component will simply just return a div that contains two text inputs, one for the username and one for the password, and a login button. So we want to keep track of the values of those inputs and store them in variables, right? For that, we will use React state. So let's start with the username. To create a state for the username, we have to use the useState function from React and pass the initial value. For this case, we will pass an empty string. And the useState function returns an array of two elements. The first element is the actual variable that will represent this state. And the second element is a function that we will use to change the value of this state. So whenever we update the value of the state, we will use this function. We can, for example, assign username to a new value like this, because this variable is a read-only variable. So whenever we want to update the state value from the code, we have to use this function. Then let's do the same thing for the password state. And now let's update the values of the inputs to bind them to those state variables. And also update the onChange event to update the state whenever the value of the inputs changes. So we will use an arrow function and use the states setter methods to update the values like this. Finally, we will create the event handler for the button click event and display an alert that says welcome plus the username. And that's it. So now export the component and save the file. And let's go to app.js and import it and render it here. Then save the file and let's go to the browser. Here is our form. So let's type any random username and password and click on the button. As you can see, the welcome message, including the username, is displayed via the alert. So this is how we can create and use states in React. Those states could be data that we retrieve from an API, for example, and use in our component. And we will see more complex use cases later in the course. A very common mistake that new React developers make is using a stale state. So what exactly is a stale state? A stale state in React is a situation where the component refers to an outdated version of the state. This means that in our React component code, we update the state value, but the component still uses an outdated version and does not acknowledge this update. And this can happen due to many reasons. For example, asynchronous operations. So when you perform asynchronous operations like API calls or timeouts and try to update the state based on the previous state. Like for example, if you have a counter and you try to update its value by adding 1 to the previous value. So in this case, the problem occurs, and we will see in more details in a moment how does this happen. Another reason is multiple state updates. So when there are multiple state updates that depend on the previous state as well, and those updates do not consider the latest version of the state. So let's see a code example of using a stale state in React. As you can see here in this example, we have this account state, which is initially set to 0, and this component renders two elements, this header that displays the count value, and this button, which is the increment button. When the user clicks on this button, this event is invoked, and in this event we use the setTimeout function to create a delay of 1 second, and after this delay we increase the count value to count plus 1. So we add 1 or increment the count by 1. As you can see here, this is a stale state case, because let's say the user clicks on the increment button 5 times in less than 1 second. So during that 1 second delay, this event invoked 5 times. And since the count is captured in the closure of the setTimeout callback, the value of the count state here will not change during that 1 second delay. So when the user clicks on the increment button 5 times, the count value is still 0. So after the delay finishes, the count value will be 1 instead of 5. Here we call this count state a stale state, because all the callbacks of the setTimeout function will reference the same stale state of count, which is 0, even though it's updated multiple times. So whenever we have an asynchronous code like this and we depend on a previous value of the state when we update the state, we have to consider a specific implementation to avoid this stale state, which we will see right now. So this is how we fix this issue, right? This is the same example, but we fixed the stale state issue here. So here in the setCount function, which updates the state value, instead of passing a direct value like count +1 as we did previously, we pass a function that takes the previous state as an argument, which is here the prevCount argument, and then returns the updated state, which is prevCount +1. So this approach fixes this issue of using a stale state. So now if the user clicks on the increment button 5 times during the first 1 second, after the delay of 1 second finishes, the value of the count will be 5, not 1, alright? And we will see this live in a coding example now. Alright, so here in this example project, we have the same code that we saw previously in the example of the stale state. So here we have this app component and we have this count state, which initially set to 0. And in this handle increment function, we set a timeout delay of 1 second. And in this callback of the timeout, we increment the count using the setCount function by passing the previous value of the count and adding 1 to it, as you can see. Alright, so if we go to the browser and test this, so now I'm going to click on the increment button 3 times in less than 1 second, and let's see the value of the count state. As you can see, the value is 1, even though it should be 3 because I clicked on the increment button 3 times. Alright, so here you can see the issue of using stale states in React. Now let's go back to the code and fix this issue by using an arrow function here, or passing an arrow function to the setCount function instead of the direct value like this. So here, let's remove that and type prevCount. So this is one argument that is passed to the arrow function, which is the previous value of the current count state. Alright, and here we're gonna update the count state to prevCount +1. And that's it. Simply this fixes the issue. Let's confirm by going to the browser. And now again, I'm going to click on the increment button 3 times in less than 1 second. And let's see now the value of the count. Now, as you can see, the value is 3. So it's not 1 as the previous case when we used a stale state. Alright, so that's it. So whenever you use a state, or whenever you update a state value in an asynchronous function, you have to always use this approach in the setter function. So you have to use an arrow function and pass an argument, which is the previous value of this state to this arrow function. And in the body of this arrow function, you have to do your updates, like incrementing or whatever updates that you want to do. So when the update of this state depends on the previous value of this state, and this is done in an asynchronous function, you have to do it using this arrow function. Now we are going to apply all the knowledge that we gained so far by creating this task manager application with React. We can add tasks like this and mark tasks as done, and also delete tasks. So let's get started. Let's start by creating a new project and name it task-manager and start the development server after the project is created. Then let's open the project in our text editor and create the first component, which is the task list component. So we create a new file and name it tasklist.js, and inside it let's create the function component. This component will render a list using the UL tag, and each item in the list is a task. So the tasks will be passed to this component from the parent component, which is the app component within the props. And we will use a conditional rendering here. So we will check if tasks.length equal 0, then we will display no tasks. Otherwise, we will display the tasks. So we will convert each task in the tasks list to an li tag using the JavaScript map function. Each item in the list will contain a checkbox that displays if the task is completed or not, and also can mark the task as completed or not completed. So we will assign the checked attribute here to task.completed, which is a boolean that indicates if the task is completed or not. Then we will display the text of the task here. Then we will display a button to delete the task. And don't worry about event handling for now. We will add all the event handlers later. Then finally, let's export the component. Now let's create the component, which consists of the task name input and the add task button. And this will be used to add a new task. Let's start by creating a new file and name it task input.js. Then let's create the function component. And this component will basically return a div that consists of a text input to enter the task name and the button to add the task. So let's create them here and then finally export the component. Now let's modify the app component, because this will be the parent component that will render the task list and the task input components. First, let's import the useState function from React. Then import the task list and the task input components. And let's start deleting all the code in the app component and create two states. The first one is for the list of tasks, and the second one for the new task that is being added by the user via the task input component. This component will render a header, which is the title of the application, then the task input component, then the task list component. And we will pass the tasks state to the task list component via props like this. And that's it. Now if we go to the browser, we will be able to see the components rendered. Of course, they don't look nice yet, but we will still add some styling to make it look nicer. Alright, now it's time to add the event handling to our application. We will implement all the event handlers in the app component and pass them to the children component, which are task input and task list components via props. So let's start by creating the event handler for adding a new task. The new task is represented by the new task state in our code. So first we will check if new task.trim equals to empty string, we will return. Otherwise, we will add this new task to the tasks list using the setTasks method. What we will do here is we will use the spread operator from JavaScript to create a new array that contains all the elements of the array of the tasks array plus the object of the new task, which consists of the text of the task and the completed flag, which is initially false. Alright, so now we have a complete new array with all the tasks that were there before plus the new task. Finally, we will use the setNewTask method to set the new task to empty string after adding it. Now let's pass this event handler to the task input component along with the setNewTask method, because we will use it to update the new task value whenever the user types in the text input in the component. And also let's pass the new task state itself. Then let's go to the task input component. Let's update the value attribute of the input to the new task state and the onChange handler to an arrow function that will call the setNewTask method to update the new task value with the current input value, and update the event handler of the add task button and call the event handler passed via the props. Alright, now let's go back to the app component and handle the checkbox toggle event that toggles the completion state of a task. It takes the index of the task as an argument, then it creates a new updated list of the tasks using the map function with the completed flag of the updated task toggled by checking if the counter I equals to the index of the current task and the current iteration. Then it will copy all the members of the task object into a new object with the spread operator and update the completed flag to its opposite value. So simply it toggles the value of the completed flag. Then finally update the tasks via the setTasks method. Then let's implement the delete task event handler. We will use the filter method in JavaScript that will create a new array with all the elements that pass the test implemented here in this function. So our test is going to be if index of the current task does not equal the index of the task to be deleted. So all the elements will be copied to a new array except the element at this index. We used underscore for the first parameter here, which is the actual task object, because we are not going to use it. Finally, let's use the setTasks method to update the task's state variable. And then let's pass those handlers to the task list component via props. And let's open task list component and add the event handling here. First, let's handle the toggle event. So we will configure the onChange event of the checkbox to call the handle toggle complete function or handler method passed via the props from the app component. And the same for the delete button. For the onClick event, it will call the handle delete task function. Let's also add the missing return keyword here and surround this JSX code with brackets. Now if we go to the browser and test the functionality of our application, we can see that everything is working as expected, but the application doesn't look so nice, right? So next we will add some styling to make it look nicer. Alright, let's start styling our application. So let's open app.css and delete all the code here. Then let's add some styles to the main application or the main app component div, whose class is app. So let's configure the max width and the margin and give it some padding. And let's also set the background color to a light gray color and make the corners of the app container div rounded by setting border radius to 10 pixels. And let's also add some shadow. Then let's style the h1 header that displays the title of the application. Let's change its color to dark gray and configure text align to center to make the title in the center of the div. And also let's style the UL tag by setting list style to none, because this is the list of the tasks that we have and we want to remove the bullet points from the list. And also let's set the padding and the margin to 0. Then let's style the button by giving some padding and changing the font size and making the corners of the button rounded. Then changing the cursor to pointer when hovering over the button, and also adding a smooth transition for the background color change using the transition attribute. And let's set the text color to white and the background color to blue, and add a style for the button hover event to darken the button when hovered. So this is for the add task button. For the delete button, we want its color to be red, so we will configure this here and also darken the button background color on hover event. Finally, let's style the list item. So let's use display flex to display or align items horizontally. Then use align items and set it to center to vertically center the list items. And let's also add some padding and a light gray border. Then make the corners round and set the background color to white and add some space below each item using margin bottom. Then finally add a shadow to each item using box shadow. And we also want a line above the task whenever we mark it as completed. So let's go to the task list component and add a linear style there. So in React, we can add the style attribute and assign it to an object. And in this object, each CSS property is written in camel case. So in our case, we will set the text decoration attribute to line through if the task is completed and none otherwise. Now let's go to the browser and take a look. As you can see, it looks nice, but let's also remove this default border from the button and give it some left margin. And also let's increase the width of the text input and give it some padding. And let's go back to the browser after saving the file. And here we go. So now the application looks much nicer than before. And you can also add more styling if you want, of course. And now let's go through the functionalities. So as you can see, we can add tasks, mark them as done, delete them, and also toggle the completed status. React hooks are special functions that let you use different React features from your components. They usually start with the word use, and we already used the state hook before in the state lecture. There are many other hooks other than the state hook, such as use context and use reducer, and we will learn each of them in detail in this section. Contexts let a component receive information from distant parents without passing it as props. For example, let's say we have this application that contains the app component, which renders this parent component and passes a user object to it via props. And this parent component renders another child component and also passes this user object to it within the props. Do you see the pattern here? So if this child component renders another component that uses the user object as well, it will have to pass it via the props, and so on. And this approach can be hard to manage, especially if the application is huge and has many components. Here come contexts into play. With contexts, all the components can share data without the need to keep passing them via props. Let's take a look at this example that uses props to pass data and change it to use contexts instead. Alright, so here is our application, and this is the app component. This component renders this parent component and passes this user object that it created here via the props. Let's go to the parent component and check its code. So here's the parent component. It renders this child component and passes this user object via props as well. Now let's go to the child component code, and here we go. So this is the child component. It receives this user object from the props and renders the username and the age here. If we launch this application, we will see that this is how it looks like. So this is rendered by the app component, this is rendered by the parent component, this is rendered by child component, and then finally the child component renders this name and the age of the user, which is passed from the app and the parent components via props. So now let's change this approach and use context and see how this will be a better approach. And especially using contexts is better when the application has too many components. So imagine if you have many other children components and you have to pass the data using props. Of course, this is not easy to manage. Alright, so let's go back to the code. And to start using contexts in React, we have to import two functions from React. So the first one is a function that we will use to create the context. So it's called create context. And the second one is the function we will use to use the context that we created. Alright, so it's called use context. Then let's create the context that will hold the user object. So let's start creating a const and call it user context and assign it to the create context function. So this create context function will create the context and assign it to this constant. And as you notice, we created the user context here outside the function component because contexts are intended to be static and they should not change during the lifecycle of the application. So we cannot create it in the function component because of that. Alright, so now we want to assign this context a value, right? Which is this user object. And to do that, we will have to go to the JSX code here of the app component and use a tag called user context. So basically this is the context that we created here. Then type dot provider, right? And provide the value of this context. In this case, it's gonna be the user object. And that's it. Let's close the tag. So now if we move this code here and wrap it with this user context tag, all the components that are rendered here or rendered by any component that's rendered here or by any children of any component that rendered here will have access to this context. So you see how this is better and easier to manage than passing props. Now we can use this context in the parent component and use it in the child component that's rendered by the parent component as well. So let's see how can we use the context in the child component. Let's go to the child component code and let's first go to the parent component code and delete this props here and don't pass the user via the props to the child component, and go to the child component and also delete the props here. And now we will change this to use the context instead of props. So as I said, we will use this use context function to use the context. So we don't need to import it here. Let's delete it and import it in the child component. Alright. And now let's go to the function component and create a user object and assign it to use context and pass. We have to pass here which context that we want to use, right? So we want to use the user context, right? But this child component is in a separate file and will not have access to this constant user context, right? So it's better if we create a separate file for this context. So let's create a new file and call it user context.js, and here we will simply just copy this code and then let's finally export it. Then let's go back to the child component and import it here and then pass it to the use context method. And that's it. So now we are ready to use this object. As you can see, we rendered it here directly using the user object that we got from the context. So now let's go back to app.js and let's delete this user attribute here, we don't need to pass it to the parent component via props. So now if we go to the browser, we can see that the username and the age are displayed here by the child component. Reducers in React are similar to states, but they are better suited for more complex state logic. For example, we have this counter component here, which creates this count state and displays it here, and there are two buttons, one to increment the state and one to decrement the state. Here is how it looks like. So this is the count state, and we can increment it with this button and decrement it with this button. Now let's change the implementation of this component to use reducers instead of states and discuss what is the difference. So first thing, we have to import the use reducer hook from React to create the reducer. Then we will have to create the initial state object. So instead of creating only one variable that holds this state count, we will create an object that represents the initial state that contains all the state variables. So let's create it here and name it initial state. And this will be an object that consists of the count here, as you can see. So let's delete this, we don't need this anymore. Alright, so now let's use the use reducer hook to create the reducer. Before that, let's change this to use camel case instead. This was a mistake. And this is how we use the use reducer hook. So the use reducer hook takes two arguments. The first argument is the reducer function that we will implement in a moment, and the second argument is the initial state here that we created, which represents the default values or the initial values of the state. And it returns an array of two elements. The first one is the current state. So we don't use this initial state anymore. We will always use this state variable. This initial state is only to set the initial values of the state. And we will use this dispatch method, which is returned as the second element in the array that is returned by the use reducer hook, to update the state. So we will use this to do any action or modification on the state, and we will see later in more details how we will use it. First, let's start implementing the reducer function and understand what is its responsibility. So the reducer function takes two arguments, the current state and the action to perform on the state. And as you can see, this approach is better than using states, especially if we have many states and many actions to perform on them, because all the logic will be in one place, which is in this reducer function. So instead of scattering the logic of updating the states in different places, we have all of them here in one function. So in our example here, we have this count state and we have two actions, increment and decrement. So let's start implementing that here in the reducer function. So we will use a switch case here and check the action.type. This action.type is a string that represents the current action. So in our case, we have two actions, increment. In this case, we will update the count and increment it by 1, right? So we will simply return the updated state. Alright, so this reducer function returns or performs an action and returns the entire updated state. So in the increment case, we will return, here's the state object, and the count will be state.count plus 1. Alright, so as I said, we use the state variable here from the use reducer hook to access the current state. Alright, we don't use this initial state anymore. So we used it to access the count in the current state and increment it by 1 and return an entire new updated state object here. Alright, let's add another case, which is the decrement case. We're gonna do the same thing, but we will decrement the count in this case. Alright, otherwise, if there's an action that is not known, we will simply just return the current state. We will not do any changes. Alright, now we are ready. So this is the reducer function and the logic is implemented here to handle the actions and update the state. Now let's update our JSX code to use this reducer. So here we will use the state.count instead of count, and we don't need to do this anymore. We don't need to handle any logic here anymore. So we just need to fire this action, right? To increment and decrement. How do we do this? We use the dispatch function. So we use the dispatch function and pass the action that we want to do. So the action here is an object, right? And it consists of this type member, which is a string that represents the action that we want to do. So we will have to pass this action object here to the dispatch function and set the type to the action that we want to do. So here it's increment, and let's do the same for the decrement button and change the action to decrement. Alright, and that's it. We are ready to test our application now. So let's go to the browser and let's click on increment. As you can see, the functionality is working fine and as expected. So as you can see, this is how reducers are better than states when we have complex states. Like this example is simple, but it just explains the advantages of using reducers than states. We have a centralized state management here, as you can see in this reducer function. For example, let's say if we have here in this example other actions like incrementing by 2, incrementing by 4, and so on. So we don't have to implement all these actions in different places. We have only a centralized one place here to implement the logic of changing the state, and this helps with scalability of the application. Now we will apply the knowledge and the skills that we gained so far by modifying the task manager project that we created before to use reducers and contexts instead of states. Right, so let's go to the code. As you can see, we have this tasks state, and we do some actions on this state by adding a task or toggling the complete status of a task or deleting a task. So we will remove this and we will create a reducer and encapsulate all that logic in this reducer. But we still want to share this reducer and the state with the app component and the task input and the task list components, right? So we're gonna create this reducer and create a context for it, right? So that all the components can have access to this reducer via this context. Let's start creating this context by creating a new file and name it task context. Then let's create the context. So we will name it task context and assign it to the create context method. And we're gonna need to use this context in another components, right? So let's export it. Then let's create the provider component for this context. This component will wrap all the other components to give them access to this context. So we're gonna also export this and let's name it task provider, and it will take the children or an object that contains the children via the props. This object is a props, but we destructured here the props objects to get the children. And let's implement the function component here. So first we will create the reducer and assign the value of this context to this reducer, right? So that all the components can use this reducer to access the state and the dispatch function to do some actions on the state. So as we learn, the useReducer function returns two elements in an array. The first one is the current state, and the second one is the dispatch function that's used to perform actions on this state. Alright, and the useReducer takes two arguments. The first one is the reducer function, which we will implement later. We will call it task reducer, and the initial state object. Alright, so we have to create this initial state object as well, but we will create it later in a separate file. Now let's return the JSX code for this provider component. As we learned, we use this tag, the task context. So we use the context here, the constant that we created, and dot provider, and set the value attribute to the value of the context. In this case, we're gonna use the state and the dispatch. So we are gonna assign the value to an object that contains the state and the dispatch function. Then what we want to do here is we want to render the children. So this children is the components to be rendered or wrapped by this provider. So we will simply just put the children here, and that's it. So now all the components rendered or wrapped by this provider will have access to the state and the dispatch, so that they can read from the state or do some actions using the dispatch function. And this state will contain the tasks or the list of the tasks. So now we have two missing or pending tasks that we have to do. First, to implement the task reducer and create the initial state object. So let's start with the task reducer. We're gonna create it in a separate file and also initialize the state there. So let's create a new file and name it task reducer.js. And let's start exporting and creating the initial state object. So it will simply just contain the tasks or the tasks list. We're gonna initialize it with an empty list. Alright, then let's export and create the task reducer function itself. As we learned, it takes two arguments, the state and the action. So we're gonna create the switch case and check action.type, and the first case or action is the add task. Alright, this is to add a new task. So what we will do here is we're gonna create a new array or list that contains the already existing tasks with the new tasks that's being created. So we're gonna return an object and use the spread operator here to return the current state, so the current tasks, and update the tasks here to add the new task. So we're gonna use the spread operator as well to add all the already existing tasks to this array and add a new task object. So first we have two attributes for the task, the text and the completed flag. How do we pass them via the reducer? We have the action, right? We have the action type, but how do we know the data or the attributes of the new task? We can send them with the action object as well. So this action is an object, right? It contains this type attribute, and it also contains another attribute called payload. So we can send data via this payload. So we're gonna use action.payload to get the text of the new task, and we're gonna set the complete or completed flag false initially. Alright, and that's it. So this is for the add task action. Let's implement the toggle task action. So this will toggle the completed flag of the task. So as we did previously, we're going to return an object that contains all the current state members and update the tasks. Then we're going to use the map function here to go through the tasks and check if the task at the current iteration is the task that we are looking for. We're gonna toggle its completed flag. So how do we know which task are we looking for? By the index of the task in the array, and we will pass this index via the action payload. So we're gonna use the state.tasks.map function, and this map function will take an arrow function that takes two arguments, the task and the index. And we're gonna check here, simply we're gonna return and check if index equals to action.payload. That means this is the task that we want to toggle its flag. So in this case, we're gonna return the object of this task. So we're gonna use the spread operator and update the completed flag to the complement of the current completed flag. Otherwise, we're gonna just return the task without modifying anything. the IDE is complaining because we didn't add the default state. So let's just add it now to remove this warning. For any other action that's not handled here, we're gonna just return the state without any modifications. Then let's handle the last action, which is the remove task action. So we're gonna simply here return also an object with all the current state elements and update the tasks. So we're gonna use a filter method as we did before to filter or create a new array without the element that we are removing. Alright, so we're gonna use state.tasks.filter, and the index is also passed through the action payload. So here we're gonna return index does not equal to action.payload. Alright, so we're gonna return a list of all the elements in the task array except the element that has the same index as the index passed through the payload of the action. And that's it. So we have the reducer function now ready and the initial state object as well. So let's go back to the task context and import them. And that's it. So now the task provider is ready to be used. So let's go to the app.js and remove this code. So we don't need it anymore as we implemented all this logic in the task reducer. We also don't want to pass those event handlers to the components, so let's remove this. And now we want to wrap those components with a context, right? Or the context provider component that we created here. So let's import it and let's wrap the components by this component here, like this. Alright, so now the task input and the task list have access to all the data from this task provider, which is the state and the dispatch function to update the state. So previously we had this new task state which was used to track the value of the input in this component, right? In the task input component. So we're gonna keep using this as a separate state. We're not gonna use reducers here because this is local to this component, right? We should not share it with any other component, or other components don't need to know about it. So for this we're gonna use a state. We don't have to use reducers for all the scenarios. It depends on the scenario. So we still have to use states for some scenarios like this, right? So instead of passing this from the app component, we're gonna create the state here for the new task and update this onChange event handler to use the set new task method that we created locally here, and also the value of the input to use the state variable here. And let's import the use state hook from React, and let's also import the use context. And now we are going to import the task context as well, because this is the context that we will use and pass to the use context method. So what do we need from this context? The dispatch function, right? To update or do the action of adding new task. So let's create this here. We're gonna use the dispatch function from the context. So we're gonna destruct the object and retrieve only the dispatch function. And we're gonna assign it to the use context method and pass the task context as an argument. Alright? So now we have the dispatch function. So let's implement the event handler to handle the add task event here. So we're gonna assign it to an arrow function, and we're gonna check if new task the trim. That means we don't have an empty string here in the new task. So in this case we're gonna call the dispatch function, and we're gonna pass the action object. First we will set the type to add task, and we're gonna pass the payload, which is the new task, right? Which is the text of the new task, which is tracked by the new task state here. And that's it. Finally, let's set the new task to an empty string after adding it. That's it, simply. That's the event handler for handling adding tasks. Now let's go to the task list and update its code. So we will also import the use context and the task context. And here we're gonna need to use the task context. And in this case, we're gonna need to use both the state and the dispatch functions. So we're gonna destruct the object and use the dispatch and the state and assign it to the use context, task context as an argument. Then let's destructure the tasks from the state. Alright. And let's modify the code here in the JSX code to use the tasks instead of props.tasks. Let's also remove the props from the event handlers here because we will implement them locally. Alright. So now the remaining step is to modify this code. So we want to modify the event handling here and not use the old code. So simply we're gonna call the dispatch function to toggle. First we are implementing the toggle action here to toggle the completed flag of the task. So we're gonna call the dispatch function and pass the action object. First the type is toggle task and the payload is the index of the task. Let's copy this code, and here we're gonna also call the dispatch function, but the action type is remove task. Alright, and that's it. So now we are ready to test our application. Let's go to the browser and let's try to add a new task. As you can see, we can add a new task, we can mark it as completed, unmark it, delete it, and here we go. So we have the same functionalities, the same application, but now we used reducers and context to make the code more organized and more modular. The useRef hook in React lets you store values that don't require re-rendering of the component, unlike the useState hook, as we learned, which causes the component to re-render whenever we update the state value. useRef doesn't re-render the component, so you can use it for storing any data that is not displayed on the web page, for example, so no need to re-render the component if this data changes. Let's say we have this simple input of type text component, and whenever we want to render it and we want to automatically focus this component or this input whenever the page loads. We will not be able to do this with state, because if we referenced this input with a state, whenever we focus this input, it will re-render, and this is not necessary. So we want to focus this input without re-rendering it. For this, we will use the useRef hook. Let's see how. First, let's import the useEffect and the useRef hooks. Then let's create a ref to reference this input and assign it to the useRef hook here and initially set its value to null. Then let's use the ref attribute in the input to reference this input via this ref that we just created. Alright, and now we want to update or focus this input whenever the component is already rendered. How do we make sure that the component is already rendered? We can use the useEffect hook for this, because this executes only after rendering the component. So we will write the code here in the useEffect hook. We're gonna type input ref, and the useRef hook returns an object which is current, and this represents the current ref. So we can access it using this current object. Then we are going to call focus to focus the input, and we want this to execute only once after rendering, so we're gonna pass an empty array as a dependency list to the useEffect hook, and that's it. So now if we go to the browser, we can see that right after we open the project, the text box or the input is focused. And that's an example of why do we need to use the useRef hook for some use cases. useMemo is a React hook that allows you to memoize or cache the result of a computation, so that it's only recalculated when one of its dependencies changes. So let's say there is a function that performs an expensive computation. It gets executed once, and the useMemo hook caches the returned values so that when it's invoked again, it returns the cached values instead of performing this expensive computation. Let's see an example. So in this project, we have this app component that contains two states, one state for count and one state for to-do tasks. And there is this expensive calculation function that takes one argument, which is the count, and returns another number. And this function takes time to execute and does an expensive calculation. Let's take a look at it. So it basically loops a lot of times and adds 1 in each iteration to the input number, then returns it. As you can see here, this function will get executed in each render of this component. Alright, so let's take a look at the JSX code of this component. We have an add to do button here that adds one to do task to the to do's list, and the to do's list are displayed here. So when we click on this button, it calls this add to do function that calls the set to do's function, which will cause the component to re-render and will cause this function to get executed, even though it does not have to get executed, right? Because we only updated the to do list, we didn't update the count. And we have here another button for incrementing the count, which will call this increment function, which updates the count state. And here, that's fine, we need to call this function again because the count changed. So we don't want this function to get executed in each render. We want it to get executed only if we update the count, right? Not when we update the to-do list. Let's go to the browser to understand this application better. So we have here my to-dos, and we can add a to-do task. You see, when I add a new to-do task, it takes some time, right? Because this expensive calculation is executed in each render. And when I click on add count, it also takes some time, but that's okay because the count is updated and we expect this expensive calculation to be executed again. But we don't want it to execute when we add a new to-do task, right? So for that, we are going to use the useMemo hook. Simply, we're gonna import it first, and all what we have to do is wrap this call with the useMemo hook, right? So we're gonna wrap it like this, and this is the first parameter. So it's an arrow function, and inside it we will call the expensive calculation function. And the second argument is the list of dependencies. So we want this function to execute only when the count is updated. Alright, so now when we call the set to do's function to update the to do's state, and the component will re-render, this function will not execute. So this will enhance the performance significantly. If we go back to the browser and click on add to do, now you see how quick it is compared to previously. But when we add a new count, it takes time because the expensive calculation function is executed. Custom hooks can be used to encapsulate component logic that needs to be used by multiple components. They start with the prefix use and can return anything you need. So state values, computed values, or even function. They are an excellent way to dry or don't repeat yourself up your code by extracting common logic that can be shared between components. Let's take a look at this example. Here in this project, we have this application component that contains this data state, and there is a side effect in which it uses the fetch method to get some data from an API. Here I'm using our example data from JSON placeholder, and once we get the data from API, we use the setData function to update the data state. Then we display this data here. In the browser, this is how it looks like, just a list of some data. What if we want to use this code here? What if we want to fetch this data from the same API in multiple other components? We will have to do the same thing. We will have to write the same exact code, right? So why don't we encapsulate this logic somewhere and use it without the need to write all this code each time we want to use it? For that, we will use a custom hook. So let's create a new file, and we're gonna call this custom hook useFetch. And here we're gonna import the use state and the useEffect hooks from React. Then we're gonna create the custom hook. So it starts with the use word here in small case, then whatever you want to type. So in this case, we're gonna type fetch and assign it to an arrow function. And basically what we will do here is we're gonna copy this code or cut this code and paste it here. Alright, and then finally return this data. And that's it. So let's export this custom hook. And we are ready to use it. I have a typo here. Now let's go to the app component and use this custom hook here. So let's import it first. And here we're gonna create a new constant, which is the data, and assign it to the useFetch custom hook. And that's it. So now we encapsulated this logic of retrieving the data from the API in this custom hook, and we can use it everywhere in our project. If we go to the browser now, we can see the same result. And now let's improve this example. We can make this more generic. Instead of only calling this function, we can pass the URL as an argument and use this hook as a replacement for the fetch method in the whole project. So now instead of hard coding this URL, let's just pass the URL here, and we're gonna need to update the dependency list of the useEffect hook here to add the URL. Each time the URL changes, we need to execute this code again. Now let's go back to the app component and pass the URL here. And that's it. Now if we go to the browser, we can also observe the same result. And each time we want to use another API, we can just pass the URL here. In React, a side effect is any operation that affects something outside the function's scope. For example, making an HTTP request or modifying a global variable. And to handle side effects effectively in React, we have to use something called useEffect hook, and we will see why and how in more details in the next lecture. The useEffect hook in React is used to perform side effects in your component, and some examples of side effects are fetching data, directly updating the DOM, and timers. Let's see an example to understand the importance of using useEffect hook. So let's say we have this component which creates this user's state variable and then fetches a list of users from an API. I'm using here JSON placeholder, which is a website that provides example APIs for testing. So after we get the response from the API, we update the user's state via the setUsers method. Then finally we render the users here in the component. This code might seem fine, but it has a problem. The problem here is that the setUsers method will re-render the component, and when the component is re-rendered, the fetch function will be invoked again and will invoke the setUsers function again, and this will result in an infinite loop. So if we run this application, we can see that the list of users are retrieved and displayed, but there's actually an infinite loop going on. It might not be visible here, and if we open the browser DevTools, we can see that there are infinite requests to the API. That's because the fetch function is getting invoked infinite times. So to solve this problem, we have to use the useEffect hook in React. Let's see how. Okay, let's go back to the code, and the first thing that we will do is we will import the useEffect hook here from React. Then we are going to wrap this fetch function call here by the useEffect hook. First, let's call the useEffect hook. And as you can see, the useEffect function takes two arguments. The first argument is the callback function that will get executed by this hook. And the second argument is a dependency list, which means that this effect hook will run only after one of those dependencies are changed. Otherwise, it will keep running in each render of the component. And if we pass an empty array as a dependency list, this means that this effect will execute only once in the first render. Alright, let's start with the first argument, which is the callback function. We're gonna pass an arrow function here, and inside it we will move this fetch function invoke. Alright, let's skip the second argument now. So that means this effect will keep executing in each render of the component. And that means we have still the same problem, right? Because the setUsers method will re-render the component and the effect will execute again, and that will result in an infinite loop. So let's check and go to the browser. As you can see, we are still getting this infinite requests to the API. So to solve that, let's go back to the code. And the key here is in the second argument, which is the dependency list. As I told you, if we pass an empty array, that means this effect will execute only in the first render. Alright? So now if we go back to the browser and refresh, we can see now that the request to the API is made only once and there is no more infinite loop. Alright, now let's see how can we use the dependencies with the useEffect hook to trigger the effect only if the dependency changes. In this case, as we learned, we can pass an array of dependencies. But in this example, we are going to use an array of only one dependency, which is the user ID. Whenever we change the user ID through this input, we will execute the effect hook to retrieve the data from the API for this user ID. As you can see, whenever I enter a user ID, we retrieve the information for this user ID. So the dependency here is the user ID, and whenever it changes, it executes the effect hook to retrieve the user information. Let's go to the code and start with this example. Alright, so we have this React project, and let's create a new component. First, let's create a new file and call it userdetail.js, and let's import the use state and use effect hooks from React. Then let's create the function component. Then we are going to use 3 state variables here, one for the user ID, we'll initially set it to an empty string, then another one for the user data, which is retrieved from the API. We will initially set it to null, and another state for the error. If there is any error from calling the API, we will store it here. We will initially set it to null as well. And that's it for the state variables. Now let's create our useEffect hook. And the first thing that we will do is we will check if user ID to be sure that it's not an empty string. In this case, we are going to call the API to get the data for this user ID. Alright, so we use the fetch function here to call this example API from JSON placeholder. Then we call the then method. And first we will check if not response.ok. That means there is something wrong with the request. So in this case, we will just throw an error. Let's say user not found. Otherwise, we're gonna return response.json. I have a typo here, there's a missing s. So response.json will return a promise. So we have to handle it using another then method. And this will return the data or the JSON object. So now we have the user data. We will call the setUser and pass the data to update the user state. And since we don't have any errors, so we will use the setError method and pass null. And we will also add this catch method to catch any error. In this case, we will update the setUser and set it to null, and we will set the error object to error.message. Alright, as we said, this user ID will be updated from the text input, and we want to execute this effect only if the user ID is changed, right? So here we have to pass a dependency in the dependency list, which is the second argument in the useEffect method. So here we will pass an array that contains only one item, which is the user ID. So now this effect will get executed only if the user ID is updated. So we are done with the useEffect hook. Now let's render the component and add the JSX code. Let's render a div and header. Let's say is user details, and the input that will be the user ID input. So the type is text and the value is the user ID, and on change event is going to call the set user ID function to update the user ID state, and we're gonna pass the e.target.value to pass the value of the text box. Let's also add a placeholder, enter user ID. Now let's display a paragraph that shows an error if there is an error. So we're gonna use conditional rendering here, and the condition will be if there is an error. So we will render a paragraph, and let's add some styling to it. So let's make the color of the font red, and let's display the error here. Then we will use another conditional rendering to render the user. So the condition, if the user is not null, we're gonna render a div, and inside it we will render the user details. So we will start with the name. Let's use a strong tag for the field name to make it bold, and then for the name we will use user.name, and we will do the same thing for the email, and that's it. So finally let's export this component. Alright, and now let's go to the app.js and import the component and render it here. Let's delete this generated code and import the component, and let's render it here. Alright, now let's start the development server and go to the browser, and here we go. So we have our application. If we enter any user ID, we can see that the information is retrieved only when we change the ID. So if we enter a different ID, we can see that information for this user ID is retrieved. So the effect hook here is triggered only when the dependency is changed, which is the user ID. In React, the useEffect hook can return a function like this, which acts as a cleanup function that executes each time before the effect hook runs. We can use it to clean up or cancel any side effects before running the effect again. For example, in this application, we retrieve the user information whenever the user ID is changed via the text box. So let's say there is an already ongoing fetch request and the user ID was changed. In this case, we want to abort the already ongoing fetch request. So for that, we can use this cleanup function. Let's implement this example. So we are going to use the abort controller, which creates a signal that allows us to stop an already ongoing fetch request. So let's create this signal like this. And here in the cleanup function, we are going to call controller.abort. So now each time this effect executes, it will abort any ongoing fetch requests. Then we have to use the signal here with the fetch request. So we will pass it the request init parameter object. Then now in the cleanup function, we can call controller.abort to abort the fetch request. So whenever this effect executes and there is an ongoing fetch request, it will abort it. As you can see, this cleanup function is very important and can prevent memory leaks and improve the performance. Alright, so now we are going to implement an application that will display the upcoming and the past SpaceX launches. So we are going to use this API provided by SpaceX, which is a public API. As you can see, it retrieves all the launches, the past launches and upcoming launches, and some details about them. So let's get started. In the command line, let's create a new project. Let's call it SpaceX LaunchTracker. Then let's go to the project folder and start the development server. And now let's open the project in Visual Studio Code. And let's create a new component, which will be the main component that displays the launches. So we're gonna name it LaunchTracker. Alright, and we're gonna import two hooks, the useState hook and the useEffect hook. And let's begin by creating a constant that will be the space x API URL, which is this URL. Then let's create the component function. And we're gonna need a state for the launches, right? To store the list of the launches. So let's start by creating this state. We're gonna set the initial value to an empty array. And let's create another state for the loading. So we're gonna display a loading label until the API returns the response. And we're gonna use this state to store this loading status. So let's create it here. It's gonna be a boolean, so let's initially set it to true, assuming that initially the API didn't return the response yet. And also let's display an error in case if there is an error, and store it in another state. So let's call it error and initially set it to null. And that's it. So now we have the states that we will use in the component. So now we want to call this API and get the response and update the states, right? So let's start doing that by using the useEffect hook. So we're gonna use the fetch API and pass the space x API URL here. And then when the API returns the response, so we're gonna check if response.ok, that means there are no errors. Or actually let's check if not response.ok and display the error here or throw the error. So that means there's an issue with the API itself, so we're gonna throw an error here. But if there is an issue with the network or something like with the fetch function itself, we're gonna display this error with this error state. Alright, so here let's just throw a new error and say failed to fetch data from the API, or just failed to fetch data. Otherwise we're gonna cast this response to JSON using the JSON function, which actually returns another promise. So let's handle it here and receives the data, the JSON data. And then we're gonna use the set launches function to update the launches with the received JSON data and update the loading state and set it to false. Alright, then finally let's catch any errors. And here we're gonna update the error state with the error message, and we're gonna also set the loading state to false. Alright, and we want this useEffect hook to execute only once when the component is rendered, right? So as we learned, in this case we're gonna pass the dependency list as an empty array. Alright, so now we are done with the useEffect hook. Let's actually return the JSX code of this component. So let's start with a div and let's add the title of the page. Let's say space x LaunchTracker. Then we're gonna use conditional rendering to display the loading paragraph. So we're gonna use a paragraph for this and display loading. And let's do the same thing for the error. And here let's display the error message. Alright, and now let's actually display the list of the launches. So we're gonna use a UL tag here, and we're gonna map each launch in the launches array with an li tag. So we're gonna use launches.map, and let's surround this by curly brackets because it's a JavaScript expression. Then we're gonna type li, and the key is going to be the launch.id. In each li, let's use a header for the launch name, then the date. So we're gonna use a paragraph and display date. Then we're gonna create a new date object, and we're gonna pass launch.date_UTC, and you can check the API response to make sure that all these elements are there with the same naming. Maybe later it will be updated for some reason. So you can paste simply the URL in your browser and make sure that all the namings are the same. Then we're gonna cast it to local date string. Alright, then let's display the rocket of the launch. Then let's also display the launch site. And let's finally display some details about this launch. Some launches don't have this details, so we're gonna check here if launch.details is not null, so we're gonna display it. Otherwise we're gonna display something like no details available for this launch. Right, then let's display a link which will redirect us to watch this launch. Alright, so we're gonna use launch.links.webcast as the URL, and let's set target to blank to open this in a new tab. And for security reasons, since we use target equals to blank, we have also to use or to set the rel attribute to no opener, no referrer. Alright, then let's type here watch launch. Alright, and that's it. So now let's export this component. And let's go to app.js and modify it here to display or render this component. Let's delete that code. Let's import the component and render it here. Alright, and that's it. So save the file and go to the browser, and here we go. So as you can see, this is the list of the launches with some information about each launch. If we refresh the page, you can see, if you have like maybe a slow network, you can see the loading. It appears for like a fraction of the second and disappears. And we can try to click on watch launch. You will get redirected to YouTube and you will see the video of the launch. Alright, yeah, cool. As you can see, there are too many launches, right? As you can see, all of them are displayed in the same page. So it would be better if we add pagination to our website, right? So we display a certain number of launches and add some buttons to navigate through them. Alright, so let's start doing this. Let's go back to the code and let's go to the LaunchTracker component, and we're gonna need to add two more states here. One for the current page, so we wanna keep track of the current page initially it will be 1 because it's initially the first page that's displayed. And we're gonna also want to keep track of the launches per page. So how many launches displayed per each page. So actually this launches per page will not be updated from the website itself. The user cannot like update how many launches per page. So we don't need a state for it. Let's instead create a constant for it and set it to 10. Alright, and now we're gonna add some code here. So we want to keep track of some things like the index of the last launch and the index of the first launch in the current page. Why do we need to keep track of them? Because we're gonna use the slice function to slice the array and provide the index of the first launch and the index of the last launch to retrieve only the current 10 launches that should be displayed in this page, right? If it's not very clear for you, everything will be clear and will make sense after we start the implementation. So let's first create an index of last launch and assign it to current page multiplied by launches per page, right? Makes sense, right? Because let's say we have 10 launches per page and the current page is 1, so the index of the last launch is 1 multiplied 10, which is 10, right? We should minus 1 here, but since we're gonna use the slice function which slices the array until this index non-inclusive, so we don't have to subtract 1. So let's also add another variable for the first launch index, and this is going to be the index of last launch minus launches per page. Alright, makes sense. Also, if we apply the example on the first page, if we have 1 multiplied by 10, so the last index is 10 and the first index is going to be 10 minus 10, which is 0. Alright, now we have those variables ready to be used. So we want to create another array that contains 10 launches for the current page. So we're gonna create this array and call it current launches, and we're gonna use launches which contains all the launches dot slice to slice it, and we're gonna pass the start index as index of first launch and the end index as index of last launch. Alright, so this array now is ready and have the current 10 launches for the current page, and we're gonna render the component using this array instead. But we also want to calculate the total number of pages to display or to render the same number of buttons for each page, right? So we're gonna calculate this here. Let's call it total pages, and let's use mass.ceil, and it's gonna be launches.length, the length of the launches array that contains all the launches, divided by launches per page, right? So this is gonna give us the total pages number. Alright, now let's go back to the JSX code of the component, and instead of launches here, we're gonna use current launches. Alright, so now if we save the file and go to the browser, we will be able to see that now only 10 launches are displayed, right? So that looks nice so far, everything is fine, but we are still missing the pagination feature itself. So the buttons that we can use to navigate through the launches. So let's go back to the component code and let's start adding the pagination controls after the UL tag here. So we're gonna create a div. So what we will do is we're gonna create an array of buttons, and each button will have the number of the page that we want to navigate to, and the button with the same number of the current page will be disabled. So first, how do we create an array? We're gonna use array.from, and first we're gonna pass an object which contains the length, which is the total pages, right, that we calculated previously. Then we're gonna pass another function here, an arrow function. Alright, and let's wrap this in a curly brackets. So this second argument is a mapping function which takes two arguments, the current element and the index. And what we want to do is we don't want to do anything with the element itself, but we want to return the index added to 1, because it's a 0 based index, and the page number start from 1. Alright, so for each element we're gonna return index plus 1, and that's it. So now we're gonna use .map to cast all the elements of this array into buttons. So we're gonna receive the page number here, and for each element we're gonna return a button whose key is the page number. And let's add an event handler for the onClick event. Right, so here we're gonna add an arrow function, and we're gonna use the set method for the current page and update the current page with the current page number for this button. Alright, then we're gonna set the disabled attribute to page number equals to current page. Right, so if this button has the same page number of the current page, we don't want to display it because we don't want to navigate to the current page. Alright, and let's add the text for this button. It's gonna be the page number, and that's it. So I still have a mistake here. For this arrow function I added curly brackets, so either I should add the return keyword here or just remove the curly brackets and add brackets instead, because it's only one line. There's only one line in this function, so let's do that, and that's it. So now save the file and go to the browser and scroll down. You will be able to see the buttons here. As you can see, for each page we have a button, and the current page button is disabled. Alright, so if we click on 2 for example, we will be navigated to the second page, and so on. So yeah, navigation looks good now. Final thing that we can do to improve this is scrolling up when we click on the button. When we click on the button, we are still here at the bottom of the page. What we want to do is when we click on a button, we want to scroll up to the first launch, right? Let's go back to the code, and here, instead of setting the current page in the event handler for the click event of this button, let's remove this code and let's implement a function. Let's call it handle click. Alright, and it's implemented here. And we're gonna set the current page number here, and also we're gonna use window.scroll to scroll to the top. We're gonna have to pass an object that contains some configuration. So the first one is the top. Let's set it to 0, and let's make the animation smooth by setting the behavior to smooth, and that's it. So now final thing, we have to pass the page number here to the function, and that's it. So save the file and go to the browser, and now let's scroll down and let's click on any button. You can see that the page scrolls to the top. Now let's add some simple styling for our website. So let's go back to the code and create a new file in the source directory here. And let's name it LaunchTracker.css. And let's create a class for the title. We're gonna use text align center and give it some margin button. And let's change the font size and the text color as well. So let's use this gray color. Then let's create a class for the list or the launches list. Let's call it launches list. And let's set the list style type to none to remove the bullet points. Let's give it padding of 0. And let's set the maximum width to 600 pixels, and let's also add margin auto and set the value to 0. And for each item in the list, we want to make it a card like item, right? So let's create a class for this and call it launch item, and let's give it some padding. let's give it 20 pixels, and margin bottom, and let's add a border of 1 pixel, and let's set the color to white. And also let's make this border rounded by giving a border radius of 8 pixels, and we want to make it a little bit like a 3D card, so we can give it a shadow using the box shadow. And let's add those location values for the shadow and the color. So we're gonna use a black shadow here, so we're gonna pass all RGB values to 0 and the alpha to 0.1. And then the background color, let's use this white color. And that's it for the launch item class. Now let's create another class for the pagination div, which has the buttons. So we're gonna use display flex because we want to center the buttons horizontally. So we're gonna use justify center, or sorry, justify content, then center. We're gonna also give it margin top, and that's it. So now let's create a class for the pagination button. Let's add some margin. So we're gonna add a right margin. Then let's add also padding. Let's set the font size to 16 pixels. And let's make it rounded by giving border radius, let's say 5 pixels. And let's give it a border, 1 pixel, solid. Then this blue color. And let's change the background color to white. And let's make the cursor pointer. And we want, when we hover over this button, we want to change the background color. So let's add a transition here and set the value to background color and 0.3 seconds, and the color also to 0.3 seconds. Then let's add a class for the pagination button when we hover over it. So colon hover. Here we're gonna change the background color to lighter blue color and the text color to white. And let's add one more class or two more classes when the pagination button is disabled or active. That means it's the button of the current page. So we're gonna set the background color to this and the color of the text to white and the cursor to default instead of pointer. Right, and that's it. So now we have our CSS code. Let's go to the component code and add the classes here to the components or the elements. So the first one is the title. Here we're gonna set the class name to title. Then the list, we're gonna set it to launch list, or actually I named it launches lists. Okay, I will remove this S. This was a typo, so it should be launches list like this. Alright, and for each item, so for each li tag here, we're gonna set the class name for this to launch item. Then let's go to the pagination div and add its class, which is pagination. Then finally the button. So let's set the class name here to Pagination dash button, and we're gonna also append the word active in case if the current page equals to the page number of this button, right, to give it the styling of the active button. So let's do that, but we're gonna need to use string interpolation, and here we're gonna check if page number equals to current page. We're gonna add the string active, otherwise empty string. Alright, and we have to wrap this with curly brackets, and then finally we're gonna want to import the CSS file here. So let's import alright, and that's it. So save the file and go to the browser, and here we go. So now it looks much nicer than before, right? So for each element we have this card like view, and the buttons now looks much nicer. If we click on the button, we get scrolled to the top, and the active button, as you can see, looks different and unclickable. One final thing, there is a typo here that I have made, so sorry about that. For the date, as you can see, it's data and invalid date is written here. So let's go back to the code and fix it. So in the LaunchTracker component, let's scroll down, and here in this paragraph, let's change this to date and this to date as well, not data. Alright, and save the file. And now if we go to the browser, we can see that the data is displayed correctly. Let's start with an introduction to software testing. First, what is software testing? Software testing is a process of evaluating and verifying that a software application or system does what it's supposed to do. And the goals of software testing are first validating the functionality of the software. So does the software meet the requirements or not? Is it doing what is it supposed to do or not? Then find bugs, right? So that involves catching errors or issues with the software before deploying or before the user finding these issues or bugs, right? To make sure that the user receives a bug-free software, right? Then ensure quality. So of course, by preventing errors and issues, that improves the quality and also the user experience, the performance, the security, and so on. And prevent regressions. So whenever there's a new feature or a new code that's introduced to the software, testing makes sure that this new code or this new feature doesn't break the existing features, all right? So there are three main types of testing, all right? We can represent them using the testing pyramid, all right? So we have unit tests, integration tests, and end-to-end tests. Also E2E tests, right? In unit tests, the individual functions or components are tested in isolation, right? So each component is tested on its own to make sure that the component is doing what is it supposed to do, right? Then we have the integration test, right? Which checks how components work together, right? So are the components doing what they are supposed to do when they are communicating together or when they are integrated together, right? Finally, we have the end-to-end test, which simulates the real use cases or the real user scenarios, all right? So testing the functionality of the system as a whole, as if the user was or were using the software, right? As you can see, this is a testing pyramid, all right? As we go down, there's more isolation in the tests, all right? And as we go up, there's more integration, all right? Because as you can see, at the bottom of the pyramid, we have unit tests, which is testing each component on itself, all right? Then integration tests, which is testing a group of components together, all right? Then we have the end-to-end test, which is testing the entire system, all right, or the entire software. So going down, we have more isolation, and going up, we have more integration. Also, going down, the tests are executed faster, right? Because when we test a component, we have less use cases and less tests to test than end-to-end tests, for example, where we have to create test cases for the entire system. All right. So of course, when we go down, since we are having more isolation, that means also less test cases, hence faster tests. All right. So going down, we have faster tests. Going up, we have slower tests. All right. That's it. That's a quick overview over software testing. And in this section, in the next lecture, we are going to start using Jest, which is a testing framework for React. So see you in the next lecture. Jest is a popular JavaScript testing library, and it's already included when we create a React project using the create React app command. All right. So let's start creating a new project and see how can we use Jest. All right. So let's type mbx, then create React app command, and then let's name it Jest. Then after the application is created, let's open it in Visual Studio Code. All right. So I'm gonna pause the video and continue after it's created. After the project is created, I opened it in the Visual Studio Code, and as you can see, this is the source directory in that project. We have the app.js, which is the app command, or the app component, excuse me. And we have also another file here, which is app.test.js, right? This is an auto-generated test for the React project, right? So as you can see, Jest automatically creates that file, and for any test file, the extension is test.js. So the component name .test.js, and usually we add it in the same folder of the component, all right? So if we create another component here in this folder, we also have to create another file with the same name of the component, then .test.js, all right? And add the test cases there. So here we have the file, and as you can see, we have only one test case, right? So using this test function, which is globally available in the application. So as you can see, we didn't import this test function, right? It's globally available. And this function takes two arguments. First, the description of the test, right? Usually it starts with lowercase character as well. That's the common convention. And the second argument is an anonymous function, which is including the logic of the test case, right? So the actual test or the actual test code. So let's start understand this code, all right, in more detail. So first we call the render function, all right, and pass one argument, which is a JSX code, by the way, as you can see. And it's basically the component that we want to render. And this function will render it, but not actually render it in a browser. It will simulate a browser and render it there. So it's basically a simulation of rendering the component, all right? Not in a real browser. So now after we call this render method and pass the component we want to render, it's as if it's rendered in a real browser, all right? How do we communicate with this browser? We use this screen object, all right? This represents the screen or the window of the browser or the virtual DOM or browser, all right? So we can use this object to query the rendered HTML. For example, here we use this getByText function. This will search for a visible text, all right? Here we pass a regex expression. So we can also pass a text, all right, a string. But with regex, it's more flexible. We have more control. And this I means case insensitive, right? So this function will search for that text. If it's found, then it will return the element that contains that text, right? And we store that element here, right? So now what do we do with this element, right? So we expect that element to be in the document. That's it, right? So let's understand this in more details. This function expect is called an assertion, right? And assertion means I am expecting something to be true, all right? So what is this something? It's that element, all right? So that's what we pass to this expect function. So it's called an assertion, right? And it means I am expecting a condition to be true, And what is this condition about? It's about that link element. That's what we pass to the expect function, right? So as you can see, it's also very readable and very easy to understand when you read the function names, all right? And that's a very good thing about Jest, all right? So usually also all the test frameworks use the same names or similar names, all right? Then we have here, this is the actual condition, all right? So here, for example, we have to be in the document. This is the condition that this assertion will expect to be true. So it expects this element then to be in the document, all right? If it's not in the document, then this will return false and the assertion will fail. Hence, the test case will fail, all right? And this is called matcher, all right? So the matcher is the method that's chained to the expect assertion and specifies the exact condition we are checking, all right? Here, for example, to be in the document. So that means the condition is that this element is in the document. And that's it. So this is a very basic and simple test case. It expects, as you can see also from the description, that an element with learn react is rendered in the document. So how do we confirm this? We have to first render the component we are testing, then retrieve or query the browser or the virtual browser to find the element that includes learn react. Then now when we have that element, we want to check something about that element. Here, what is this something? We check if it exists in the document or not, all right? So we use the assertion, we say expect. That means I'm expecting something to be true about that element. So we pass that element and the condition, which is a chained method, which is called matcher. Here we use to be in the document, all right? All right, and that's it. So far we didn't use this test case, or we didn't execute that test case so far in the course, right? Why? Because we didn't actually run the command to run the test. So let's go to the package.json file. And here we have the scripts section. So we have the start script, right, which under the hood executes that command. We have also the test script, as you can see, which runs that command. So if we execute that script or that command, it will run the tests, right? So any file with extension.test.js will be executed, all right? So let's go to the command line and run this test. So here I'm in the project folder. I'm gonna execute this script using npm, then the name of the script, which is test in that case. Sorry, I was not in the correct folder, so I'm going to the correct folder now, and again I'm gonna execute npm test. Let's wait and see. As you can see, running then app.test.js, because this is the only file that we have, the only test file we have. And as you can see, test suits one passed and one total, tests also one passed, one total, because we have only one test suite and one test. We will understand more about test suites later, but as you can see, there's only one test and it's passed, right? That means the test case is successful, all right? So as you can see now, we have some options. We can quit, all right? So let's click on Q and let's go back to Visual Studio Code. Now let's modify the app component to fail this test case, all right? As you can see here, we render this hyperlink with learn react text. So let's remove react, for example, right? And save the file. So now the test case will fail because it looks for this string, all right? So if react is not there, it will not find an element that contains that text, and this assertion will return false, right? Because this matcher will return false because the element does not exist in the document, right? So let's go to the command line and run the test now again. As you can see now, the test case has failed, all right? And if we scroll up, we can see more details about the failed test case. As you can see, this is a description, all right, of the failed test case. Renders learn react link, all right? And there's the failure message, the error message. So unable to find an element with the text, then the regular expression, right? So that's some details about the failure, right? And the test case that failed. So again, let's go to the Visual Studio Code, and we can return this back to its original form and run the test case again to make sure everything is fine. So I clicked on A and now it's passed, right? So that's an overview of Jest, and as you can see, it's already included when we create the React project using create React app command, right? And when we create the project, there's already automatically generated app.test.js that tests the app component. Of course, you will have to modify this test because this is just for the boilerplate code that's automatically generated by the command. But of course, you will change the app.js file, so you have to also change here the tests, and based on the application, you will have to create test cases, right? And we will see more details about how to create tests, how to use matchers, what are the matchers that exist or included in Jest, and so on. But for now, we have a quick overview. So now we know that the test function is actually a test case, right? So this represents a test case, and inside it, we use a render function to render the component. Then we retrieve any element from that document using the queries from the screen object. The screen object we imported from testing library /React, and we can use it to represent the browser, the virtual browser, right? So we can query from that virtual browser anything, like to retrieve an element, for example. For example, here we use the get by text to retrieve an element by text. Then finally, this is what actually, or this is what actually the test case depends on, all right? The assertion. So here we expect something, then the condition, right? So we expect that condition to be true, and about that element. The condition is about that element. So the condition is to be in the document. What is to be in the document? The element that we pass to the assertion, all right? So if the condition returns true, the test case passes, otherwise the test case fails. So far we have seen app.test.js, which is automatically generated by create React app command, right, when the project is created. And it has an example test case which tests app.js component, right, or the app.js file. Now it's time to create another component and create a simple test case for it, all right? So here in the source directory, let's create a new folder, all right? Let's call this folder greeting. This is the name of the component also. So let's create a new file in that folder, call it greeting.js, all right? And here, let's create an example component. So let's start with the function, and it's gonna be named greeting. And here we're gonna just return immediately some JSX code. So it's gonna just display a greeting message, right? So let's say hello, then just, right? That's it. So finally, let's export this component. And now let's create the test file for that component, all right? As we learned, we create a file with the same name of the component, all right? Greeting, and the extension is test.js, all right? So first, let's start with creating a test case. The test case will render this component and expect to see a text with the value hello Jest, right? So let's go back to the test file and type test, right? So the test method, all right? And as we learned, it takes two parameters. The first one is a description of the test case. So let's say renders greeting Jest, right? And the second parameter is an anonymous function, which is the actual test, right? So here we write the test code. First, as we learned, we want to render the component we are testing, right? So what are we testing? Greeting. So let's import it as well, right? And let's render it here. How do we render it? Using the render function. So we have to import it as well, all right? So maybe we can, or there is no option to import it, so let's import it manually. So we also need another thing to import here, which is the screen object, right? This is the virtual browser from and testing library, then React, right? And now let's call the render method and pass the greeting component as an argument, right? Now it's rendered in the virtual DOM or the virtual browser. So now how do we query this virtual browser? We use the screen object. So we're gonna query the browser or the virtual browser to find an element with the text that we will pass. So it's hello Jest in that case, right? First we want to store that element. So let's create a constant, call it element, and assign it to screen.get by text. And here we can pass either regex or text. So let's pass text in that case, right? Hello Jest. And finally, now we add the assertion and the matcher. So the assertion is expect, as we learned, the expect method, and we pass here the element, all right? Then the matcher. So here also we want to check if it's in the document or not. So we use that to be in the document matcher, and that's it. So finally we have to render that component here in app component. Let's remove that auto-generated code, and here let's just render it and import it as well. It was auto imported by the IDE. So we are good to go now. Let's go back to the command line, and here let's run npm test. So now as you can see, we have two tests, all right? We have the greeting.test.js and app.test.js, so two test files, all right? There is one failed test case now. As you can see, the greeting.test.js file has passed the tests, all right? But there's another test case that failed, which is this test case. And the reason why this test case failed, because we removed that component from the app.js, right? We removed the automatically generated code. So now this doesn't exist anymore, right? So for now, let's delete that file because we don't care about app.js now. We don't care about testing the app component. In this lecture, we are focusing on greeting component, right? And now let's go back to the command line and execute npm test. As you can see, now we have only greeting.test.js, all right? And it's passed. The test case is passed, all right? So let's try to fail the test case also. So let's go to greeting.js, and here let's render something different, like for example, hello world, right? Now let's go back to command line. As you can see, the test has failed. We didn't have to execute the command again because there's this watch which is already checking if there is a code change. It reruns the tests, all right? If we want to exit that mode, we can click on Q, right? And now we have to run the test again. So as you can see now, the test has failed. All right, let's go back and modify this, right? So let's say we will pass a name to this component as a prop, right? And we render here hello, then that name. So let's first pass it here, right? Let's pass the props object, and here instead of hard coding this, let's render props.name, all right? We're gonna pass this from the app component as a prop, all right? Let's pass here Jest, for example, all right? But now there is a problem with the test case. It will fail if we go to the command line. You can see that it's failing because we rendered the component and we didn't pass the name, all right? So we have to also pass the name prop here. So let's pass Jest in that case. And we can pass any name we want here in the test case and also include it here, all right? So now we pass Jest, that's fine, as we did in the actual use case in app component, right? So let's go back to command line. Now the test passes. We can also modify this, for example, pass any random name, but we have to also modify this string, right? If we go back to the command line, as you can see, the test still passes. All right, so that's it. Now we saw how to create a component and create its test file. All right, so it's the same name of the component file, all right, followed by test.js as an extension, and we can add one or many test cases here and write the description, as you can see. And the second argument is the anonymous function that has the test code. And we saw also how to test a component with props. All right, so far we have been using only one matcher, which is to be in the document, but in the next lectures we will see more examples of more matchers and different matchers than this one. All right, everyone, so this is the official documentation of Jest, and as you can see, there are many matchers. So far we have used only one matcher, which is to be in the document, but as you can see, we have many other matchers. For example, this to be matcher, right, which tests if a value is exactly equal to another value. All right, so here, for example, it expects that expression to be 4, right, which is true. This works with values, but also we have another matcher, which is to equal, that works with objects as well. As you can see, we have here this data object, and we use the expect with the to equal matcher to check if this object is equal to that object, right? So this returns true because the keys and the values are the same. So the objects are the same or equal. So we have many other matchers. For example, we have for truthiness, all right? So this checks these matchers, like for example, to be null checks if a certain object or value is null, to be undefined, to be defined, and so on. So these matchers check the truthiness of something, all right, or of a condition. We have also other matchers for numbers, like to be greater than or equal, and so on, right? We have all kinds of matchers, all right? So based on the use case you have, you can refer to that Jest official documentation and check if there is a matcher that is the perfect choice for your use case, all right? So for now, let's go back to the project and see some another example of a test case using a different matcher. All right, so here I have the Visual Studio Code open, and as you can see, we implemented this simple component greeting, all right, and we added the setter. Let's add another component here, which is a button, all right? So I'm gonna add it here, and let's add here, for example, start, all right? Just for example, let's wrap this in a fragment. All right, so we added this button. Now let's add a new test case in the greeting.test.js file to test if this button exists and if it has start as content, all right? So let's go here and create another test case for that. So as we learned, we create a test case using the test method, and the first argument is the description. So here, let's say button exists with title and start, all right? So that's it for the description. Now let's create the actual test, which is basically an anonymous function. So first, the most important thing that we have to do as first step is to render the component we are testing, all right? So here, let's pass a random name as prop, all right? Let's say name. Now we have the component rendered in the virtual browser, right? So now let's retrieve the button from that virtual browser. So we use the screen object dot, and what we want to find now is a button, right? So we can use that method get by rule, all right, and pass the type of the element we want to retrieve. So in that case, button, right? We pass it like that. So this will retrieve an element with that type, right? Since we have only one button, so it doesn't matter, all right? So in that case, we want this button to be in the document and also to have a specific text, which is start, right? So maybe I make this test case description more descriptive by saying button exists in the document, all right? And here, as we learned, how do we check a specific condition using assertion and matchers. So the assertion is expect, right? And we pass the element, which is a button, and then the matcher, first one is to be in the document, right? So if that's true, we move to the next condition, which is also expect button. Then we have another matcher called to have text content, right? This will check the text content of the element. So here we pass the expected text, which is star, right? And that's it. Now we have two conditions, right? If one of them fails, the test case will fail. So let's go to the command line, and as you can see, since the watch is already running, test cases are passed, right? Two test cases are passed. Now let's go back to Visual Studio Code and try to modify the component. Let's modify this text. Let's say instead like test, for example, and save the file, and let's go back to the command line. Now as you can see, the test case fails, right? As you can see, this result is this description says the expected element to have the text content start and received is test, right? That's why the test case failed. If we scroll up a little bit, you can see now that in this file there is one test case that was successfully executed, which is renders greeting Jest, and this one which failed, which is the button exists in the document with the title start, right? So maybe you have some tests that passes and some tests that fail, all right? So that's it. Let's go back and again write it as start. Now the test should succeed, as you can see. So that's it. That's a very simple use case and test case, all right? As we saw in Jest official documentation, there are many matchers. So based on your use case, you can find the suitable matcher from the documentation if you don't know it already, all right? There is a very popular concept in testing called mocking. Let's understand it. First, what is mocking? Mocking means creating fake versions of functions, modules, or components so you can control their behavior in tests. To understand this better, let's continue by seeing the test pyramid again, alright? So, as we learned previously, we use unit tests to test each component, right, in isolation. So, when we test a component, we test only that component regardless of any other component, right? But the problem is sometimes we have components that depend on other components or depend on other functions or modules that are external to that component. So in that case, we don't care about them, right? Because we are testing only that component. So that's where mock comes into play. In this case, we can mock these modules or functions that the component depends on them by creating a fake or a dummy version from that function or component, all right? So again, we can mock functions, also modules. This can be an API call, for example, or any external module that we can use in the component. Also React components, so children components or external components that we use in a component, all right? So now we saw an overview of what is mocking. Let's go to the code and see some code examples. Let's continue with the previous example. So here we have this simple greeting component and we have a header and a button. Let's say we have a function which is the onClick callback function or onClick handler function that will be passed from the parent component to that component, to the greeting component. And this will be used here in the button. So let's configure the onClick handler here to props.onClick, right? So now this function is out of scope for that component, right? We don't want to test it. In that case, we have to pass that prop here from the app.js and add this test case of that function here in app.js. So in app.test.js in that case, the test file for app component. We deleted that file because we don't care about it for now in this section, but if we want a complete testing of our software, we have to add this file and add testing for the app component. In that case, we test that function. So let's add this function here and pass it within the props, right? So we're gonna add here a function. Let's implement it, right? So let's just display something like button clicked or something like that, just for an example. So let's go to the command line and start the npm server. If you already started it, then you can test in the browser right away, but I didn't start the server, so I'm gonna start it and test in the browser just to make sure everything is working as expected. So now, as you can see, here is the page and the header is displayed as expected. There is a button. If we click on it, we can see the alert, right, with the message. So everything seems to be working as expected. Let's go back to code and continue. So again, here is the function in the app component, and we pass it to the greeting component within the props. So here the component receives it, and this is considered out of scope for this component. When we test, or when we do the unit testing for this component, we don't care about this function, right? Because it's not implemented in that component. So in this case, we can use mocking, but we can have a test case that checks if that button calls that function on the click event, right? Because this is considered within the expectation of that component, or the functionality expected from that component to call that function. But we don't care about the function. We don't care about what it does, all right? We just care about that this button clicks, this button fires or invokes this function when it's clicked, all right? So that's what we will do. Let's go to greeting.test.js and create a new test case for this, all right? So we're gonna create test case here using the test function, and let's set the description to calls on click handler when clicked, or let's say button calls on click handler when clicked, right? Then we pass here the anonymous function, and first render the component. So greeting, let's pass any name here, and now we have to pass the function, right? So let's just pass nothing for now, right? So edit curly braces, and let's also close the tag. And now let's start mocking that function. How do we mock it? First, we need to store that mock, all right, in a variable. So let's create a constant, or excuse me, in a constant in that case. So let's call it mock on click, all right? And how do we mock it? All right, we use the Jest object, which is also globally available. We don't have to import it like the test function, for example. So Jest.fn. That's it. Very simple. Now we have a mock function, all right? We don't care about the functionality of this function, as I told you, right? So we're not gonna implement it. We're not gonna do anything. It's just a mock, all right? A dummy function. So we're gonna pass it here, right? And that's it. Then we have to also get the button. So I'm gonna create a constant, name it button, and assign it to screen dot get by rule. Since we have only one button, so I'm gonna use this matcher, right? So that will retrieve the button or the element with the type button. So now what is the remaining step? As you can see, this test case, from the description even, we can see that button calls on click when clicked, right? So far, the button is not clicked yet. We rendered it in the virtual browser, the component. So the button is there, but it was not clicked, right? We have to simulate that click action, right? So we can use something called fire event, right? It's also from the testing library module. So let's import it. And this will simulate an event, all right? In that case, we want to simulate the click event. So we can call fire event dot click and pass here the button, right? So we can pass the button element. This will fire or simulate a click event on that button, right? So now we are done with all the steps needed to have the output we want to check, right? Or the condition we want to check, which is the mock function, or in that case, we don't care about whether it's a mock or not. We care about that this button calls the function passed to the props, to it through the props when it's clicked, all right? So how do we do this? Where is the function? It's here, right? This is the function we pass to the component. So we want to check if this function, right, is called. So now when we use the assertion, we want to check a condition on what, or in relation to what. In that case, not the component or the button, it's the function, right? So we pass the function here. Then dot. Now the matcher, we have a matcher called to have been called times. Alright, so this will check if the function is called a certain number of times. In that case, just once. So we pass one, right? And that's it. So now let's go to the command line and let's, okay, I have the server started here. I'm gonna just stop it. We don't want it for now. And I'm gonna run npm test. And let's see the result of the unit tests. As you can see now, 3 passed tests, alright? So this is now working as expected. Let's try to fail this test case. So here, let's remove that on click from the button, for example. And now let's go back to the command line. As you can see, the test case fails, alright? So that's the case for mocking a function, alright? What about mocking an entire component, for example, alright? So now it's time to make a test case for that app component. And here we render that component, which is a child component, right? The greeting component. We don't want to test it, right? Because it's out of scope for the app component. So in this case, we want to mock it, right? So let's start doing that. So here in the source directory, I'm going to create a new file. I'm going to call it app.test.js, right? Because it's the test file for app.js, alright? So we need to do some importing. So I'm gonna copy them from here. We need the same import. So I'm gonna copy this one and paste it here. And of course, to import the component itself, right? And now it's time to start the test case. So I'm gonna use test, and here we're gonna do a simple check to make sure that the component is, for example, let's go back to app.js and display something here. All right, so a header, let's say app component, right? So we're just gonna make sure that this text is displayed by that component, all right? Just for example, so renders app component. This is a description of this test, all right? And now here, first we want to render the app, right? Then we want to do two things, right? So we want to make sure that this is displayed, and we want to also make sure that this component is rendered, but we don't care about its functionality, right? So we're not gonna go to greeting.js and see what it displays and then make sure that this is displayed, right? No, we're not gonna do that, right? So in that case, we're just gonna tell Jest, make sure that app component renders greeting component, all right? So how do we do this? We can mock that component and we can make it display any random string, for example. Then we can we can render and check if that random string we set is displayed, all right? So that means like we are replacing that component with another mock component because we don't care about it, right? That's what we will do. And also we're gonna check if this is displayed, all right? So let's go back to app.test.js, and here let's start with the first step, which is retrieving or making sure that this exists. So let's create a constant, call it header, and assign it to screen because we want to query the virtual browser, right? So we use the screen object for that. Then we use the get by text matcher, right? And pass here app component, right? So this now is enough to start using expect and pass header. And here the matcher is, so excuse me because I said here matcher, this is actually more a query. Here is a matcher. So that was a mistake from me. So here we use the to be in the document matcher. Alright, that's it. So that's fine. This will check that this component renders the app component string, right? But that's not enough, right? Because this app component does also more than this. So it renders also this greeting component. So we want to make sure that it's rendered, alright? So let's go back to app.tester.js and mock that component. So we're gonna also create a new test case, and let's say renders greeting component, alright? And here the second argument, which is a function. Alright, so first we also render app, alright? And now we want to make sure that this component, the greeting component, is rendered. As I told you, we don't care about the component, so it doesn't make sense to go to the component and see what's displayed here and then check if that's displayed on the screen. No. So we have to mock that component. How do we mock it? First, we create a constant, and let's say mocked greeting, and assign it to Jest. This is globally available, we don't have to import it. And here we have all the mock functions. So we have previously used fn, which is mocking a function. Now we use something called mock, alright? This will mock an entire module, or in that case component, alright? So what is the name of that module, alright? It's the component, so it's dot / then the component name, alright? In that case, greeting. So if we go back to app.js, as you can see, this is what we care about, alright? So where we import it from. So in that case, it's actually greeting, then another greeting, because there is a folder called greeting, alright? So I'm gonna change this to that. Now we mock this module, alright? So whenever we import something in app.js from that path, it will be mocked, alright? So now what is the value that will be mocked? This is the component itself, which is a function, right? So this might seem a bit confusing, but the second argument is actually a function, alright? Regardless of what is this module is, alright? So here we add an anonymous function, and from that function we return another function. This is a function component, alright? So here we return, right, and another anonymous function, right? And here we display whatever we want to display. So it's a JSX function component, a normal function component. So let's say a div, for example, or a header, right? And here we display whatever we want, right? We don't care about this. So we can display like mocked greeting, for example, right? So now we have this mocked component. We can pass it to app and let it render it, right? But the point is, we rendered app here, alright? So app will not know about this mocked component, right? Because this is executed after rendering the app. So to solve that, we're gonna cut this line and paste it here, alright? In that case, we don't actually need to store it in a constant. We just call the Jest mock. This will mock that module, alright? This will be available for the app whenever we render it in any of these test cases, alright? So now what we want to check is we want to check if this text is displayed, alright? So again, let's create a constant, call it header, and name it screen. We want to query the mocked browser or the virtual browser. So we use screen.get by text and pass mocked greeting, alright? If that exists, that means app rendered that component, right? Or that mocked component. So now we use expect, pass header, and to be in the document. That's it. Okay, we have an issue here, but that was intentional, alright? So here we modified greeting.js and we removed that onClick handler. Let's retrieve it back and save. Now let's go back. we have an issue with the new test case, which renders the greeting component. Okay, so I have found the bug. Sorry about that, everyone. So it's just a syntax error, because here in this function, all right, as I told you, the second parameter is an anonymous function, right, for the mock function, and then from that function we want to return a component, a function component. So we return that anonymous function here as well. But as you can see, I added curly braces, and here I didn't add the return keyword. So either I have to remove those curly braces or add the return keyword here, right? So I can add the return keyword here, but it just looks a bit messy. So I'm gonna remove it and remove the curly braces, right? And just keep this, right? So that means return that JSX code. All right, now let's go back to the command line. As you can see, all the test cases are passing now, all right? And as you can see now, we have 2 test suites instead of 1. Why? Because we have 2 test files. So each test file is considered test suite. And also we can create more than 1 test suite inside 1 file, all right? That's what we will see in the next lecture. All right, but for now, let's continue with the mocking in Jest. So now everything seems to look working fine. Let's try to make this test case fail by not rendering the greeting component. So I'm gonna just comment that line, right? And save and go back to the command line. Now, as you can see, the test case fails, all right? So that's it. Everything is now working as expected. That's how we use mocking in Jest, and for these reasons we use mocking. So thanks for watching, and see you in the next. When we executed the tests from the previous example, we saw that we have 5 test cases and we have 2 test suites. And as we learned, because we have 2 files, all right, we have 2 separate test files. So that's why we saw we have 2 test suites, because each test file represents 1 test suite, all right? But as I told you, we can also create multiple test suites in each file. But first, what is actually a test suite? So it's a group of related test cases, simply, all right? That's why each file is a test suite, because all the tests in the file is related, right? Or are related. So that's the case for the files, but also inside each file, we can have a group of tests that are related. For example, in the greeting file, in the greeting test file, in the greeting component test file, we have 1 test case that checks if the component renders some text, all right? Which is here. I also need to update the description, because the title or this text is sent from the props or from the parent component as props. So here, let's update the description: renders greeting or renders greeting then name, all right, which is a prop that's sent to that component. Then we have 2 other test cases related to the button. One checks if the button exists with a specific text, and then another one checks if the button fires a specific function when it's clicked, all right? So those are related, and they are not related to that one, right? Because it's not about button here. So we can group those 2 test cases in 1 test suite, all right? How do we do this? We use something called describe. This is a method also available globally, all right? It takes 2 arguments. The first one is the description or the name of that test suite. In that case, we can call it button related, all right? Then the second one is an anonymous function. And here we don't type the test cases, all right? We don't type the test code, I mean. We type the test cases. So we call the test functions here. So I'm just gonna cut those 2 test cases and paste them here. All right, so now let's go to command line. And as you can see, the number of suites is still 2, all right? Because each file is considered a test suite. So with this describe function, we create a test suite, but it's like virtually created, right? It's virtually grouping those tests together, all right? So it doesn't increase the number of test suites here, because this is represented by each file, all right? So if we want to see the benefit of that, let's make one of these tests fail, all right? So for example, we can make this test fail. For example, let's add here any number. Let's go back to the command line. As you can see, now this test case fails, and we can see the test suite here, right, which is button related, then the test case, right? So it's like the virtual group of tests, right, or test cases. And usually these test cases are related, right? React Developer Tools is a plugin that you can install in your browser, and it gives you more details about your React application. And that can make debugging easier for you. So you can download it from this website, the official React website. So depends on which browser you are using. I'm using Firefox, so I'm gonna click on install for Firefox and click on add for Firefox, and then click add here. And once the plugin is installed, you can open your React application. For example, I am opening the task manager application. Then you can right click here and click on inspect. This is in Firefox. In other browsers, you have to open the browser developer tools. Then you can see here components and profiler. Those are added by the React Development Tools plugin. So if we click on components, for example, we will be able to see the components of our React application. As you can see, let's zoom in a little bit. So we have here the app component and the task provider, which is a context provider. As you can see here, we have this tab which shows the hooks. So if we expand this, we can see that there is this reducer hook that contains the tasks. So let's add, for example, a task here. As you can see, the list of tasks is updated with a new task. So this makes debugging easier, as you can see. We can also go to any other component and see the hooks and some information about the component. For example, the task list component has this context, and there is the state. We can expand the state and see the tasks inside the state, and also the dispatch function, which is in the context. And there is this rendered by, which shows which component renders this component, or which component is a parent component. So for sure, this tool makes your life easier with debugging your React application, especially if the application is huge and has many components. One way to deploy React apps is by using GitHub Pages, which is a static site hosting service directly integrated into GitHub. So if you have a GitHub account, you can use it. Otherwise, you can create an account and use it for free. And keep in mind that this feature doesn't support server-side code, so it might not be suitable for dynamic web applications. So here I have the GitHub website open. I will click here on create new and create new repository. And let's type a repository name. For example, let's name it react-deploy and create the repository. Then let's open the command line and create an example React application. So I'm going to use the npx create react app command here, and let's name it react deploy. Then after the project is created, open it in Visual Studio Code and open package.json and add this line here. So we're gonna set this homepage property to this URL. This part of the URL is your GitHub username, and this is the repository name of the repository that we just created previously. Then open the command line again and write this command: npm install --save, then gh-pages, and let it execute. Then finally go back to the package.json again, and in the scripts section add those two lines. The first one is pre-deploy, and the value is npm run build, and the second one is deploy, and the value is gh-pages-d build. So the pre-deploy will automatically run before deploy and make sure that the latest build of the application is deployed. And the deploy command will deploy your website to GitHub Pages. So now we are ready. Let's go back to the command line. Alright, so now let's use the git init command to initialize the repository locally. Then let's add all the new changes using git add all. Then let's commit the changes. Then let's add the remote repository URL. So let's go to the Git website and we can copy it from here, then paste it here. I have a typo, so this should be remote, not remove. Then finally, let's push the changes using git push. And let's run this command, npm run deploy to deploy our website. So now if we go back to our GitHub repository, we can see the code here and we will be able to see this deployments here. So click on it and you will be able to find the deployment that we just did. And this is the URL of our website, so we can copy it and open it in another tab. And you can see now our React app is rendered. Another way to deploy React applications for free is by using Vercel. So you can go to vercel.com and create an account for free. And if you have a GitHub account, you can sign up with it. So now let's deploy the SpaceX LaunchTracker application that we created previously to Vercel. Let's go to the command line and go to the project folder and type this command. So this will install Vercel. Then you have to log in to Vercel. So you're gonna type Vercel, then login. So since I already have an account, I'm gonna select the first option here because I created my account with GitHub. So you will get redirected to the browser, and if the login is successful, you're gonna see this message. Then now type this command, Vercel. So here, enter Y. Then select the scope that you want to deploy to. You can create this scope from the Vercel website. I created it previously, so I'm gonna select this and hit enter. And for this option, we're gonna select no. And let's enter the project name. So I'm gonna keep the default name here, which is the name of the folder. And this also, I'm gonna keep it to the default value because we are already in the directory of the project. And now you can see that it's uploading the project. So now Vercel will detect that your project was created with create React app and will ask you if you want to modify these settings. So we're gonna select no and hit enter. And now you can see that the project is getting deployed. And after the deployment is finished, you can see now it says deploy to production. And those are some links that we can use. For example, this is the link of our deployed website. So let's copy it and paste it in the browser. And here we go. So this is our application from Vercel deployment. We can also open this link to manage our deployment from Vercel website. So let's copy it and paste it in the browser. And here we go. So as you can see, this is the deployment dashboard, and we can view the source code here, for example. So this is the source code of our project. You can see the source files. And if we go back to deployments, as you can see, this is the domain or the global domain of our deployed website. So if we click on it, we will get redirected to our website. Because if we go back to the command line and you can see this URL, this is not the global domain for our website, because if you try to log out from Vercel and try this domain name, you will not be able to open it until you log in. So this is only for you, but this one is the global domain for our project. All right. And here you can see the build logs, for example, of this deployment. And also you can see the runtime logs from this tab here. We don't have any logs, so it's empty now, but this can be useful to debug your application if there are some errors. Hey there, in this section we are going to implement this match the pairs game in React. As you can see, we can start the game. There is a timer that counts how many seconds are there since you started the game. You have to match the pairs. We have some flags of some countries, and you have to match the pairs to win this game. Alright, as you can see, whenever we match a pair of flags, they stay like that. And once all the matches are finished, the game will restart or will reset, and it's gonna store the fastest time you spent so far to win the game. Alright, So for example, now we have 47 seconds. If I win the game other time in less than 47 seconds, this will be updated. For example, if I spend 20 seconds to win the game, this will be 20 seconds, and so on. So now that we understood what we will do, let's get started. Alright, let's start creating the project from the command line. So I'm gonna use the mbx command and create React app. Then let's name it match the pairs. Hit enter and wait until it's created. After it's created, let's go to the app folder and let's start the application. So we're gonna use the npm start command, and you should see the browser open and you should see a window like this. So that means everything is fine for creating the project so far. Alright, so now let's open the project folder in Visual Studio Code, and let's open app.js and remove all the code here. Alright, and let's create a new component. First, let's create a new folder and name it header, and inside it let's create a new file and name it header.js, and this is gonna be the header component, which will display the timer and the start button and the reset button. First, let's start by importing React and create the function component, which is gonna be header. And let's return the JSX code for this component. So we're gonna start with a header, and this is gonna be the title of our game. So let's call it match the pairs. Right, and the next component is the button that will start the game. So let's name it start, and let's create another button to restart. Right, finally let's export this component, and let's go to the app and import it here and render it. Alright, let's go back to the browser. As you can see now, it shows up here, but we still have to do some styling, right, to make it look better. So let's go back and do that, and let's go to app.css and remove all this code. Only keep .app class, alright, because we need this text align center attribute. So let's set a background for our application. So we're gonna use background color and set it to a darker gray color, or excuse me, instead of adding this here, let's add it to the body tag. So let's add the background color here and go back to the browser. Here we go. So let's also change the color of the text to white. So here in app class, let's use color and choose a white color. Now let's go back. Let's style the buttons. So first, let's set the background to none to remove the background, and let's give it a border. So it's gonna be a 2-pixel border, solid, and the color is white, so like this. And let's also add some padding, so 6 pixels and 12 pixels, and border radius, let's add a 4 pixels radius, and let's set the color of the text to white, and let's make the font bold. So let's set the font weight to bold, and let's make the cursor pointer. Now let's save this and go back to the browser. I think it looks better now. but we still can do some color change when we hover over the button. So let's go back and do this. So down there, let's add button hover, hover, and let's change the color to some lighter gray color, so something like that. So now when we go to the browser, we can see that the text color changes when we hover over the button, which looks nicer than without any changes. Finally, let's add some margin to the button to keep some space. So let's add around 2 pixels. And that's it. So now initially everything looks fine. Alright, let's go back to the app and start creating the timer of the game. So whenever we actually start the game, there should be a timer that counts the number of seconds so far. And once we restart, this timer resets and stores the current fastest time, alright? So for example, for the first time, if we solved the game in 30 seconds, this will be stored as the fastest. If we finished it later in 20 seconds, this will be stored as the fastest instead of 30. If we finished it later in 50 seconds, this will not affect the fastest, right? Because the fastest so far is 20 seconds. So we're gonna do this. Now, let's go back to the code. And we're gonna have to use some states here. So the first one is the time. Right, we're gonna assign it to use a state and initially set it to 0. We have to also store a boolean which is indicating if the current time is running. So we're gonna name it is running and initially assign it to false. And we need also another state for the fastest. Let's call it fastest time. We're gonna also initially assign it to, let's assign it to null. And since we want to use the setInterval method in JavaScript, which is an asynchronous method, we have to use an effect hook here. So let's type useEffect. And there, let's store this interval in a variable. So first, we're gonna check if is running, right? Is running equals to true. We're gonna set this interval using the setInterval function, which takes a function as an argument. And we're gonna call here the setTime function to set the time state, alright? So we're gonna increment it. Alright, we're gonna increment the previous time. And we need to call this since we are calculating seconds here. So we wanna call this each 1 second. So we're gonna pass here 1000 because it's milliseconds. And that's it. In case if is running is true. Finally, let's also add a cleanup method. As we learned, it's written like that. When we return here from the hook, that means this is the cleanup function. So we don't need those. Let's just call clear interval and pass the interval variable. Alright. And we want to call this hook each time the is running flag is changed, right? So we're gonna pass this as a dependency here. And how do we update this flag? Through the start game button, right? So let's create the handler for this button. Let's name it handle start, assign it to a function. So we're gonna set the is running flag to true, and that's it. So we're gonna just set the is running flag to true, so that will trigger this hook effect or excuse me, the effect hook, and this will start the interval. All right. One more thing, we want to calculate the fastest time, right? So when do we need to do that? When we click on the restart button, right? So let's create the handler for this button, handle restart. And here we're gonna set the running, or set the isRunning flag to false. Then first we need to make sure that isRunning is true. We don't want to execute this code otherwise. So because the user might click on the button when the game is not actually started. So in that case we set the isRunning flag to false, and we want to calculate the fastest time so far, right? So in case if fastest time equals to null, that means it's not initialized yet, or fastest time is larger than the current time, which is time, right? In that case we're gonna update fastest time and assign it to time. All right, and that's it. So finally, now let's pass those handlers to the header component, and also let's add the labels that will show the timer and the fastest time so far. All right, so here we're gonna type handle restart and assign it to handle restart, and handle start as well. Alright, now let's go to the header component and let's receive this from the props. So we're gonna add the two handlers, handle start and handle restart, which are passed from the app component as props. So we're gonna just add them here to the onClick event, and same for the start button. Right, let's add also two more headers, one for the current time and one for the fastest. So this one is gonna be current time, and this one fastest time, and we need to pass both in the props as well. All right, so let's pass them here from the app component. All right, and that's it. So let's go back to the header component and let's add the time and the fastest time to the props here, and we're gonna display the time here. So we're gonna display it in seconds, and for the fastest time we're gonna do a conditional rendering here, because initially the fastest time is null, right? So we want to make sure that it's not null. So we're gonna check if fastest time does not equal null. In that case we're gonna display it. So we're gonna use string interpolation here. All right, and display it like this, also in seconds. Otherwise we're just gonna display NA. All right, there is no value yet. Before we continue, I had a mistake here, so excuse me about it. This should not be the case here. When we want to update the fastest time, of course for the state we use the setter function. So we're gonna use the set fastest time and pass the time like this. All right, and that's it. So save the file and let's go to the browser. Now let's start the timer. As you can see, it starts to count. Once we click restart, we can see that the fastest time now is 6 seconds. Let's start again. As you can see, it starts from the last value, right? So we should reset the value. So let's go back to the code and do this. So basically in the app component, when we handle the restart, we have to also set the time to 0, right? So let's go here and not here. So after this if statement, we're gonna set the time to 0 to reset the timer, right? Now let's go back to the browser. Let's refresh and start the timer. So now we have 3 seconds. When we restart, you can see that it starts from 0 now. So now let's start and let's stop at 1 second. As you can see, the fastest now is updated. All right. So using this fastest time, we're going to keep track of the fastest time the game was solved. All right. For the user. All right. So now I created this image data folder, which contains 2 parts. The images folder, which contains the images of the flags that we will use in our game, and this image data file, which, as you can see, I imported all the flags here and stored them there in those constants. And we're gonna basically create an array of objects. Each object will consist of 2 attributes: the source of the image and whether it's matched with another one or not. So one is a string, which is the source, and one is a boolean, which represents if it's matched or not. So we're gonna also export this array. So let's create it here and name it card images. And it's gonna be an array of objects, as I said, and the first attribute is a source. So we're gonna start with flag 1, and matched is gonna be false initially for all of them. So we're gonna need this for all the flags. So let's create or copy paste them 6 times. Right. Let's change the values. And that's it. Alright, so we have the array now and we can use it. So let's go back to the app component and create a state for the cards. So we're gonna name it cards and the setter as well. We're gonna initially set it to an empty array. And we want to create a function that shuffles and prepare this array of cards, alright? So we're gonna name it shuffle cards. And we're gonna create a constant, name it shuffle cards or shuffled cards. Right, and we want, so we have 6 flags, right? But we want to double those numbers, right? Or to double those flags, because we have to match the pairs, or we have to match each flag with another pair, another flag. So we're gonna use a spread operator to do that. So we're gonna use it like this and use the card images array that we added in the image data file. So it was automatically imported by Visual Studio Code, and do it twice like this. So we have now an array that contains the array of cards duplicated, right? But we also want to shuffle them, right? So here we're gonna use a sort method, right? Let's use it like this, and we want to like randomly sort this array, all right? We want to swap images randomly in this array. So first we have to pass a function to the sort method, and here we're gonna use math.random minus 0.5. all right? I'm gonna tell you what does it mean. So basically, if this expression returns negative, that means items should be swapped, otherwise they don't swap. So we want to do this 50% of the time. We want to swap the elements 50% of the time, And we know that math.random generates a value between 0 and 1. So when we subtract 0.5 from this value, we're gonna always have a value between negative 0.5 and 0.5, right? Because if it's 1, we're gonna have 0.5. If it's 0, we're gonna have negative 0.5. So this gives us a 50% probability of this value being positive and 50% probability of it being negative as well, which is what we want, right? We want to swap the cards using 50% probability. So that's what we are going to do with the sorting. We also want to give the card a unique ID, right? So we're gonna use the map method here and map each card like this. So I'm gonna use the spread operator to return all the card already existing attributes, and also gonna add the ID. And let's just use math.random here just to give each card an identifier. And finally, we have to set the cards to those shuffled cards, right? So here I'm gonna use the set cards method and pass the shuffled cards. So we initialize this state, right? Have a typo here. There's missing D. That's it. So basically we want to shuffle those cards whenever we start our application, right? So on the first render, we want to shuffle the cards. For that, we're gonna use an effect hook here. So the dependency array will be empty. That means it will be executed only one time when the application or the component is rendered. So we're gonna call the function like this, alright? One more thing, when we restart the game, we also want to reshuffle the cards, right? So here, let's call the shuffle cards method in the handler restart function or handler. And that's it. So now we are ready with the cards objects or the array of cards. The next step is to implement the card component itself, right? So that's what will render the cards in our game. And that's what we will do next. Alright, let's start implementing the card component. So let's create a new folder here in the source directory and name it card. And there, let's create a new JS file and name it card.js. Let's start by importing React. And let's create the function component. So in this component, we're gonna destructure the props. So we're gonna have 4 props variables. So the first one is the card object, right? And the second one is the handler for clicking on a card. So let's name it handle choice, which we will pass by the application component. And flipped, which is a Boolean value that will indicate if we should flip this card or not. Alright, if it's true, we're gonna flip the card. Otherwise, we're not gonna flip it. Alright, I have a typo here. Then finally, another Boolean variable called disabled. So this one will indicate if we should flip this card or if we actually have 2 identical matching cards. So this variable will be true, and that means we have to retain the current state. Alright, we don't flip the card anymore. This is also gonna be passed from the application component, and that's it. So let's assign this to props to destructure it, and let's create the click handler on the image here, which will basically call this handle choice, but it will check for the disabled flag. If it's true, it will not execute this method. Alright, so let's call it handle click. So we're gonna check if not disabled, we're gonna call handle choice. Alright, and that's it. So now let's start creating the JSX code for this component. So we're gonna add a div here, and let's assign the key attribute to card.id. Right, we're gonna add the CSS classes later, but for now let's just add the main elements. So we're gonna have another div here, and this will basically represent the card whether it's flipped or not. It will contain the images, so we're gonna have two images. The first one is the we don't need this closing tag. So the first image is going to be the front of the card, or the cover. So when the card is not flipped, this will show up. So I'm going to use this world map image here, right? But of course you can customize all these images. So I'm gonna set the source to this image like this, and let's also add some other attributes. So let's add all to say card back, and that's it. So we're gonna add the class also later. So we're gonna need another image for displaying the flag of the card itself. So it's gonna be this image, and we're gonna set the source to the source attribute from the card object. Right, and also let's add the alt card front, and that's it. So as I said, we want to display this image when the card is flipped, and when the card is not flipped, we want to display this image. That's what we will do in the next lecture, when we add also the CSS file for this component. So I have created a CSS file here and added the classes for the card. Let's discuss them quickly. So the image will be 100% and 100 for the width and 100% for the height to completely fill the container div. Alright, and we have the card class here. We set the position to relative to make it like a position context for all the children elements, which are the images. Alright, so if we scroll down, we can see that card.front, which is the front image, has position absolute, and then we have styled the image element in the card div. We set the display to block and the cursor to pointer to have the pointer cursor when we hover over this image. Then we configured the front of the card, which is the image that shows the card or represent the card, like the flag of the card, right? So we set the transform attribute to rotate Y 90 degrees to make it initially invisible. So we rotated 90 degrees on the Y axis. We also add this transition to make the transition smooth when we flip the card, right? We have also the flipped class for the front class. So that's what we will add. This class is a class that we will add when the card is flipped. So we set the rotate Y of the transform attribute to 0 degrees to make it visible, alright? We add also some delay because we have to wait until the animation of the other image, which is the world map image, finishes, or the back of the card finishes, alright? Then this is a styling of the card back. So we have also a transition all ease in and giving 0.2 seconds to make the transition smooth, and we have the delay also to wait for the front of the card animation, alright? And when the card is flipped, we want the back to disappear, right? So we're gonna set the transform to rotate Y 90 degrees to make it invisible, alright? And we don't want a delay here because when we transition into this state, we want it to happen immediately, alright? We only have a delay when the card is transitioned from flip to non-flip. And that's it. So now let's go back to the component and add those classes. So this div is going to represent the card div. So we're gonna set the class name to card, and we want to show this or assign the flipped class here based on the flipped flag, right, from the props. So we're gonna do something like this. We're gonna check if flipped is true. we're gonna set the class name to flip. Otherwise, we're not gonna set the class name, right? And for this image, the class name is going to be front, and for this one, it's gonna be back. And that's it. Finally, let's export the card component. And next, we are going to start actually importing the card in the app component and finishing the implementation. Alright, now let's go to the app component and start actually importing the card component and display the cards. So basically, we want to do some things like store the first choice and the second choice. We are matching pairs, right? So we have two choices. So we're gonna have two different states for each choice. One is called choice 1. Initially, it's gonna be set to null. And we're gonna have another state for the second choice, alright? So it's gonna be choice 2. Right, also initially going to be null. And also we have to store a state for the disabled status or flag. So we're gonna create it right here, and this is going to indicate if the two cards are matching, we're gonna disable any flipping. All right, initially it's gonna be false, and that's it. So now let's do some modification to the code. First, let's add a function to handle the choice. This is the function that we passed to the card here. So let's start creating it. This will take the card object as an argument, and we'll decide whether to set it as choice 1 or choice 2. So basically, if choice 1 is already set, so it's not null, we're gonna set choice 2. Otherwise, we're gonna pass also the card. Otherwise, we're gonna set the choice 1, right? And we also need a function to reset everything, because if we match two pairs, we want to reset all the choices, all right? And also the disabled state. And if we don't match, if we select two different flags, for example, we will also need to reset all the choices. So we're gonna create a function here, name it to reset, and let's set choice 1 to null and set choice 2 to null, and we're gonna also set the disabled flag to false. And that's it. We're gonna use this function here in the code, not in the JSX code, all right? So in the component code itself. Alright, so we're gonna also have to create another effect hook that will monitor the values of choice 1 and choice 2. Whenever one of them changes, this hook will execute. So it will basically check if we matched two pairs or not. Let's create that hook down here. Right, so the dependencies are going to be choice 1 and choice 2. And so first thing, we're gonna check if choice 1 dot source equal, or excuse me, first we are going to confirm that both choices are not null to make sure that we have already flipped two cards. So in that case, we're gonna disable any further flipping. So we're gonna set disable to true, and we're gonna check if choice 1 dot source equals choice 2 dot source. That means there's a match, right? Because both have the same image. So in that case, we're gonna have to modify the cards, because we want to set those specific two cards to, or set their attribute, their matched attribute to true, right? If we go back to the image data file, and we can see the array of cards. There are matched attributes, and initially all of them are false, right? Because we don't have matches yet. But whenever we have a match, we have to set the matched attribute to true for both cards. So we're gonna have to return another array of cards with this modification and update the state with this modified array. So first we're gonna use the setCards function, and we're gonna pass a lambda function here that takes one argument, which is the current or previous cards, so before we update them. So we're gonna return the updated cards here. So we're gonna use basically the map function from JavaScript, which will map each card object. So it takes a lambda function, and this lambda function takes one argument, which is the card, alright? And it's gonna map all the cards with this lambda function. So here we can also return the card after modifying it. So first we're gonna have to check if card.source equals to one of those choices sources. So we can pick any one, for example choice 1, it doesn't matter because both are equal. So in that case we're gonna update this card. So we're gonna return the card itself. So we're gonna use the spread operator to return all the attributes of the card and just modify the matched attribute and make it true, right? Otherwise we're gonna return the card without any modification, right? And that's it. So after doing this, we want to reset, right? We want to reset the choices. So here we're gonna call the reset function that we implemented previously. And that's it if we have a match. Otherwise, what do we need to do? So we're gonna add an else statement here. We want to reset, but we want to have some delay, all right? So we're gonna use the setTimeout method and pass the function, the arrow function. And here we're gonna we don't need the curly braces because it's only one line like this. We're gonna call the reset method after 500 milliseconds, all right? That's it. This is gonna trigger if either choice 1 or choice 2 has changed, all right? So now finally we want to render those cards here in the application, right? So after the header, let's render that. So we're gonna also use a def for the cards, and we're gonna set the class name to card grid. And I have added this class to the CSS file, as you can see. So there is a margin top, and we set the display attribute to grid, and we configure this grid using grid template columns to set the layout of the grid. So that means we're gonna have a grid of 4 equally sized columns, and we're gonna have a gap of 15 pixels between each column, all right, or between each item. Now let's go back to the app component, and here in the cards div, we're gonna render the cards, all right? So we're gonna use an expression here between two curly braces and the map function. So we're gonna use cards.map, and for each card we're gonna use a card component, right? So here we're gonna, excuse me, we don't need those curly braces as well. So here we're gonna return the JSX code, which is, we also don't need a return keyword since we added those braces. So first we're gonna have a div, and the key is going to be the card ID. This is like the parent div, because we will have multiple cards, so we want to make them unique using the ID. So we're gonna pass here card.id, and we're gonna actually create the card component here and pass the props. All right, so first we have to import it as well. So let's select, or let's manually import it. So let's go to the top and import it. right? Let's go back and let's add props. So we're gonna add the card object itself and the handle choice method, the flipped. So here we want to say that if this card is either choice 1 or choice 2, or its matched attribute is true, then flipped is true, right? So we're gonna do something like this: choice 1 or card equals choice 2 or card dot matched. All right, in that case we're gonna pass flipped to true. Otherwise, if if all the expressions are false, flipped will be false. If only one of those is true, then flipped will be true. All right, and we're gonna also pass the disabled flag like this. All right, and that's it. All right, and once I started the app, there's an error, so it cannot resolve card. There's a problem with the import here that I added to import the card. As you can see, I have to also add another slash in the name file, the file name. We also need to do some adjustments here in the card component. So first we need to import the card card.css file. All right, so let's do that. And we also have to add the onClick event here in this image to call the handle click method. Right, and in the app component, I have a mistake here. We don't need this curly braces, right, when we import the card component. Now if we run the application, we can see that there is an issue with the images because the alt text is displayed but the image is not displayed. So let's go back and fix it. There is also one more modification here in the card component. So instead of passing the path of the image directly, I imported it here and use this constant here as a source attribute. And also here I didn't add the card object, excuse me about that, so we have to set to this function. Now if we go back, we can see that when we flip the cards, it works. If the cards don't match, they are flipped again back. And yeah, so everything looks fine. We can try to match any two cards like this. For example, as you can see, they don't flip back. So everything looks fine, but we can still do some adjustments. Like first we have to start the game to be able to play, otherwise we can't play. So we have to do this. And also we can add some styling, like to change the colors of those texts to make them more apparent from the title. All right, so yeah, we can go back and do this quickly. So here in this handle choice function, we want to make sure that the timer is running, right? So we're gonna check the is running flag. If it's true, we're gonna execute this code, otherwise we don't execute it. All right, so let's copy this line and put it in the if statement body like this. All right, now if we go back to the game, when we click on the cards, we can see that they don't flip. Now let's start the game. When we click, now it works, right? Let's also change the colors of those labels. So in the header folder, let's create a new CSS file. Name it header.css. And let's add some styling for the h2. We're gonna they are h1, but we are gonna change them to h2. So let's make the color blue, for example. And let's go back and change those two headers to h2 instead of h1. All right, here as well. Then let's import the CSS file here. And save the file. Now if we go back, we can see that the color is not the best choice, this blue color. So you can choose whatever you want, but let's go back and choose a more decent color. So I have selected this one. It looks much better now, but you are free to choose whatever you want. Also, it would be better if we make the size of those cards a little bit smaller, right? Because as you can see, I have to scroll to be able to see all the cards. So let's go back to app.css and add a maximum width of 800 pixels and also margin of 40 pixels auto. So now if we go to the browser, it looks much nicer, right? So let's start. As you can see, now it looks much better. One more thing, we want to restart the game once we win, right? So if all the pairs are matched, let's see what will happen. As you can see, now I matched all the pairs and the timer is still running, right? So we have to stop the timer and update the fastest time. If it's faster than the fastest time, we have to update it after matching all the pairs, right? And this restart button should appear only when we start the game. So let's do these adjustments in the next lecture. Alright, let's do the final adjustments. So we want to restart the game once all the pairs are matched, right? So after we update the matched state here in the cards, we want to do this check. So instead of returning here, we're gonna store this in a constant, right? And return it later. So let's name it updated cards. And here, let's just check. So we're gonna use the every method from JavaScript to make sure that all the cards has their matched attribute equal to true. So we're gonna use the every and pass the arrow function here and check for the matched attribute. So if all the cards are matched, we're gonna call the handler restart method, which will restart the timer, alright? Otherwise, we're gonna just return the updated cards. Alright, so now let's save the file and go to the browser, start the game, and see what will happen after we match the pairs. Alright, so this is the last pair, I will match it. As you can see, it resets right away. And it also updates the fastest time. Hey there, in this section we're gonna implement this painter in React. So we can draw on this canvas, as you can see. Alright, we can also change the color. As you can see, we can change the width of the line that we are drawing. As you can see, we can like increase the width and decrease it, and also the opacity. We can decrease the opacity, increase the opacity. Alright, so interesting. We're gonna implement this in this section, so see you in the next lecture. Let's create the React project from the command line. So I'm gonna use the mbx create react app command, and let's name it painter. Then let's go to the project folder and use the npm start to start the server and make sure that everything's fine. And here we go. So everything looks fine so far. The project was launched in the browser. So let's open it in Visual Studio Code and start coding it up. So let's open the app component and delete those lines of codes. Just keep the main div, which has a class name app. Alright, and let's add a header for the application title. So it's gonna be an h1 element, and let's name it painter. And let's add another div here and give it the class draw area. We're gonna create those CSS classes later. And we're gonna use in this project the canvas element from HTML. which will allow us to draw, right? So I'm gonna render it here. And for now, let's set the width and height of this canvas. So for the width, let's set it to 1280 pixels, and the height to 720 pixels. Right. In this application, we are going to draw following this approach. Whenever the user clicks on the canvas, we're gonna start drawing, and whenever the user moves with the mouse while clicking, we're gonna draw, and whenever the user unclicks the mouse, alright, or in other words, on mouse up, we're gonna end the drawing, alright? So we need to configure 3 events for this canvas. Let's configure them here. On mouse down, we're gonna start drawing. On mouse up, we're gonna stop drawing. And on mouse move, we're gonna actually draw, right? So we're gonna implement those methods later, but for now, let's just create them. So start drawing is going to be a method, an arrow function, and it's gonna take the event as an argument. Let's copy this code and paste it 2 times. This one is gonna be stop drawing, and this one is draw, alright? And we are going to implement those methods later in another lecture, but for now we have the main structure of the application component. Now if we check the browser, we can see that this is how the project looks like. So let's add some styling to make it look better. So let's go to app.css and delete all that code, alright? Just keep the app class, and let's remove this line here. Let's set the width to 100 and the height to 100 VH, meaning the height will be 100% of the viewport height or the entire browser height, right? And let's also set the display attribute to flex so that we can align the children elements in an easy way. And we want to align the children vertically, so let them stack vertically. So we're gonna set the flex direction to column, alright? And also we want the items to be aligned to the top of this div or the main application div. So we're gonna set justify content to flex start, and also let's align the items horizontally to the center. So we're gonna use align items in center, and also let's set linear background. So I just copied the line here. We start with a linear gradient with or at 120 degrees. That means it starts from the bottom left to the top right at 120 degrees. We begin with this color at 0%, then end with this color at 100%, alright? And we can also change the colors. You can change them if you want to whatever color you like. So let's set the second color to light blue like this, for example. And now if we go to the browser, that's how it looks like so far. So just the background image is visible, but we're gonna need all the other styling changes later as well, alright? Now let's go back to the code and style the header. So we're gonna style the h1 header here. Let's set the font size to 50 pixels. And also let's change the color. I will choose this color. Let's see how it looks like. Yeah, not so bad. So feel free to pick whatever color you want. But for this example, let's continue with this color. And now let's go back to the code and style the canvas itself. So we're not gonna actually style the canvas element, but the draw area div here. So we have this draw area class. Let's create it in the CSS file. And let's start styling this. So let's also set its width and height the same as a canvas. So 100 or 1280 pixels for the width, and the height 720 pixels. And let's give it a border. So let's set its size to 2 pixels and solid, and let's set its color to any color that you would like. I'm gonna use this gray color. And let's also set its background color to white and save the file. Let's go to the browser. As you can see now, this is the canvas that we will draw on. So far the styling looks okay. Alright, so we're gonna stop at this point, and in the next lecture we're gonna start the implementation of the drawing functionality. Right, so now we want to do some DOM manipulation on the canvas, right? Whenever we want to do something like that in React, we use the useRef hook, right? So we're gonna do this to keep a reference to the canvas element and also to the 2D rendering context, which is provided by this canvas as well, right? So let's start creating those references. The first one is the canvas ref, and we're gonna assign it to null initially, right? And also the ctx ref, which is a reference to the 2D rendering context of this canvas. All right, so we're gonna also use the useRef hook here and initialize it to null. And we also wanna keep track of some states. The first one is drawing, which is a flag that indicates whether the user is drawing or not. So let's create it. And assign it to false initially. Alright, we need also some other states. So I'm gonna paste this 3 times here. The second state is the width of the line. Alright. And it's initially gonna be 5 pixels, and also the line color. Initially it's gonna be black. Finally, the line opacity. And it's gonna be initially 0.1. Alright, so we're gonna also implement a menu component that will change those settings. Alright, then we also want to initialize this canvas with those settings. So we want this to happen at first render and also whenever one of those settings change, right? So we're gonna use an effect hook here because we're doing some DOM manipulation, right? And the dependency list will be line width, line color, and line opacity. All right. And here in this effect hook, we're gonna store the canvas in a constant. So we're gonna use the canvas ref .current to get the current reference, and also the 2D context. So we're gonna name it ctx and assign it to canvas.get context and pass 2D string as an argument. Then we're gonna set the ctx.lineCap to round. So that means the end of the line will be rounded. We can also add another effect, which is line join, which will make whenever the lines interfere, the corners will be rounded. So let's set it as well. And also let's set the global alpha, which will set the opacity of the line. So this one, we're gonna assign it to line opacity state, alright? And also the stroke style, which is setting the color of the line, and the line width, we're gonna assign it to the line width state. Finally, we're gonna update the ctx reference .current to the current ctx, alright? Whenever any of those attributes change, we're gonna create this canvas context and configure it with those settings, then update the reference, alright? And we're gonna use this reference here in the start drawing and in the stop drawing and also in the draw method. So let's start with the start drawing. What we wanna do here is we wanna start the drawing only. We're not gonna actually draw. So we're gonna use the ctxref and call the current, which represents the current reference, then begin path, which will begin a drawing path. And we also wanna move to the current mouse position, right? So we're gonna again call ctx.current.moveTo, and here we're gonna pass the coordinates of the mouse. So we have the event object here. We can access those coordinates from there. So we're gonna use e.native event.offsetx, and for the y we're gonna use e.native event.offsetY. Alright, finally we want to set the isDrawing flag to true, right? So we're gonna set the isDrawing flag to true, and that's it. For the stop drawing, we're gonna do the opposite. So we're gonna use ctxref.current.stop or close path. This will close the drawing path, and also set the isDrawing flag to false, alright? And that's it. So finally, the draw method, what we want to do here is actually drawing, but we can draw only if the isDrawing flag is true, right? So we're gonna do something like that. If not isDrawing, just return, alright? Do nothing. Otherwise, we're gonna use the line2 method from the drawing context to draw a line from the current position to the specified coordinates. So from the starting position to the position currently that will be specified, which is the coordinates of the mouse, alright? So we're gonna use ctxref.current.line2, and we're gonna pass, for the x coordinate, we're gonna pass e.native event.offsetx, and for the y, e.native event.offsetY. Alright, and that's it. But this function will not actually render this line, so we have to explicitly use the stroke function to render it. Alright, so we're gonna use the stroke function here after the line2 function. Finally, we want to associate the canvas with the canvas ref here, right? Because we're gonna use it here in this effect hook, alright? So let's go back to the JSX code, and here let's set the ref attribute to canvas ref. Alright, and that's it. So save the file and let's go and test our application in the browser. So here we go. Now we can draw. As you can see, everything looks fine so far. Amazing. So what we will do next is we're gonna add a menu that will allow us to change the color and the opacity and also the size of the drawing line. So that's it. See you in the next lecture. Now let's create the menu component. So let's create a new file and name it menu.js. Let's import React. And now let's also create the menu function component. we're gonna receive 3 props attributes in this component: the setLineColor function and setLine width and setLine opacity. So we're gonna pass those from the app component and use them here. All right, so let's just return the JSX code. We're gonna have the main div here, and we're gonna have a label. Let's call it brush color, and we're gonna have an input of type color. All right, so we're gonna set the type to color and the onChange event to setLineColor, and we're gonna pass the value, which is e.target.value. We're gonna have to also create an arrow function. I missed this, sorry. And let's call the function there. Right, then let's also do the same thing for the width of the brush. So we're gonna use a range input here, and we're gonna set the minimum to 3 and the maximum to 20. We actually don't need this. And for the onChange event, we're gonna call the setLine width and also pass the value like that. All right, let's copy that and do the same thing for the opacity. In this input, we're gonna set the minimum to 1 and the maximum to 100. And here we're gonna call the setLine opacity function and pass the value divided by 100, because the opacity range is from 0 to 1. All right, let's change this to 1, and that's it. So let's finally export this component. And now let's go to the app.js and let's render the menu here. It was auto imported by Visual Studio Code. So we're gonna pass the props here, the setLineColor method and the rest of the methods. All right, and let's save the file and go to the browser now. As you can see, it doesn't look good, but we're gonna change the style later. But let's check the functionality. So now let's modify the color. All right, as you can see, it changes the color. We can also change the width of the line. As you can see, we can control the size and also the opacity. So let's increase and decrease. Yeah. So the functionality looks fine, but the style is still missing. That's what we will do in the next lecture. Now let's style the menu component. So go to app.css and let's add the menu class here. And let's set the width to 650 pixels and the height to 50 pixels. And let's also set the display to flex so that we can use the justify content, for example, to add evenly equal space between the elements in this div, and also use align items center to center them horizontally, vertically. And let's add a border radius Alright, let's add 5 pixels. And let's add a background color. I'm gonna add this gray color. And let's use margin auto to center this div horizontally. Right, so we're gonna set the margin value to auto to set it horizontally with the parent container. And also let's give it some margin top, like 10 pixels. And that's it. So now let's go back to the menu component and import app.css. And let's set the class name for this div to menu and save the file. Then let's go to the browser. Now it looks a bit more organized, but if you want to challenge yourself and continue styling it to make it look better, feel free to do that. As I said previously, this course is focused on React mainly, right? So we're doing basic styling here, alright? Let's begin by understanding what is Tailwind CSS. Tailwind CSS is a utility-first CSS framework designed to enable users to create web applications faster and easier. Utility-first CSS means providing single-purpose classes which you can use and combine to style a complete website without the need to write a single line of CSS code. So Tailwind does not provide predefined components like buttons or modals. Instead, it provides those utility-first classes. For example, using traditional CSS to style a button can look like this, and doing the same thing with Tailwind looks like this. This utility class is equivalent to this CSS code, which sets the background color to blue, and this class sets the color of the text in the button to white, and this configures the padding on the y-axis and this on the x-axis, and this makes the button rounded by adding border radius. And you can check the Tailwind website documentation for a detailed documentation of all the utility classes that it provides. But as you can see, this way is much easier and more efficient than using traditional CSS, especially for huge web applications. Let's take a look at how can we configure padding using Tailwind CSS. So as we learned, we use utility classes with Tailwind, alright, to style our components. So those are the utility classes that we can use to configure padding, and those are the equivalent traditional CSS code that are equivalent to those utility classes. And you can take a look at those in the official documentation of Tailwind CSS. So let's start taking a look at an examples. So basically you type the letter P, and then if you want to configure margin top, you can type the letter T, then dash, then the size of the padding. So for example, here we used 6, which is equivalent to 1.5 rem, which means 1.5 of the default size of the browser. So if we want to add padding to a single side, for example, top, we use pt. For padding right, we use pr. For padding bottom, we use bp. For padding left, we use pl, right? So those are for the single side paddings. And dash size of the padding is a standard for all the padding classes, alright? Now let's take a look at the horizontal padding. So if we use px, we're gonna add horizontal padding like this, so for the left and the right sides. And for the vertical padding, we use py, alright? So it's gonna add padding on the top and on the bottom. And if we want to add padding to all the sides like this, we're gonna simply just type p and dash size. We don't type anything else other than p. That's how can we configure padding using Tailwind. Now let's see the margin. So it's pretty similar to padding, but we use the character M or the letter M instead of P. Everything else is the same. So if we want to give margin left, we use ML, margin top we use MT, margin bottom we use MP, and margin right we use MR. And for the horizontal margin we use MX, for the vertical margin we use MY, and for all sides margin we use M only. Now let's take a look at the colors in Tailwind CSS. So those are all the colors available in Tailwind. If we want to use any color, we simply use it by its name, and you can also take a look at this in the official documentation of Tailwind CSS as a reference for you, alright? In case if you forgot any of the colors, or if you want to discover new colors, right? So as you can observe, for each color we have shades, different shades, starting from 50 until 950. So whenever you want to use a color, you type the color name dash its shade, alright? For example, gray dash 50 will give this grade, and gray dash 700 will give this grade, and so on for all the colors. So for example, if you want to change the background color of a div, you can type bg dash then the color name like this. We also have some classes to configure the font size. For example, if we want to configure the font size to 12 pixel, we can use this text-xs or x small, and text-sm or small for 14 pixels, text base for 16 pixels, and so on. You can find all the sizes here in Tailwind CSS website. Alright, so basically you type text dash and the size of the text. For example, configuring those paragraphs here, the first one text-sm, text base, text lg, and so on. So this is basically how we configure the font size using Tailwind. And for the color, we also use a similar syntax, but text dash the color instead, alright? So we have here some examples for some colors. As we learned, whenever we want to use a color in Tailwind, we type the color name dash the shade of this color. For example, this is text dash gray dash 400, which is shade 400 of the color gray, alright? So this will set the font color to this color. As you can see here, this is a preview of the color of the font, and so on. So we can use any color like this. For example, here in this paragraph, we used text dash blue dash 600 to configure its font color to this blue shade, alright? To change the background color in Tailwind CSS, we use the word bg and dash then the property, either its color or inherit, to inherit the parent color, current, which is current color, transparent, which is transparent. Otherwise, we can set the color like this, like we did previously with the font color. So basically the color name and the shade. For example, here this button, we set its background color to this color and this shade of this color using the bg keyword here, or the bg class. And this is how it looks like. We can also add shadows with Tailwind using the shadow class. If we want a small shadow, we can use -sm, and this is for medium or normal shadow, and shadow-md for the medium shadow, and -lg for the large shadow, and so on. So those are all the sizes and the options to use the shadow in Tailwind, and you can take a look at this at the Tailwind website. So here's how it looks like. This is the medium shadow, and this is the large shadow. This is x large and 2x large. As you can see, it matters. As you can see, the difference is in the shadow size. And you can also add inner shadow like this using the shadow-inner. And if you want to remove any existing shadow, you can use shadow-none. In Tailwind, we can use grids or create grids like this. So using the grid class, dash columns, dash the number of columns. For example, here we have 4 columns. So to create this grid, we have to use the grid, then grid dash cols dash 4 to create 4 columns. At first, we have to use the class grid itself, and we can also set the gap size between the grid elements like this using the gap class, and dash then the size of the gap. Tailwind also allows us to style components based on some events, like hover event, for example. So let's say we want to style a button if we hover over it. For example, change its background color. Like this button here, when we hover over it, the background changes, right? So to do that in Tailwind CSS, we simply type hover, then colon before the class name like that. So that means when we hover over this component, add this class, right? Which is here background sky 700. So that means when we hover over this button, it will change its background color to sky 700, all right? And this applies for any other class and any other component, right? So we can also, for example, change the text color when we hover over the button, or change its size or anything else. Now we will see how can we configure Tailwind CSS and use it in a React project. So first we will create a project that we are going to use later when we start working on the card gallery project using Tailwind CSS. But for now, in this lecture, we are going to only configure Tailwind CSS to be able to use it in this project. So in the command line, let's create a new React app. Let's call it Tailwind-card-gallery. Then after the project is created, let's go to the project folder. And now we have to install Tailwind CSS and its dependencies. For that, we're gonna use this command. So we are going to use this command for this. And wait until the installation finishes. Then we're gonna execute this command. And this will generate this configuration file for Tailwind. We can use this file to customize our Tailwind setup, which we will see later. Now we have to configure Tailwind and add some code changes in our project to include it. So let's open the project in Visual Studio Code. Alright, so here I have the project open in Visual Studio Code. Let's go to index.css and delete all those generated code and add those 3 code lines. These directives will inject Tailwind's base and component and utility styles in our project. Alright, now let's go back to the command line and start the development server to make sure that everything is fine. And here we go. So the browser opens and the project now is configured with Tailwind CSS. So we are ready to use it. As I said, we will use this project that we have just created to create the card gallery project later. But for now, let's make a quick test. So let's go back to the code and open app.js and let's delete that generated code. Then let's create a div and configure some classes. The first one is this one. This will set the minimum height of this div to the full height of the viewport. So it will ensure that the div covers at least the entire height of the screen. Then let's also use this class, which will set the background color to gray, specifically light gray. Then let's use a flex class to turn the div into a flex container. So this is equivalent to display flex in CSS. And then items center class, which will vertically center the items in this div. And then justify center to horizontally center the items in the div. Then in this div, let's add a header and say hello Tailwind. And let's also configure some classes for this header. The first one is this one. This will set the font size to 36 pixels. Then this one to make the font bold. And then this one, which will set the text color to a medium shade of blue. And that's it, but we still need to configure Tailwind to include the paths of all the templates in our project. So we have to include the paths of all our components in this project through the Tailwind config.js here in the content property. So let's configure it with this value and save the file. And now let's go to the browser, and here we go. So Tailwind styles are applied to our component, and now we are ready to continue using Tailwind. So here's our card gallery project. It's basically a gallery of some images and title and description, and we're gonna make the design responsive. That means if we resize the window, we can see that the design changes accordingly. So instead of displaying 3 cards on smaller screens, it will display 2 cards, and even smaller, it will display 1 card. So for example, if you open this website on the mobile, you don't have to worry about how it will look like because it will change based on the screen size. Alright, let's begin by creating the card component. So let's create a new file in the source directory and name it card.js, and let's create the component function. And so we are going to create a div here. This is the main div of the component, and let's add some classes to this div. The first one is this one, which will set the maximum width of this div to 384 pixels. So we want to ensure that this card has a width limit and it doesn't expand beyond this. That's why we use this class. And let's also make this card rounded by using the rounded class. And let's use the overflow hidden class to make sure that no images or content go outside the card's borders. And let's also give it some shadow using the shadow class, and we're gonna use shadow-lg to make the large shadow. And let's set the background to white using bg-white class. And that's it for the main div. So the first element in this div is going to be an image, and the source is from the props. So we're gonna use props.image. And let's set the alt from the props as well. We're gonna use the title, which is the title of the card, as an alt for the image. And finally, let's start it with a class. So we are going to use the wfull class, which will make the width of this image equals to the 100% of the parent element, which is this div. Alright? And that's it for the image. Now let's create another div for the title and the description in the card. And let's style it with some classes. We're gonna start with bx-6 to give it a horizontal padding of 24 pixels, and by-4 to give it a vertical padding with 16 pixels. And that's it. Inside this div, let's create another div for the title. So this is gonna display the title from the props. And let's style it. So the first class we're gonna use is font_bold to make the font bold, and text-xl to set the font size to 20 pixels, then mb-2, and this will add a bottom margin of 8 pixels, then text-gray-700 to set the color of the text to dark gray, and then finally text-base, and this will set the font size to the base size of 16 pixels. Then let's create a paragraph for the description, and let's style it. So we're gonna use the text-gray-700 to set the color of the text to dark gray, and that's it. So now we are finished with the card component. Let's finally export it. Now let's go to app.js and use our card component to create the gallery view. So let's open app.js and delete the code that we wrote previously. Let's also delete that import. And let's import the card component. Then let's start by creating the main div and add some classes. The first one is min-h-screen, and this class will set the minimum height of this div to 100 vh or viewport height, and this will ensure that this container or this div will span at least the full height of the screen. Then let's give it a background color using bg-gray-100 to give it a light gray background color. Then let's use the flex class, and let's also use the flex wrap class. This will ensure that all the cards will wrap to the next line on smaller screens to prevent overflow of the cards. Then justify center to center the items or the elements in the div horizontally, and items center to center them vertically. And then the b-4 class we'll add a padding of 16 pixels on all the sides to ensure that all the cards in this div have some space around them. So we use the flex and flex wrap to make the alignments and the spacing of the children elements flexible, and then we align them with the justify center and items center classes. And now we are going to use another div to display the cards, and here we're gonna make this div responsive. That means it can show up on different screen sizes with no problems. So we're gonna use the grid class, and this will display this div as a grid, and each card that's displayed in this div is displayed on this grid. Alright, so we have columns and rows, and we're gonna set the number of elements in each column to make this application responsive. So let's start with grid dash calls dash 1, and that will define a grid with one column. So on small screens the cards are displayed in only one single column. Then md, then grid dash calls dash 2, that means on medium screens we will display 2 cards per row. And then finally lg dash or column grid dash calls dash 3, so that means on larger screens we will display 3 cards per row. And then finally let's add some spacing between the cards using gap dash 6 class, and this will add a gap of 24 pixels between the grid items. Now we are ready to add the cards here in this div. So I have already prepared 3 cards with their props, the title, the image and the description, and I have used those placeholder images from placeholder.com and some example titles and descriptions. So now that's it, we are ready. Let's save the file and go to the browser, and here we go. So here's our application. We have the main background div, and each card is displayed in the grid, and due to using this grid we have a responsive design. So if we try to resize the browser, we will be able to see that the design is responsive. On this screen we have 2 cards per row, and if we make it smaller like this, we have only 1 card per row. And this is the advantage of using the grids with Tailwind to make the design responsive. So if we display it on the mobile screen, for example, we don't have to worry about how it looks because it's responsive, and it will display different number of cards based on the screen size. And that's what we configured using grid calls class here. Set the number of the cards in each row based on the screen size. We can also add custom configuration to Tailwind. We can, for example, add our custom font and use it. So let's go to tailwind.config.js and do that. So here we have this theme object, and there is another extend object where we can add our custom fonts. So we are gonna add a custom font color. So let's add another object here and name it colors, and inside it let's create the name of our custom color. In this case we're gonna call it brand, and we're gonna have to configure the default value for this color and the light and the dark. So I've configured here to some shade of blue, and now we are ready to use this color in our code. So if we go to the browser, here's our cards. Let's say we want to change the color of the title to this new color or the custom color that we configured. So let's go back to the code and open card.js, and here is the div that displays the title. So to add this color to this div, we are going to simply type text dash the name of the color that we configured, which is brand, and that's it. So this class will configure the color of this text to the brand color that we created. So let's save the file and go to the browser, and here we go. So the title color now changed to the color that we created. I have also changed the images of the cards here and used some random images from the internet. So feel free to add your images here just to make the project look nicer and more realistic. And also if we resize the browser to make sure that it's responsive, we can see that the view is still responsive. The images are displayed with no issues. Alright, let's understand what exactly is GraphQL. GraphQL, which was developed by Facebook as React, is a query language for APIs. The advantage of using GraphQL over REST is that with REST we often face something called overfetching or underfetching. For example, a REST endpoint might return more data that we need, or it might return less, requiring multiple requests to get all the necessary data. And this is solved by GraphQL. And we will understand more when we dive deeper in GraphQL. So let's take a look at an example of a GraphQL query. Let's say we have a table called user, and we have many columns in this table, but we are interested only in retrieving the ID, the name, and the email. So with GraphQL, in this case, we're gonna make an HTTP request, and with this request, we're gonna send a query that looks like this. Here we type the name of the table, and between two brackets, the value of the column of the row that we want to retrieve from our API. Then between two curly brackets, we type the columns that we want to retrieve. Alright, in this case we want to retrieve the ID, the name, and the email. With REST APIs, maybe there are many other columns that will be in the response of the API, and we are not interested in those columns. So that is the advantage of using GraphQL, that you specify which data you need, and this data will be the only data that is in the response of the API. To be able to use GraphQL in your React application, the backend service you're communicating with needs to be built following GraphQL specifications. Fortunately, GitHub provides GraphQL API, and we are going to use it as a practice to learn more about GraphQL. And GitHub also provides a way to explore the GraphQL APIs, which is through the GraphQL Explorer. So you can go to the GraphQL Explorer in GitHub using this URL, and you have to sign in with your GitHub account via this button here. Alright, so now I signed in with my account. In the left panel here, we can type our GraphQL query, and we will be able to run this query and see the response here in the right panel. For example, the already existing query that was generated by GitHub by default here is viewer then login. So that means it will retrieve the username of the current viewer or the current user. Alright, so if we run this query, we'll be able to see my username here. Alright, so now using this information, we are going to create another query that retrieves more information about my account. For example, the repositories and the avatar picture and the name and location and etc. So here in the query, we want to retrieve the user, right? So I'm gonna type user here, and between two brackets, I'm going to pass which column I want to find by this user. So here, as if we are saying find by, so I'm going to say login equals to, so login then column, then the string or the value of this column. So I'm going to copy my username here or my login. And of course you can do the same thing for your account, because when you run the auto-generated query, you will be able to see your login here. So let's go between the two curly brackets and type which data we need from the API. So we're gonna type name and then enter, then location, then enter, then avatar URL, which is the URL of the profile picture, then enter. And now we're gonna retrieve the repositories, but we don't want all the repositories. Let's say we want 5 repositories only. So we can do this using the first keyword here between two brackets and column, then the number. So that means we're gonna retrieve the first 5 repositories only. And then we're gonna have to open two curly brackets here and specify which repository data we want to retrieve. And whenever we retrieve data that contains pagination in GraphQL, we have to use the keyword nodes here, and here we have to type the columns of the repository that we want to retrieve. So in this example, we want only to retrieve the name of the repository. Alright, and that's it. So this query will retrieve this user with this login, and will retrieve its name, location, avatar URL, and the first 5 repositories, and the name of the first 5 repositories. Alright, so let's run this query using this button. And here we go. So this is the response of this GraphQL query. So here is the user object, and there is the name and the location. I think I didn't set the location in my GitHub profile, that's why it's null. and this is the avatar URL or the profile picture URL, and the repositories or the first 5 repositories, so the names of the repositories. So as you can see here, the response looks pretty similar to the query, right? So using GraphQL, we are sending a query that resembles how the response will look like. Alright, so we are done with this example using GitHub GraphQL API Explorer. Now we are going to implement a website using React that will allow us to type any username, and the website will retrieve this information about the user and display it on the website. To be able to use GitHub GraphQL, you have to generate a personal token. So to generate that personal token, you have to go to GitHub homepage like this and click on your profile picture on the top right of the screen. Then click on settings. Then on the left, click on this developer settings. And here click on personal access tokens. Then click on fine-grained tokens and click on this button, generate new token. Then you have to enter a token name. So let's name it GitHub-GraphQL, or you can name it whatever you like. Then you can select an expiration for this token, or you can leave the default value. And then finally click on generate token. And as you can see, you'll be able to see that token generated like this. So copy it or keep this page because we will need it later. To be able to communicate with a GraphQL API, we have to use Apollo client in React. That's what we are going to configure in this lecture. But first, let's create the project and install the dependencies. So we're going to use create react app command with npx, and let's name it github-repo-feature. Let's hit enter. Then after the project is created, let's go to the project folder. And now we are going to install Apollo client to be able to use GraphQL. Alright, so we're gonna type npm install, then add Apollo /client. Then also we're gonna install GraphQL and hit enter. Then let's open the project in Visual Studio Code and go to index.js, and we are going to import some packages here from Apollo client. So let's type import, then curly brackets, and the first class is Apollo client, and another class which is in memory cache, and Apollo provider, and finally create HTTP link. And we will see what does each of those do soon. Alright, so now first we have to define the endpoint or the URI for the GitHub GraphQL API. So we can do this using the create HTTP link function here that we imported from Apollo client. So let's do that. Let's create a constant, call it HTTP link, and assign it to create HTTP link. And we're gonna have to pass the HTTP options object. So here we're gonna configure the URI, which is the URI of the endpoint. We're gonna assign it to the endpoint of GitHub GraphQL. And also we have to authorize ourselves to be able to use this API. And this authorization requires the personal token that we created previously in GitHub, alright? So we are going to use it here. So we're gonna pass it through the headers, through the authorization header. So we're gonna create a headers object here and set the authorization. We're gonna use string interpolation here and type peerer, then space. Then here you have to paste the personal token from GitHub. Then the next step now that we have to do is we have to create the Apollo client or an instance from the Apollo client class, alright? And this is the client that we will use to communicate with the GraphQL endpoint here that we created through GraphQL queries. So we're gonna create a new instance from the Apollo client, and we have to pass the options object. So the first thing we have to pass the link, which is the HTTP link object that we created for the GraphQL endpoint here. And the second argument is the cache. We're gonna set it to in-memory cache. This will significantly improve the performance because it will prevent the redundant network requests for the same data. So this is a cache mechanism implemented by Apollo client to cache the data, alright? And that's it. So now we have the client, but we want to make this client available for all the application components, right? So for that, we're going to use the Apollo provider, which is a context provider that will provide this client object to the app component. So we're going to wrap the app component here with this Apollo provider, and we're going to set the client to the client object that we created. And we're going to wrap the app component like this. And that's it. So now all the components in the app will have access to this client. Now let's start the implementation of the main component that will render the HTML page that will allow the user to input a GitHub username and fetch the data and display the user's repository. Alright, so let's go to app.js, and here we're gonna have to import two dependencies. First, GQL, and use lazy query from the Apollo client package, and we will understand what are those soon. Alright, so type from and then Apollo client. So we will use this GQL tag to type GraphQL queries, alright, and we will see how in a moment. And this use lazy query is a hook provided by Apollo client, which defines a lazy loaded query. So what does it mean? It means that it will not automatically execute the query on the component render. Instead, it will return a function that will allow us to call it programmatically and execute the query. Alright, so let's start by creating the actual GraphQL query. Let's call it get user repos, and we're gonna assign it to JQL, then type the query string. Alright, so we're gonna type the query string between back text like this. Alright, and now let's start typing the query. So we're gonna begin with the keyword query and type the query name. So we're gonna call it get user repos. And this query will take one argument, which is the username. So we're gonna use the $sign here and type username. And after colon, we're gonna type the data type, which is string, followed by exclamation mark. That means that this argument cannot be null. Alright, so now we're gonna type curly brackets and we're gonna type which table we are querying. So we want to retrieve from the user table, right? Because we want information about the user. And we want to query by the login. Alright, so we're gonna type login column, and we're gonna pass the username argument here as the login. Alright, then curly brackets, and here we're gonna define which data we are expecting in the response. So we want a profile picture, so it's called avatar URL, and we don't have to type comma or something, just new line and type the following or the next column. Alright, so we want also the name and the repositories. We want only first 5 repositories. Alright, so we're gonna type first column then 5, and here we're gonna type nodes as we learned and type what we want to retrieve about this repository. So we want to retrieve the name and the description and the URL. Alright, and let's also retrieve the ID of the repository to use it later when we render the repositories. Alright, and that's it. So now we have the query ready to be used. Let's add a semicolon here, and now let's move to the app component and create our state variables. So the first one is the username, which will store the current username that the user typed in the input. So let's create this state. We're gonna call it username, and initially assign it to empty string. First, let's import the useState hook from React. Then we're gonna use the useLazyQuery hook, which returns a function that can be called programmatically to execute the query, and also loading, error, and data states to manage the query status. We will see now in a moment. So element that it returns is the function. Let's call it getUserRepos. And the second element is an object that contains 3 states: loading, error, and data. Alright, we're gonna assign it to useLazyQuery, and we're gonna pass the query as an argument. So we're gonna pass the query that we created, which is this one. And that's it. So now let's start typing the JSX code of this website. Let's remove this code and start typing our code here. So we're gonna type first div and style it using inline style. So we're gonna use text align center and also give it a padding of 20 pixels. Alright, and here we're gonna start with an h1 header and type GitHub user repositories. Have a missing O here. And then we're gonna create the input, which will allow the user to type the username. So first we're gonna set its type to text and value to the username state that we created. And let's set the onChange event to an arrow function and call the set username state function to update the state variable with the e.target.value, which is the value of the input. And let's also add a placeholder. So let's type something like enter GitHub username. And that's it for this input. We don't need this closing tag, we can close it here. And now let's create the search button. So we're gonna create a button here and let's type search. So when the user clicks on this button, it will retrieve the data about this username that the user wrote in. So let's type on click, and here let's type handle search, which is a function that we will implement now. So here let's create an arrow function. Let's call it handle search. And let's type get user repos and pass, which contains an object called variables. And this object, we will pass another object that contains the variables that we will pass to our function that we retrieved from the user lazy query hook, right? Which is the username, right? So we're gonna type username and that's it. Alright. So now whenever the user clicks on the search button, this function will invoke and pass the username as an argument and the query will be executed. Alright. So whenever the query executes and retrieves the data, this data state will update. Alright. So we can check if this data is not null. We will display the JSX code that renders the information we are retrieving. And loading means that the query is still executing, and error means that there is an error. So we're gonna use those states here and render the components based on their values. So here we're gonna use conditional rendering, and on loading we're gonna display a paragraph that says loading, and here another conditional rendering, and we're gonna check here if there is an error. We're gonna display the error, so we're gonna display error.message. Alright, and we also will check if data.user to make sure that the API responded with a valid user. In this case, we're gonna render some elements. So the first one is a div, which is a container div, and we're gonna start with the image, the profile picture of the user. So we're gonna set the source to data.user.avatar URL. Alright, so this user object matches with the user query that we created. Alright, this is the advantage of using GraphQL. So this is how the response will look like, exactly the same. Alright, so now let's continue with the image. So let's also add alt here. Let's say data.user, have to add curly brackets, data.user.name, and let's set its width to 100. And let's also add an inline style here. So we're gonna set the border radius to make it rounded to 50%. Alright, and that's it. So let's close the tag, and now let's display the username. So we're gonna use a header here, an h2 header, and display the username using data.user.name. Alright, and now let's render the repositories of the user, and then we're gonna use a UL, and let's add also some inline styling. So we're gonna set the list style type none to remove the bullet points from this list, and also let's add padding of 0. Alright, now let's use the map function to create the list items. So we're gonna use data.user.repositories.nodes.map, and we're gonna pass an arrow function here, and for each repo we're gonna display a list item whose key equals to repo.id, and style, let's add a margin bottom of 10 pixels. And now in each list item we're gonna display the repo name, so we're gonna use repo.name, then the description. Alright, and we also want to display the URL, so let's use hyperlink here and set the href to repo.url, and let's set the target to blank to open this link in a new tab, and let's also set the rel to no opener and no referrer, right, for curing our website. Alright, so that's it. We're gonna wrap this strong tag here with this hyperlink tag. So the repo name will be a URL that redirects to or opens the repo. Alright, before we start, I have a mistake here in index.js. So in the initialization of Apollo client, before in-memory cache, I have to type new keyword to create a new instance from the in-memory cache class here. And now let's go to the browser after starting the development server. Here we go, we can see our components. As you can see, I wrote my username here as an example, and we can see the data, like the picture and the name, but no repositories. But if we go to the network tab in the development tools in the browser, and we can see the API call here, I clicked on it and I could see the response from the API and the repositories are there. So this is not a problem with the query, it's a problem with the implementation in the component. So let's fix this problem. And if we go back to app.js, I have a mistake here, sorry about that. In this arrow function, no need for those curly brackets. Otherwise, if I keep them, I have to return or type the return keyword here, alright? And return this JSX code between brackets, alright, like this. So this is an option, or we can remove this. So let's Control Z and remove the curly brackets. And this will also return this JSX code, right? So whatever you prefer, do it. And now save the file and go back to the browser. And now here we go. So we can see the repositories and the description, and some of the repositories don't have description like this. And we can also click on the link and go to this repository, alright? Before version 16.8 of React, and for your information, the current React version used in this course is 18.3. So before 16.8, components in React were created as classes instead of functions. As you can see here, this is an example project I just created. This is the app component, and as you can see, it's a function component as we learned. So basically, it's a function that returns JSX code and exported and rendered here in index.js, right? So this is how components work currently. But before version 16.8, basically we had to create a class to implement the components in React. Let's see how by converting this component from a function component into a class component. So let's copy this code or cut this code and delete this function. Instead, we're going to create a class and call it app, and this class is going to extend React. First we have to also import React. So it's going to extend React.component. So any class component has to extend React.component. Now, how can we return the JSX code for this component? We have to implement a function called render. This function should return the JSX code for this component. Alright, so we're gonna paste this code that we cut previously that returns the JSX code, and that's it. Now we have a class component. So if we go to the browser, we can observe the same output, as you can see. Of course, there are differences in using props and the state, and we will dive deeper into these differences later. But for now, let's see an example of using props. So let's go back to the code and create another component. Let's call it welcome. Alright, and let's create the class for this component. Then let's implement the render function. And we're gonna just return a header that displays hello plus something from the props. Alright, so now how can we access the props in the class component? Basically the same way, but we have to use this keyword. So the same way as function component, but instead of props directly passed as an argument to the function component, we're gonna access it via this .props. So let's use this .props.name, and that's it. Let's export the component. Now let's import it here in the app component and render it somewhere here. And passing props from the parent to child is the same way. So we're gonna type the name of the prop and pass the value. And that's it. So now if we go to the browser, we can see the component is rendered here and the prop is retrieved and displayed. Let's see an example to understand how state was managed in class components. So in the same project that we used previously, let's create a new file and call it counter.js. Then let's import React and let's create the class component. Let's say this component will display a count and a button to increment this count. So we need to keep this count in a state. So first we need to initialize the state, right? So to create and initialize the state, first we have to do this in the constructor of this class. So let's add the constructor, and as you can see, the props are also passed to the constructor of the class. So we're gonna call super and pass the props, and here we're gonna initialize the state. So we're gonna assign this to the state to an object that contains the count variable and initially set it to 0. So that's how we can create and initialize state in class components. It's one object that contains all the state variables. Now let's render the component using the render function. So we're gonna return a div and a bar graph that displays the count. So we're gonna access it using this to the state.count. This is how we access a state variable. So basically it's an entry in this state object, and then a button to increase this count. So let's handle its on click event here, and now we need to set this state variable, right? So previously in function components we used a function for each state variable to update its value, right? But in class components we use only one function to update the entire state object. Alright, so we have to pass the entire updated state object. The function is called setState and takes the state object as an argument. So here we're gonna update the count to this .state.count plus 1. Alright. And that's it. So this is how we create and initialize state in class components, access state and update state. This is how it's different from function components. Now let's export this component. Then let's render it here in the app component. Let's import it first. Now if we go to the browser, we can see that count is initially equal to 0, and we can increment it, as you can see. Now let's discuss lifecycle methods in class components in React, which allow us to hook into different stages of a component's life. The first one is component did mount, which is called once immediately after the component is added to the DOM, and this method is great for fetching data from an API, for example. The second one is component did update, which is called after the component has been updated due to a change in props or state, for example. Then component will unmount, which is called right before the component is removed from the DOM, and this method is perfect for clean up, like unsubscribing from events or canceling network requests. Now let's practically see some examples of using the lifecycle methods in React class components. Let's create a component that fetches some data from an API and renders this data. So in our project here, let's create a new file and call it data fetcher. And let's start by importing React. Then let's create the class component, call it data fetcher, and extend react.component. And let's begin by the constructor. As we learned, the constructor takes the props as an argument. First we will call the super function and pass the props, and then we're gonna have to store the data retrieved from the API in a state, right? So we're gonna initialize a state object here to an object that contains this data object and initially set it to null. Alright, and as we learned, component did mount method is called once immediately after the component is added to the DOM, and it's a great choice for fetching data from an API, right? So let's implement this function and add our logic here. Then let's call the fetch function here, and I'm going to use an example API from JSON placeholder. Then finally update the state with this JSON object using the this state method. Then let's render the JSX code of this component. Let's use a pre-tag here and display the retrieved JSON. But first let's use JSON.stringify, cast it to string. And that's it. So finally let's export the component. And let's go to app.js and import it and render it here. Let's render it here below the counter component that we used previously in a previous example. And that's it. So now save the file and go to the browser. And here we go. So we can see the fetched data that was retrieved from the API rendered by the component. So going back to the code, component did mount is invoked once the component is added to the DOM or rendered, and it's a perfect choice for fetching data from APIs. Now let's see another example for the component will unmount method, which is perfect for cleaning up, like unsubscribing from events or canceling already ongoing network requests, or for example stopping any ongoing timers. We can apply this example on this component, for example, so that we can abort any ongoing fetch request if the component will unmount. Means it will get removed from the DOM. So at this point we don't want to continue with the fetch request, or it also can be useful in many other use cases to prevent memory leaks. So let's create an instance of, so for this we're gonna use the abort controller. Let's create a new instance here in the constructor. and we're gonna pass this signal of the port controller with this fetch request so that we can import it later. Then let's add the signal keyword here, and let's now implement the component will unmount method. Here we simply will just call this .apport controller .apport. So that makes sure that if the component will unmount or get removed from the DOM and there is an ongoing fetch request, it will be apport. Now we are going to create a website that displays a weather for a city. The user can type a specific city and the website will display the weather information for the city. And we are going to use class components to implement this website, even though function components in React are the modern way to create components, but sometimes you will have to work with projects that's already implemented with class components, so that's a good practice for you. So we are going to use OpenWeather to get an API for retrieving the weather for a specific city. You can create a free account on OpenWeather, and after you create an account, you have to click on your username here and you will see this menu. You have to click on My API Keys and you will get redirected to this page. So you have to copy this key because we are going to use it later in our application, alright? So copy it or just keep it somewhere because we will need it. Alright, now let's go to the command line and create our project. So we're gonna name it weather-dashboard. So let's click enter and wait until the project is created. Alright, after the project is created, let's go to the project folder. And here we're going to install Tailwind CSS because we are going to use it in this project. Alright, so type this command and hit enter. Then let's initialize Tailwind CSS to create the configuration file. So use the command mbx tailwind css init. Then open the project in Visual Studio Code and go to tailwind.config.js, and we need to configure the content here. So add this string to let Tailwind CSS scan all these files, and also go to the source folder, then index.css, and add the Tailwind directives here. Alright, and that's it. So save the file, and now let's start creating our component. So go to app.js and delete this code, and let's start implementing it from scratch using class components. First, import the component class from React. Then now let's create the class component. Let's name it app and extend the component class. And let's create the constructor, which takes the props as an argument. Then we're gonna call super and pass the props, and we're gonna initialize the state as we learned, right? So we're gonna initialize the state to an object, and here we're gonna need some variables like the city name, or we're gonna call it city, and initialize it to an empty string, and the weather, which is the object that we will retrieve from the API from OpenWeather, so it's initially null, and the error if there are any errors later when we call the API. Right, so this is the states that we are going to use for the states variables and the state object. And now then we will create the function that will fetch the data from the API. So let's name it fetch weather data and assign it to an arrow function. So this website will fetch the data for a specific city, which is this city variable here in the state, and the value of this city will be set by the user when the user type the city name in the input. Alright, this is what we will implement later. So we want to make sure that this city is not null. Alright, so first let's retrieve this city by destructuring the state object, and we will check if not city, we will just return. Alright, otherwise we're gonna create another variable, name it API key, and this will be the API key that we copied at the beginning of this lecture. Alright, again, this is the OpenWeather website, and we clicked on the username and selected my API keys from the menu, and we copied this API key. Alright, so now let's paste it here in the code. Then let's create another variable for the API URL. This is the API that we will use from OpenWeather, which will retrieve the weather for a specific city. As you can see, in the URL parameters, we have to pass the city and the API key. Alright, then after that, we're gonna use the fetch function and pass the API URL. Then once the API sends the response, we're gonna check if not response dot okay. That means there is an error, so we're gonna throw a new error here and say like city not found, or maybe we can make it more general and say could not fetch the weather information or the weather data for this city. Let's use double quotes here instead. Alright, otherwise we're gonna return response.json and handle the promise here. So once we receive the JSON data, we're gonna update the state using this state method and pass the new updated state object. So we're gonna update the weather object with the data that we retrieved from the API and error to null, and that's it. But we still have to handle the errors that could happen with the fetch function. So in case if there's an error, we will catch it here, and we're gonna set the state variable, the error state variable, to this error. Alright, and we're gonna set the weather to null, and that's it. So this is gonna be the fetch weather data function. And as we learned, the JSX code of the component has to be returned by a function called render, right, in the class component. So let's implement this function, and again we're gonna destructure the state variable to get the city, the weather, and the error variables from it. Then we're gonna return the JSX code here. So that's it so far. We're gonna implement the render function, or specifically type the JSX code for this component, in the next lecture. Now let's start writing the JSX code for this component. So let's start with the main container div, and let's start it using Tailwind classes here. So we're gonna use the min-h-screen. This will set the minimum height to 100%. This will set the minimum height of this element to 100% of the viewport height. Also, let's give it a background color. Let's give it a gray background color. And also, let's use the flex class to center the items horizontally and vertically. So we're gonna use item center to center the elements in this div vertically, and justify center to center them horizontally. Then we're gonna give some padding using b-6. Then let's create another div here to display the weather information inside this div. Alright, and let's also style it. So let's use the max-w-md to set the maximum width of this element to 448 pixels, and use the w-full class, and let's also set its background color to white. and give it some shadow, so like medium shadow, and let's also make it rounded using the rounded large class, and let's also give it some padding using the p-6 class. Then in this div, let's start with the title, which is an h1 header, and we'll display weather dashboard. Let's also style it. So we're gonna use the text -2xl, set the font size to 24 pixels and make the font bold. And let's also give it a margin bottom and align the text to be centered. And then let's create a form here, and let's just give it the margin bottom class here, and we're gonna start with the input, which will let the user type the city. So its type is going to be text, and the value is going to be the city, which is this variable that we destructured from the state object. Let's set the placeholder text to enter the city name, and let's style it. So we're gonna give it a border, and let's make the border color gray and make it rounded, and let's give it some padding or vertical padding and also horizontal padding, and let's make the width full, and let's give it some margin bottom, and that's it. So we don't need this closing tag, we can just close it here. And now after the input, let's create the button that the user will click to get the weather. So it's gonna be of type submit the form, and let's style it. So let's set its background to blue, let's set the text color to white, and let's give it a vertical padding and horizontal padding, and let's make it also rounded, and let's make its width full. And when we hover over it, we want the background color to be also blue, but a darker blue. So let's increase the shade from 500 to 600, and that's it. So now we can type the text of this button. Let's say get weather data or information. Alright, and that's it for the form. So now let's display the error if there's any errors. So we're gonna use conditional rendering here to check if there is an error. We're gonna display it here in this paragraph. So we're gonna display the error like this, and let's style this paragraph. So we're gonna make the text color red and align the text to be centered. Then after that, we're gonna display the weather. Alright, so we're gonna also use conditional rendering, and check if weather is not null, we're gonna display the following components or elements. So first, let's start with a div, and let's set its class name to text center. Then let's create a header, an h2 header, and here we're gonna display the weather dot name. Before we continue, let's take a look at an example JSON response from this API. So first, we have this JSON object, and it contains the name of the city. So we're gonna display this city name, and you see there is an object called main here, and it contains the temp or the temperature. So we're gonna also display this, and we're gonna display the description of the weather, which is in this weather array, right? So it's an array that contains only one object, and in this object there is a description. All right, so let's go back to the code, and here we're gonna display in this header the weather name, which is the city name, and let's also style it. So we're gonna set the text size 2XL, which is 20 pixels. And let's make the font semi-bold using this class. And also let's give it a margin bottom. Alright, and let's now display the weather temperature. So we're gonna use a paragraph here and display temperature, and then weather.main.temp, then Celsius here. Right, let's remove this space, and let's set the text color to gray, and let's do the same thing. So let's copy this paragraph and paste it, and here we're gonna display the weather description. So we're gonna use weather.weather, which is an array that contains only one element. So we're gonna use index 0, then description, because this element is an object that contains the description string. Alright, and that's it. So now we are done with our JSX code. So finally, let's export this component. And start the development server and go to the browser. As you can see now, everything looks fine. But now the remaining step is to actually implement the event handlers. So when we click on the button, we should get the city weather, and we should be able to write the city name here. Now we will implement the event handlers for the get weather information button and for the city name input. Let's start with the city name input. So when the user type any value in this input, we want to update the state to set the city name to this new value, right? So let's create the event handler here. Let's call it handle input change, or let's name it handle city name input change, and assign it to an arrow function. Then here we're gonna use the set state method to update the city in this state to event.target.value, which is the value of the text box. Right, and now let's go to this input and update its own change event handler and pass this handle city name input change function. Alright, then now we want to handle the on-click event for the get weather information button. So what we want to do here, we want to call the fetch weather data function, right? And as we learned, this is a form, and the default behavior of the submit button is to refresh the page, right? We don't want this, so we're gonna use event.prevent default to prevent this from happening. So let's create the handler here. So let's name it handle weather data submit, assign it to our function, and we're gonna use event.prevent default to prevent the default behavior of the submit button, and we're gonna use this .fetch weather data to fetch the weather data from the API. And that's it. Simply, that's the event handler for the button. So let's update the on-click event handler here, and that's it. So now save the file and let's go to the browser, and let's try to type any city name and click on the button, and here we go. So we get the weather information displayed and everything looks nice. Let's try another city and click on the button, and here we go. So everything is working as expected. React Router allows you to navigate through different views in your application without the need to refresh the page, as you can see in this simple example. Let's start by setting up React Router in our project and implementing a simple example. So first we have to install the React Router DOM package to be able to use it in our project. So write npm install then React Router DOM in the project folder. Then after it's installed, now let's open the project in Visual Studio Code and start coding. So first we have to go to index.js and wrap our app component with the browser router tag. So let's do that by first importing the browser router from React Router DOM package, and then we have to wrap the app component here with this browser router tag. Then save the file and let's go to app.js and add some routes. First, we have to import two classes. The first one is routes and the second one is route from the React router DOM package. So routes is a component that serves as a container for all the routes in the application. Alright, so let's delete that code, and the first thing that we will do is we're gonna create the routes tag here and wrap all the routes in the application here with this routes tag. Then let's start creating our first route. We will use the route component and path two attributes. First one is the path. This is the path of this route. And the second one is element, which is a component that should be rendered when the path is matching the path for this route. So let's type here this component, which we will implement soon. And this is our first route here. So this route represents the root path of the application, which is the home page. Let's create another route for, let's say, an about page. So the path is going to be /about and the component is this about component. So now let's implement the home and the about components. So this component will just display welcome to the home page. Let's export the component. And let's create the about page. This component will return or display about us. Let's finally export it. And let's finally import it here in app.js. And that's it. So now let's start the development server and check the browser. As you can see, once the browser is launched, we can see the home page. If we change the path to about or /about, we will be able to see the about us page without the website getting refreshed. So this is basically the functionality that React Router provides. Of course, you don't have to manually change the path yourself like that. We will see later how can we programmatically do it using buttons or any other from the web application itself. In the previous example, we created two routes, the home page and the about page. And as you saw, we had to change the path manually to be able to navigate through these pages. Now let's modify this example to let the navigation happen internally. To do that, we will use a component called navLink, which is similar to the anchor tag in HTML, but unlike the anchor tag, it does not refresh the page. It will just change the URL and will let the React router handle the navigation. So let's begin by importing the navLink component from the React router DOM package. And let's create a nav tag here. And let's wrap everything in a div. Alright, and in the nav tag, let's start adding the navLink components. We have to configure the to property to the path that this navLink navigates to. So this one will navigate to the home page, which has this path, right? So we will configure the to property to this path, and that's it. So here we will write the title or the text that is displayed by this navLink, which is home. And let's copy and paste and do the same thing here for the about page. And that's it. So now if we go to the browser, we will see both the navlinks here. If we click on home, we will navigate to home, and if we click to about, we will navigate to about without refreshing the page, as you can see. Of course, the style of those navlink components doesn't look so nice now, but we're gonna leave them like that. We care about functionality in this lecture, but of course we have to add some styling to make it look nice. Now let's learn nested routing in React routers. So let's say we have another component called user, and this component will have some nav links to other components. So let's say this one will navigate to profile, and let's add another one that will navigate to settings. Let's wrap those with a div. Then finally, let's export the component. Let's also create the profile and settings components. The profile will just display profile because it's just an example here. So it's just gonna display the profile string in a header. And the same for the settings. Let's create a new file. Alright, so this user component will have those navigation links to the profile and the settings components. Let's change this to settings. Now let's go to the app.js and handle this new navigation here. So we're gonna have to add another route for the user component. Let's import the user component. And we're gonna also add a nav link component to navigate to the user component. Now if we go to the browser, we can see that the user navigation is added here. When we navigate to the user, we can see the profile and the settings navigation links, but if we click on them, we can't see anything. Let's fix that. First, we have to handle the new routes for the profile and the settings here. Since those are children of the user component, so we're gonna wrap them with the route tag for the user component. So we're gonna add two routes here. Set the path for the profile and the element to the profile component. Do the same thing for the settings, and let's import them. Alright, now if we go to the browser and click on the user and navigate there and click on settings, we can see that the path changes, but we don't still see the component, right? That's because we have to do some code modification here in the user component. We have to add an additional component here, which is called outlet. This is a component from React Router DOM package, and this renders the matching child component with its respective parent component. Right, so whenever we have a parent component that has navigations to children components like this, we have to put the outlet component at the end. Now save the file and let's go to the browser and click on user. Now we click on settings, we can see the settings component. If we click on profile, we can see the profile component. If we navigate to about, we can see the about us. Home, we can see the home page, and so on. Now let's see how can we programmatically navigate from the code. Let's say we have a login button, and when the user successfully login, we want to redirect the user to the user component without the user manually redirecting or navigating to the user component. We will see how to do that programmatically from the code. So let's add a button here and let's display login, and let's handle the onClick event here. So we're gonna implement the event handler in this handle login function. Now we want to navigate the user to the user component. So we will not add the actual login logic here, we are just focusing on the routings. So we will consider that the user successfully logged in and we will navigate the user right away. So to do that, we can use the use navigate hook from React Router DOM. Let's import it. And let's create a new instance from this use navigate hook here. And let's use it here. it takes one argument, which is the to argument, and this is the path that we want to navigate to. So we are going to navigate to user, and that's it. So now we can programmatically navigate the user to the user component. Alright, now let's go to the browser and test our code. Here is the login button. If we click on login, we can see that we get redirected to the user component. We can also pass parameters in the URL and capture them in our components. For example, we can pass the user ID to the user component by adding another slash and then the name of the parameter, which is the ID of the user, for example. Now let's go to the user component and capture this parameter. So to capture this parameter, we have to use the useParams hook. So let's import it from React Router DOM package, and we can capture the params here using the useParams hook like this. And let's display the user ID here, this header. So we can do something like params.id. So this is the name of the parameter that we passed via the URL here. They have to match. But then we will have to modify here in the app.js the navlink component and pass some ID. Of course, we have to do this statically now because it's an example, but it should be dynamic in a real scenario. And we have to do the same thing in the handle login button here, which navigates to the user component. Let's pass the same ID, or let's better define the user ID here as a constant. And let's use it here in our code. Like this, right? So let's save the file and let's go to the browser. Now we can see the home page. If we click on user, we can see the user ID here and in the URL as well, as you can see. If we go back to home and click on the login button, we can also see the user ID. Alright, so this is how our online shopping website looks like. We have the products displayed here and we have a responsive design. So if we change the screen size, we can see that the number of displayed products adjust accordingly, and we can view the details of the product. It will navigate to another product details page, and we can also display the user profile. Alright, let's start creating the project. Let's call it online-shopping. After the project is created, let's go to the project folder and let's install React Router DOM. Then let's also install Tailwind. And finally, let's initialize Tailwind. After that, let's open the project in Visual Studio Code and open Tailwind config.js. And here in the content array, let's add this entry. Then let's go to source, then index.css, and add the Tailwind directives. So delete that code and add the first one, which is base and components and utilities. Then let's go back to the command line and start the development server to make sure that there are no issues. So here's the browser and there are no issues so far. So the setup is done correctly and we are ready to start coding. In this project, we are not going to use real APIs. So we have to create some data to be able to use it, right? As a replacement for the API. So we are going to create some JSON files that will contain some data that we can use as a replacement to the API. But feel free to create your APIs if you want. So let's go to the public folder and create a new file, and we're going to call it data.json. And here I'm going to add this JSON, which is an array of objects, and each object represents an item in the online shopping web application that we will create. So I'm going to add some example images to the images folder as well. And if you want, you can copy these images or download them from the Git repository, or you can use your own images. And the same applies for the JSON file itself. You can download it and use it from the Git repository. Alright, now let's set up the React router in the home or the root page of the project, which is the app component. So let's go to source, then app.js, and let's delete those imports and import browser router. And we're going to wrap our routes in this browser router to be able to have access to the history of the navigation. Then routes and route. Alright, and let's delete that generated code here from the app component. And we're going to wrap this app div with the browser router component. And here in the div, we're gonna start creating our routes. So we're gonna create the route component, and the first route we're gonna create is the root route or the home page route. So the path is going to be / and the element is the home component, which we will create later. Let's repeat that for the following 3 routes. So the next one is a profile, and the next one is the product. So this is going to display the product details. So the path will be /product, then /the ID. Here we're gonna pass the ID as an argument to this route, and that's it. So now we're going to implement this home component and the profile and the product details component as well. Let's start creating the home component now, which will display the items that the user can buy in the online shopping application. So let's create a new file in the source directory, and let's name it home.js. And let's start importing the useEffect and the useState hooks. And let's also import the link component from React router DOM. This will allow us to navigate programmatically from our code to another component or another web page. So the first thing that we need to do is we need to create a state for the products or the items in the online shopping, right? So it's going to be an array of products. So let's create the state and call it products. And initially assign it to an empty array. Then we're going to call the API, which is fake API, which is the JSON file that we created, but we still will treat it as an API. So we need to handle a side effect here using the useEffect hook. And in this useEffect, we're gonna fetch the data from data.json that we created previously. Then we're gonna cast the response into a JSON object. Then finally, we're gonna update the state using setProducts and pass the data as an argument. And we need this to be executed only once the component is rendered. So we're gonna pass the dependency list here to the useEffect hook as an empty array. Now let's start with the JSX code of this component. So let's start with div, and let's give it some classes to style it. The first class is container, which will center this div and will set a maximum width based on the screen size. Then let's add mxAuto, which will set some horizontal margins to effectively center this div. Then let's add some padding to all the sides of this container using the b-4 to add a padding of 16 pixels on all the sides. Alright, so now let's move to the header, which will display online shopping. And let's add some classes. The first one is text-3xl, which will set the font size to 30 pixels. And let's use font-bold to make it bold, and text center to center the text horizontally. And finally MB-6 to add a margin bottom of 24 pixels. And now let's create the grid that will display the products. So it's gonna be a div, and let's style it. So the first class we will give is grid. That will allow us to define rows and columns for this grid. So let's start with the columns. We're gonna type grid-cols-1. This will set the grid to have only one column by default, so on small screens. Then sm column grid-cols-2. This will change the grid to have 2 columns on small screens. Let's do the same thing for the medium and the large screens. So for the medium, we're gonna type md, and we're gonna type 3 to make it have 3 columns in medium screens. And we don't have to handle anything else now. This also applies to larger screens. And let's add some gaps between the items or the products. So we're gonna use gap-6, and this will set the gap between the grid items to 24 pixels. So to display all the products, we have to use the map function to map each object from the data that we retrieve from this JSON file to a div or a product card div. So we're gonna use a JavaScript expression here and type products.map, and for each product we're gonna add this div, and this is going to be the main container for the product card. So we're gonna set first the key attribute to the product ID. This is used as a unique identifier for each product, so this will help React to effectively update and re-render only the components that have changed, rather than re-rendering the entire list if there is a change in the products. Then let's style the div. So we're gonna add some classes. The first one is border, to add a border of 1 pixel around the cart. Then let's add some padding using b-4 to add 16 pixels padding inside the cart here. And let's make this card rounded and add a shadow. And we want, when we hover over this card, the shadow to become larger. It makes it like it's raised when we hover over it. So we're gonna use hover, then colon, then shadow -lg. So that means when we hover over this card, we're gonna change the shadow from shadow to shadow large to make the shadow larger. And we can make the transition smoother here by using transition. Then let's add the image of this product. Its source is going to be product.image, and alt is going to be product.title. And let's now style it. So let's give it a fixed height using h-48 to set its height to 192 pixels. And let's make the width full using w-full to make the width full to its container. And let's use this class object-cover. This will ensure that the image covers the entire area of the container while maintaining its aspect ratio, so it may crop the image to achieve this. And let's add some margin bottom using mb-4. This will add a margin bottom of 16 pixels. And let's also make it rounded. And that's it for the image. So now let's move to the title, which is an h2 header that will display the product title. And let's add some classes. The first class is text-xl. This will set the font size to 20 pixels. And let's also make it bold using font-bold. And let's add some margin bottom using mb-2. And this will separate this title from the rating, which we will add now. So let's add a paragraph, and let's type rating, column, then product.rating. and let's style it. So we're gonna just add this class text-yellow-500. This will set the text color to yellow, specifically 500 shade, which is a shade of yellow. We have from 100 to 900, which is basically the intensity level of the color. And then after that, we're gonna add the link to this product, which will open the product details page. So let's use the link component here to navigate to this product details page and set the to the path of this page. So we're gonna use string interpolation, and we're gonna add /product, then slash, and the product ID. This is the path that we set previously for the product details page. So let's add the product ID here, and that's it. So now let's add the text here, which is view details, and let's style it finally. So let's set its color to a shade of blue, which is 500, and when we hover over this link, we want it to be underlined. So let's add hover, then column, then underline. And that's it for the home component. Finally, let's export it. Have a typo here. And now let's go to app.js and import it. And that's it. So now we have the home component. We still have to implement the profile and the product details components. If you want to check the progress so far, you can comment or delete temporarily those two lines and save the file and go to the browser. And here we go. So that's how the home page looks like now. We have the products in a grid, and whenever we hover over a product, you can see that the shadow gets bigger, and the design is also responsive. If we try to resize the page, we can see that it adjusts automatically based on the size, as you can see. Alright, and that's it. So let's go back to the code and put the two lines again. And alright, now let's create the product details component. So let's create a new file in the source directory and call it product detail, and let's import the useEffect and useState hooks. Then let's import the useParams hook, because we are going to get the ID of the product from the parameters passed through the router. Then let's create the function component. And here we're gonna get the ID from the useParams hook. So we're gonna destructure the object retrieved from the useParams hook and get the ID like this, because that's what we only interested in now. It's the only parameter. And let's also add the state for the product that we are currently displaying in this page. Let's initially assign it to null. And now we're gonna also call the API, which is the JSON file in our case, to get the product with this specific ID. We're gonna use the useEffect hook here, and we're gonna use the fetch method. And now we will find the product with this specific ID. We're gonna store it in this found product constant, and we're gonna use the find method in JavaScript to iterate through the items in the data that we have and return an item that matches the condition that we will implement in this arrow function, which is if item.id equals to the ID that we have. So we're gonna parse it into integer using parseInt method. Right, so if we found this product, we're gonna use a setProduct method and pass this product. So here we're gonna pass it in case if we found it or not, because it will be null anyways as it was. And here, when do we need to call this useEffect hook? Whenever the ID changes, right? So we're gonna add the ID to the dependency list here for the useEffect hook. Sorry, I added it in the wrong place. Should be here. Alright, we didn't handle if this product is null, right? So let's handle it here. If not product, we're just gonna display loading. So a paragraph that says loading. Alright. This is conditional rendering. So if we don't have the product yet, we'll display loading. Otherwise, we will return this JSX that we will write now. The main container div here. And let's configure the class name to container to center the content and set the maximum width of this container. And let's also add mx-auto to add auto margins on the left and the right. And let's also add b-4 to add some padding to all the sides of the container. Then let's reuse the same header that we used in the home page for the title. Let's go here and copy it. And we're just gonna change the margin bottom to 4, and we don't need to center the text, so we're gonna remove this text-center. And let's add the image. So the source is going to be product.image, and alt is product.title. Then let's style it. So we're gonna use w-full to make the width full, and h-auto to ensure that the height of the image adjusts proportionally based on the width. This is to maintain the aspect ratio of the image. And also let's use object cover to make sure that the image covers the entire container while also maintaining its aspect ratio. And let's add some rounding corners to the image to give it like a smooth look. So we're gonna add rounded-lg, and then let's add some shadow to add a medium shadow, and let's add finally some margin bottom, and that's it. So let's close the tag. Now let's move to the product description. So it's gonna be a paragraph that displays the product, the description, and let's add some classes here. Let's set the text size to 18 pixels using text-lg, and let's add some margin bottom using mb-4. Then let's also display the price of this product. So we're gonna use a paragraph, and class name is going to be text-2xl to set the font size to 24 pixels. And let's use font semi-bold. And let's also set the text color to a shade of green. And let's add some margin bottom. And we're gonna display here the product dot price. Then let's add a button, which is going to be the add to cart button. And let's style it. So we're gonna set the background color to a shade of blue using bg-blue, and set the color of the text to white. And let's give it some padding using by-2 to add a vertical padding of 8 pixels, and bx also -4 to add a horizontal padding of 16 pixels. And we want to increase the shade of the blue when we hover over this button, so we're gonna type hover, then column, then bg-blue-600, and let's make the transition smoother using transition. And that's it. So now if we save this file and go to app.js, let's delete this file for now, and let's go to the browser, and let's click on the view details of any product. As you can see, we see the image in full size, then the price, and then add to cart. There's still one mistake here. I have a typo for the description. Now if we go back to the browser, we can see that the image is in full size. there is this description of the product and the price and the add to cart button. And we can add the $sign here to the product price, make it look more obvious. And now everything looks good. If we go back, we can see the list of the products and we can view details and see the product details. So let's go back to the code and go to app.js and restore the profile route here and save the file so that we will implement it in a moment. Now let's start implementing the profile page. I also created a JSON file for the user data and added some example JSON data here. So let's create a new file in the source directory and call it profile.js. And let's import the use state and useEffect hooks from React. Right, and let's create the function component. And let's create the state variable for the user that we are displaying in this page. And let's fetch the data from the JSON file. Then invoke the setUser function to update the user state here. And let's pass the dependency list to the useEffect hook as an empty array because we want this to execute once the component is rendered only. And we're gonna check if the user is null, we're gonna return loading as we did previous product details page. Then let's return the JSX code here. So we're gonna start with a div. And this is gonna take the container class to center the content horizontally and set the maximum width to adapt to different screen sizes. And let's also add some auto margins on the left and the right to center this div horizontally with its parent component. And let's add padding with 16 pixels to all the sides of the container. Then let's create a div for the profile section. And this is gonna have the flex class, which applies the flexbox layout model. This makes it easier to align and distribute the space among items in this container. And we are gonna also use the flex-column to set the direction of the flex items to a column to stack them vertically. And then items-center to center them horizontally. And let's begin by the profile picture. So it's gonna be an image. And we're gonna set the source to user.profilePicture and the alt to profile and the class name. We're gonna set the width of the image to 128 pixels using W-32 and the height also to 128 pixels using H-32. And let's make it rounded using the rounded full class. And let's add shadow and also margin bottom. Alright, and let's then display the user name. Let's also style it. So we're gonna set the font size to 30 pixels using text-3XL and make the font bold and give some margin bottom 8 pixels. And let's also display the email of the user. We're gonna set the text color to gray and give some margin button. And that's it. So finally, let's export the component. And now finally, we want to add a button that will allow us to go to the profile page. So let's go to home page and add this button. And as we learned, to navigate programmatically to another route, we have to use the useNavigate hook. So let's import it from React router DOM here, and then let's create a constant here and create an object from this use navigate hook. So we're gonna call it navigate and assign it to use navigate. And then we're gonna create a function to go to the profile page. We're gonna call it go to profile. And simply we're gonna navigate to /profile. Alright, then let's add the button to go to the profile here, right below the online shopping header. And we're gonna set the onClick event to go to profile. And let's add some styling to this button. So let's add a green background and set the text color to white and add some vertical and horizontal padding. And let's make it rounded and add some effect when we hover over the button. And let's make the transition smooth. And that's it. So save the file and let's go to the browser. And as you can see, we see the button now. Let's click on it. We can see the profile, and let's go back. Let's click on view details. We can see the details of the product and everything seems to be fine so far. So that's it. We are done with implementing our online shopping website. Of course, you can feel free to add more styling and make it look as you wish to practice also your knowledge about Tailwind CSS. Next.js is a React framework which offers features like server-side rendering, routing and API routes, data fetching, and many more features that allow you to build production-ready applications in an efficient way. So why should you consider using Next.js over plain React? There are several reasons for that. First, SEO benefits, which is a challenge that React apps face because they rely on client-side rendering, while Next.js relies on server-side rendering. That means that when the server receives a request for an HTML page, it renders this HTML page and sends it back to the browser fully rendered, which can be then displayed immediately. And this significantly improves SEO. Then improved performance by handling the rendering on the server, because that makes the rendering of the website quicker. Also API routes. So if you need an API for your application, Next.js allows you to create API endpoints directly in your project, and static and dynamic content, which allows you to mix static and dynamic content depending on your case. Alright, so now we will open the command line, and the first thing that we will do is we're gonna install the npm, which is a package manager used by Next.js. So type npm install, then -g, then npm. Alright, then we're gonna create our Next.js project. This is a command line that I'm gonna use. I'm going to use npx and create next app, and its name is going to be Next.js dashboard. And the example flag here is used to clone the starter example from Next, which is provided by Vercel. So we're not gonna write code from scratch. Much of this code is already written in this example, and this will help us to focus on learning the main features of Next.js without worrying about writing code. Of course, we will have to write some code, but we're not gonna write all the code from scratch. Alright? So this is a command, and you can copy this command from the resources, or you can pause the screen and type it, whatever you like. So let's click enter, and now we're gonna type y here to install the required packages. Then wait until the project is cloned and created. And after the project is created, let's open it in Visual Studio Code, and let's take a look at the project structure here. First, we have this app folder, which contains all the components in our application. And there are some folders in the app folder, like the lib folder, which contains all the functions used in our application, such as, for example, reusable utility functions and data fetching functions. Then we have the UI folder, which contains all the UI components in our application, and the public folder that contains all the public static files or assets, like the images, for example. And finally, we have the seed folder, which contains a file called route.ts. And this file creates a server-side endpoint that you can access in the browser to start populating your database. Alright, so we're not gonna use this for now. So let's move to the files. We have here this next.config.mjs, and this is a configuration file for next.js. It's automatically created. Sometimes you have to do some modifications in the configuration, but we don't need to change any configuration in this example. In this example, we have some placeholder data because we're not gonna use actual APIs. So this placeholder data is located here in lib folder in the placeholder-data.ts. As you can see, those are some data or JSON objects that we are going to use in our example. And as you can see, this project is created in TypeScript, but don't worry if you don't have any knowledge about TypeScript. I'm going to explain the TypeScript code, and you can still create applications with Next.js without having to use TypeScript because it supports both JavaScript and TypeScript, and it automatically detects whether you're using JavaScript or TypeScript and installs the necessary packages accordingly. Alright, so now that we went through the folder structure of our project, let's go back to the command line and start the server. Alright, so now let's go back to the command line and go to the folder of the project, and let's begin by installing the project packages using npm -i. And then after that, we are going to start the development server using npm -dev. As you can see, the server started at port 3000, so we can copy this link and paste it in the browser, and this is how the page should look like by now. So if the page look like this for you, then everything is fine so far. As you can see, the home page doesn't have any styles yet, right? So let's go back to the code and change that. If we go back to the code, in the app folder, we will see this UI folder, and there's this global.css file, which is the global styling for our application. So this file can include all the CSS rules to all our routes or components in the application. And as you can see here, in this file, there are the Tailwind directives because this application uses Tailwind to style the components. So if we add the Tailwind directives like this, all the components in our application will have access to Tailwind classes. So how do we include this file in our application? We have to go to app, then layout, this file, which is the root layout of our application, and include or import the CSS file here. So let's type import and the path of this file, which is app/ui/global.css. And in next.js, we have to add this character before the path, and that's it. So let's save the file, and if we go back to the browser now and refresh the page, we will be able to see that this is how it looks like, and of course it looks nicer. But what if we are not using Tailwind? In this case, we can use CSS modules, which allow you to scoop CSS components to each component, so you don't have to worry about style collisions. Alright, so each component will have its own CSS styling. Let's see an example. So let's go back to the code, and in app, then UI, let's create a new file and let's call it home.module.css. And here let's add some CSS code. So the class shape will configure some border and the height and the width of a div. Now let's see how can we use this in our component. So we have the components here in the app folder. Let's say we want to modify here the page code and add a div here, for example. And this div will be styled using the class that we have just created. So first we have to import the CSS file that we have just created. As we learned, we have to start with the @ character. And now we can go here to the div and configure the class name. As you can see here in this JSX code, we have the same syntax as React because Next.js is based on React. So class name, and then we're gonna type here. Now let's configure the class name to the class we have just created. So we're gonna use styles dot then the class name, which is shape, and that's it. So now if we save the file and go to the browser, we will be able to see here the shape that we have just created. Using custom fonts in your project can affect the performance, especially if the font files need to be fetched and loaded. And there is a metric called cumulative layout shift, which is used by Google to evaluate the performance and the user experience of a website. And with fonts, layout shift happens when the browser initially renders text in the system font and then swaps it for the custom font once it's loaded. And this swap can cause the text size and the spacing and many other things to shift and appear in not a very good way. So Next.js automatically optimizes the fonts in our application when we use the next/font module. It will download the font files at build time and hosts them with other static assets used in our application. So that means when a user visits your application, there are no additional network requests for fonts needed. And this of course improves the performance. Let's add a custom font in our application. Let's go back to Visual Studio Code, and in the UI folder here, let's create a new file called fonts.ts, and we're gonna use this file to track all the fonts in our application. And let's begin by importing the font, which is enter from next/font/Google. Have a typo here. Then let's finally create an instance from this font and export it. So we're gonna export constant. Let's name it enter and assign it to a new instance from the enter class. And here we also had to specify which subset we would like to use, which is Latin in this case. Alright, so now to be able to use this font, we're gonna go to layout.tsx, which is the root layout of our application. And as we did with the CSS file here, we are gonna do the same thing for the font. So we're gonna import it. Then how do we apply this font throughout the whole application here? So simply we are gonna configure the class for the body. And we're gonna use a string interpolation here and type enter.className. Then let's also use a class from Tailwind called anti-alias, which will smooth out the font. And that's it. So now if we go back to the browser, we will be able to see that this font is applied in our application. And we can also add fonts for specific elements or components in our application. For example, we have this Acme logo component, which uses this font only here in this component. So we're gonna do the same thing. We're gonna go to fonts.ts and we're gonna also import this font. Or actually we don't need another import line because it's in the same package. So we're gonna just type comma here and type Lusitana and export it the same way as we exported the enter font. And we're gonna configure this font. So we're gonna pass the weight and the subsets like this. Alright, and save the file. Alright, now we can render this component without any issues because the font is now added to our application. So let's go back to page.tsx and here let's render the Acme logo. So let's uncomment this line and save the file, and let's go back to the browser to make sure that everything's correct. And here we go. So this is the component. Next.js provides an image component which has many advantages over the traditional HTML image component, such as preventing layout shift automatically when images are loading, resizing images to avoid shipping large images to devices with a smaller viewport, lazy loading images by default. That means images load as they enter the viewport, not when the HTML page is rendered, and also serving images in modern formats like WebP and EVIF. So let's use the image component in our application. Let's go back to Visual Studio Code, and if we go to the public folder, we will be able to see two images, Hero Desktop and Hero Mobile. And those images are completely different, and they will be shown depending if the user's device is a desktop or a mobile. We will see how to do this. So first, let's go to page.tsx and import the image component that we're gonna use, which is provided by Next.js. Then if we scroll down, we will see this comment, add hero images here. So let's add this image here. So we're gonna use this image component, and let's add some configuration. First, the source, which is gonna be /hero-desktop.png. And let's adjust the width to 1000 and the height to 760. Then the class name to hidden, then md::block. So hidden here is to remove the image from the DOM on mobile screen, and md::block to show the image on desktop screens. Alright, that's why we configured it like this. Then finally, let's add the alt to this string, and that's it. So save the file and let's go to the browser, and here we go. So the image is rendered, as you can see. As I told you, we configured this image to be hidden in mobile devices, right? So let's make sure that this is the case. If we open the development tools in the browser, I'm using Firefox, but any browser you use should include the same feature. If we open the mobile design here, we will be able to see that the image is hidden. Alright, and if we switch it back to desktop, we will be able to see the image. So now let's add the image for the mobile device. Let's go back to the code, and let's copy the same image component here and paste it here. And this one is going to be for the mobile, so we're gonna use hero mobile, and the width is going to be 560 and the height is 620. And now we're gonna change the class. This is the key here. So instead of hidden md::block, we're gonna add here block, then md::hidden. So I hope you found the hint here. So we're simply saying in small screens here, hide the picture, and in medium screens or large screens, show the image. And here, vice versa. In small screens, we display the image, and in medium or large screens, we hide the image. Right? That's what it means. Alright, so now if we go back to the browser, let's now switch to the mobile view. Now we will be able to see this image right here. Pages in Next.js are organized in a file system like approach. For example, our website will have a page for the dashboard, and there is another nested route in the dashboard for the invoices. So this is how the URL will look like. As you can see, this is how the folder structure will look like in our project. So the app folder will map to the root segment, which is our root website URL. Then the dashboard folder will map to this segment, which is /dashboard, and the invoices folder will map to /invoices. So, and for each folder we have to include a file named page.tsx, and this will contain our code that renders this page. Alright, so for the root page of our website, we're gonna add page.tsx in the app folder, and for the dashboard, we're gonna add page.tsx in the dashboard folder. This is gonna render /dashboard, and so on. Alright, so this is how it works in Next.js. So let's go back to Visual Studio Code and add those pages. So here's our app folder. Let's create a new folder here and name it dashboard. And in this dashboard folder, we're gonna create the page.tsx file, which will export the React component that renders this page. So that's how we're gonna create our React component. We're gonna name it page, and we're gonna return the JSX code, which is just gonna render a text, let's say dashboard page. All right. And that's it. Now if we go to the browser and try to type /dashboard and hit enter, we're gonna see the dashboard page. All right. So since we created the dashboard folder and exported the JSX code in the page.tsx in this folder, our route is automatically created for us for this page, as you can see. Now, as an exercise for you, you can pause this lecture and create another 2 pages, one called customers and one called invoices inside the dashboard page. All right, so those are going to be nested components that are rendered from the dashboard component. All right, so pause the lecture, try to do it by yourself, and then let's continue. All right, so we're gonna do it the same way. We're gonna create a new folder here in the dashboard folder and call it customers. And we're gonna create another page.tsx here in this folder. And we're going to export the component that renders this page. So it's gonna be the same like the dashboard page, but we're gonna type customers page instead. And the same for the invoices page. So we're gonna create a new folder in the dashboard folder, call it invoices. Create page.tsx there. And do the same thing. So we're gonna export the React component and we're gonna type here invoices page. All right. So now if we go to the browser and try those URLs, here's the URL for the invoices page. And as you can see, it's rendered here. Let's try for the customers. And here we go. So the customers page is also ready. So now since both the customers and invoices pages are in the dashboard page, what about creating a side navigator that we can use to navigate between those pages? All right, so let's do that by going to the dashboard folder and creating a new file called layout.tsx. So this layout file is a special file that you can use to create UI that's shared between multiple pages. So here we're gonna share it between the customers and invoices and the dashboard page, which is the parent page of both those pages. All right, and this is going to be the side navigator. So here let's start by importing the side navigator, which is called side nav, from the UI components that's already created in this project. And now let's create the component for this layout. So it's named layout and it takes one argument, which is the props, and in the props there is an argument called children, and every child can be either a page or another layout. In our case, automatically the customers and invoices pages are going to be nested in this layout. All right, so this is gonna be the children prop. Then we're gonna add some divs here. I just prepared them. And here we're gonna render the side navigator. So we're gonna use the side nav component. And I forgot to add the return keyword here. So let's add it. And that's it. So this side nav component now will render all the children pages rendered in the dashboard page, which are customers and invoices pages. So if we save the file and go to the browser, we will be able to see the side nav here and the pages. We have the home, which is the dashboard page, invoices, and customers. And one benefit of using layouts in Next.js is that on navigation, only the page components update. So if I click here on invoices, the invoices page will get re-rendered, the same for the customers. However, this layout will not re-render. All right. Now let's do one more change in our dashboard layout. As you can see here, if I click on customers, the page refreshes, as you can notice. The same for invoices, the same for home. Alright, if we go to the code, we will be able to see why, because here in this nav links component, which is used in the side nav component, we're using hyperlinks for each page. Alright, so instead of that, let's use another component that will not refresh the page when we click on it. So it's named link. Let's import it. And this component will act the same way as the hyperlink, but it will not refresh the page. So let's replace the hyperlink here with the link component. Everything else will remain the same. Now if we go to the browser and click again on the pages, invoices, customers, we can see that the page does not refresh anymore. Even though parts of the application are re-rendered on the server, but there is no full page refresh. And one more thing, a common UI pattern is to show the active link to indicate to the user which page they are currently on. So let's go back to the code and do this change. And we're gonna use a hook called usePathName. Let's import it. From next/navigation. And to be able to use it, we have to turn this navlinks component into a client component. So to do that, we're gonna go to the top here and type use client like this. Then let's create a constant here and name it path name and assign it to use path name hook like that. Then we're gonna use a library to do some conditional CSS styling. It's called CLSX. So let's import it. And here, let's go down to this link and we're gonna assign a class based on the current link. If it matches to the current path, which is this path name, we're gonna give it a specific style or class that will highlight it. Otherwise, we will display this class that we created before. So we're gonna give it some classes based on the current link or URL. If it matches the path name, we're gonna style it to highlight it. Otherwise, we're gonna keep those classes that we used previously. So this is how it looks like. We're gonna wrap the styling here in the CLSX function. And this is the common styling, alright? And then comma and the conditional styling, which is going to give it a different background color and font color based on the current link.href, which represents the current URL. If it equals or matches to the path name, we're gonna highlight it using this style. And here we go. So now if we go to the page, we can see that the current page is highlighted. And if you faced any issues at this point, you can try to restart the development server, because there are some random issues that are solved when you just restart npm or the development server. If it's not solving the issue, feel free to post a question in the Q&A section and I will respond as soon as possible. Alright, now we are going to set up a database using PostgreSQL, which is provided by Vercel. But for that, first we have to create a GitHub repository and push our code there. So if you don't have a GitHub account, you can create one for free. And this course is focused on React and Next.js, so we're not gonna discuss details about GitHub. But it's super easy to create an account on GitHub and continue with the following steps. This will make it easier to set up our database and deploy our application. So here's my GitHub account. I'm going to create a new repository and name it Next.js-example. And click on create. I'm going to leave everything else as it is. Then I'm going to follow these steps to push the code to this repository. Alright, so let's go back to the command line and I'm going to go to the project folder and then type git init to initialize a git repository locally. Then I'm gonna add all the files using git add, then dash, then dot to add all the files. And then I'm gonna commit those changes or those files. I'm going to set the message of the commit to initial commit. Then I'm going to add the remote repository here using the remote add origin. And then I'm going to push those changes. Have to use this command instead. Alright, now if we go to the repository to make sure that everything is uploaded, here we go. So our code is uploaded to our GitHub repository. So now the next step is to create an account on Vercel. You can create an account for free if you don't have, and you have to link your GitHub account. So you can simply just sign up with your GitHub account on Vercel and it will automatically be connected. Then as you can see, we can see the repositories in our GitHub account. So we can just click on import on the repository that we have just created and leave everything as it is and click on deploy to deploy our application. And then after the deployment is finished, you can see this window afterwards. And now by connecting and deploying our application, whenever we push any change to the main branch, Vercel will automatically redeploy the application. And that's a great advantage to use Vercel to deploy Next.js applications. Alright, so now we're finished with the deployment. Let's start creating our Postgres database. First, let's click on this image to make sure that our website is working correctly. And here we go. So this is our website served from the server. Now to create the database, we have to click on continue to dashboard. Then we have to click on storage. And here, let's click on create Postgres database. And you can read this agreement and accept it. Then we're gonna leave the region as the default region and click on create. Then let's click on connect. And that's it. So now we can see this window. Click on this .env.local. Then click on show secret and then copy snippet. Then go back to Visual Studio Code and you can see this .env.example file. Let's rename it to .env only. Alright, and let's open it and delete all that code and paste the code that we copied before. And we don't want to upload this file and show our database details in GitHub repository. So let's go to .getignore and make sure that this file is there. So as you can see, .env files are ignored and not pushed to GitHub. So that's fine for now. Alright, now let's populate this database with some initial data. To do that, we can go to the app folder and we will see this seed folder. Inside it, there is this route.ts. And this code will create the records in our database. So, but before we uncomment it, let's scroll down and you can see this file. Let's remove it. Right, like this. And that's it. So save the file after uncommenting. But as you can see, we still have to install some dependencies. So let's go to the command line and in the project folder, let's type pnpm, then I, then this, which is Vercel Postgres database. So let's click enter and install it. And that's it. So let's now start the development server. And let's open this URL. So the root URL /seed and leave it for some time, and eventually it should display this database seeded successfully message, which means that the database is created and the data is initialized in this database. Then after that, you can feel free to delete this file. Now let's explore our database. Go back to Vercel and make sure you click on this data here on the side nav. Then let's click here in this text box and we will be able to see the tables that we have. For example, let's click on users and we will be able to see the user here. And let's click on another table like the customers. Here we go. So those are the data that were populated by seeding our database. And you can find this data here if we go back to Visual Studio Code and go to the app.lib folder, then placeholder data.ts. Here we will be able to find all the data that we have seeded. Now that the database is ready and populated with data, it's time to fetch this data in the application. In Next.js, we can use React server components to fetch data from the server. We can use async and await syntax without the need for using useEffect hook or useState hook, for example. So this is what we are going to use, and we will use Vercel Postgres SDK, which allows you to write database queries, basically SQL. So if you go to app then lib then data.ts, you will be able to find this SQL queries written here by importing the SQL function from Vercel Postgres. So we can use it like this. For example, this function fetches the revenue. As you can see, it uses the SQL function and then the SQL query like this. So we have all the functions that fetch the data from the database implemented here in the example project, and we are going to use them and render the components that use them or display the data that's fetched by them. And as you can see, all these functions are using the async and await syntax. So when we use them, we have to use them in server components that support promises. Alright, so now let's go back to the dashboard and add some code changes there. So go to app then dashboard then page.tsx, and let's start importing some components. So we're gonna import the revenue chart component. Let's also import the Lusitana font. Then we're gonna delete this code and add new code. We're gonna start by the main component, and we're gonna use an h1 for the title. And let's pass here the font that we imported. We're gonna use Lusitana.className and add some other classes as well, like MB4 for the margin button and text XL. Alright, and let's type here dashboard. Then let's add another div here and style it like that. And here we're going to render the revenue chart component, which takes a prop, which is the revenue. And this revenue is retrieved from the database. If we go to data.ts again, we can see the function that retrieves the revenue here. So we're gonna use this function to retrieve the revenue and pass it to the component. First, let's import this function. Right, and let's use it here. But this function is asynchronous, right? So we're gonna use the await keyword here, and we're gonna have to change this component to support asynchronous execution. So we're gonna type here async to make it an asynchronous component or server component. Then we're gonna pass the revenue here to the revenue chart component. And then finally, let's go to this component, which is in the UI folder, in dashboard, then revenue chart, and let's uncomment this code and all the commented code here as well. And that's it. So now if we go to the browser and to the dashboard component or page, we will be able to see this chart right here. Now we're gonna render another component which gets the latest 5 invoices sorted by date. So let's go back to the dashboard page, and here let's import this component, which is called latest invoices, and its fetch function from the data file, which is called fetch latest invoices. Then we're gonna fetch the latest invoices here as we did for the revenue. Alright, and then we're gonna render the component here. And I forgot to add a wait keyword here. And the same thing, we're gonna go to this component and uncomment the code there. So let's go to latest invoices.tsx in UI then dashboard and uncomment all these code lines. Alright, then save the file and go to the browser, and here we go. So this is how it looks like now. Now finally, let's go back to the code and render the card components, which will display some information like the amount of invoices collected and pending invoices and so on. So let's go back to the dashboard page, and here I'm going to insert another div here with the same classes that I gave to this div previously. Then I'm going to add the cards components here. And I'm gonna import the card component. Alright. So we have a card for total paid invoices, another one for total pending invoices, number of invoices, number of customers. And we're gonna get all these information from a function called fetch card data from data.ts. So let's import it. And this function returns an object that contains all these variables. So we're gonna destructure them. But first let's import this function, which is called fetch card data. And here we're gonna destructure the returned value from this function. So to use those variables directly here, we destructured them from the returned object from this function. And the same thing, let's go to dashboard folder in the UI folder and uncomment the code in the cards component. Then save the file and go to the browser. And here we go. So we have cards that display this information. Alright, so now we're gonna create a blog website using Next.js, and we are going to use a PostgreSQL database to store our data. We're gonna create this database using a website called Supabase for free. So you can go to this website and log in or sign up with your GitHub account. It's pretty easy to do that. Then you will get redirected to this homepage. You have to click on new project and create a new project here. For the project name, let's type blog website. And you have to type the database password here. So type the password. Then select the closest region for you and click on create new project. Then you will get redirected to this page. You have to wait for some minutes until the project is set up. Alright, and then after the project finishes setting up, you can go to the left sidebar and select SQL editor. And let's create the table for the posts in our blog application. So we're gonna type create table, then the table name, which is posts, then brackets. Then we're gonna type the columns in this table. So the first column is the ID of the post, and this ID should be unique for each post. So we're gonna use the data type UUID, which is an abbreviation for universally unique identifier, and this will ensure that each ID value is unique across the table. And also we're gonna make this column the primary key. So we're gonna type primary key, and we want to create a default value whenever there is a new post created for the ID. Alright, so we're gonna create a default value for the ID because the user doesn't have to enter the ID by themselves, right? So we're gonna type default to specify that we have to create a default value for this column, and then we're gonna use a function here to create a random ID. It's called UUID generate v4. Alright, so this will create a unique identifier for each post whenever a new row is inserted. And that's it for the ID. So let's now create the title of the post, which is gonna be of type varchar, and let's type the length 255, and we're gonna also type not null to make sure that this column cannot be null. And then we're gonna create the content column, which is the content of the post, which is gonna be of type text and also not null. And then the date of the post, so it's gonna be of type timestamp and also not null. And this date column should also have a default auto-generated value, right? So we're gonna type default, and then we're gonna use the now function, which returns the current date and time at the moment of insertion. Alright, and that's it. So those are all the columns in our table. So let's run this query, and you should see this message, success, no rows return. Now if we go to the table editor from the sidebar here, we can see our posts table. We can click on it and see our columns here. Alright, so now let's create the project and install the required dependencies and also connect to the database that we have just created. So let's create the project using the npx then create next app command, and let's name it Next.js -blog and click enter. Then type y and press enter again. And for this project we're not gonna use TypeScript, so if you see this question, just select no and click on enter. And also for the ESLint, click no. For the Tailwind CSS, select yes, because we are gonna use it to style our application. For the source directory, select no. And for the app router, select yes, then no. For the customize the default import alias, and wait until the project is created. Then after the project is created, let's go to its folder, and we're gonna use a dependency called Prisma, which will allow us to connect to the database and query this database. Alright, so let's type npm install then add Prisma, then / then client. Then let's also install the Prisma package, which is used for the CLI and the development tools. So we're gonna type npm install Prisma, then --save-dev. Then we have to initialize Prisma to create the necessary files. So we're gonna use npx Prisma init, and now we have to configure the database URL. Alright, so let's open the project in Visual Studio Code, and here's the project, and now we're gonna go to this env file, and you see here this database URL. We're gonna replace this auto-generated URL with our database URL. So let's go back to Supabase and let's get the database URL from here via the left sidebar. We can go to project settings, then database, and we will be able to see the URL here. So copy this URL, go back to Visual Studio Code and paste it here, and you will have to change this your password here with your actual password. Then now we have to configure the schema of our database locally so that Prisma can be able to work with this database. Alright, so let's go to the Prisma folder here and then schema.prisma, and we're gonna create a model for the post, which is the table that we created in our database. Alright, so we're gonna have the ID, and notice that this model is the local model. Alright, so it's the local version of our posts table. Alright, so it's not actually the table. So here we're gonna use a string as a data type for the ID, and we're gonna use the @id to specify that this is the primary key, and also the default to specify that it's auto-generated, and pass the UUID function here. And this db.uuid specifies that the ID field is stored as a UUID in the database. Alright, so that's it for the ID. Let's go to the title, which is gonna be of type string, and the content, which is string as well, and the date, which is of type date time, and it also gonna be using the default because it's auto-generated, and the function to generate this is the now function, which returns the current timestamp. Then let's go back to Visual Studio Code and do one more modification. So here in the schema.prisma file, let's add here another entry, which is direct URL, and assign it to inf, then brackets, then between double quotes direct underscore URL. And let's go to the env file and add this direct URL. So we're gonna get this direct URL from Supabase. Though let's go back to Supabase, and here you can see in the database settings this connection string that we copied previously. There is this display connection pooler set to transaction, the mode. So let's change this to session mode and copy this URL and paste it here, and also add your password here, and go back to the command line. And now let's run this command. This will migrate our database and synchronize our Prisma schema with our database schema. So click on enter. Then when you see this message, select yes. Then now it's time to populate our database with some data. So we're gonna use the seed file for that. So in the Prisma folder, let's create a new file and call it seed.js. And you can download this file from the resources of the lecture, because we don't have to worry about the code here because it just populates some data. So it's out of scope for this section of the course. And then go back to the command line and type node, then Prisma / seed.js. Then to make sure that everything is successfully finished, let's go back to Supabase website. Then from the sidebar, let's select table editor and select the post table, and you will be able to see the data. Alright, now let's create the API that will retrieve the posts from the database. And we can use this API to render the posts in our home page. So to create an API in Next.js, we're gonna use API route. So simply in the app folder, let's create a new folder and name it pages. And in this folder, we're gonna create another folder called API. And each folder in this API will map to an API route, right? So let's create another folder in the API folder and name it posts. So this is gonna be the posts API. So to create the handler for this API, we're gonna create a new file and name it index.js. And here, the first thing that we will do is we're gonna import Prisma client. This is the client that we will use to retrieve the data from the database. So we're gonna create a constant here, name it Prisma, and assign it to an instance from the Prisma client class here. Then now we're gonna create the handler that will handle this API request. So we're gonna export and default and then async function and name it handler. And this function takes two arguments, rec and res, which is the request and response objects respectively. So here we're gonna check first if the request.method equals to get. We're gonna handle the request here. So we're gonna wrap this code in a try close, and here we're gonna retrieve the posts. So we're gonna create a constant, name it posts, and assign it to prisma.post.findMany. Alright, so this will fetch the posts from the database, all the posts. Then now we're gonna prepare the response object. So we're gonna first use the res.status function and set the status to 200, then the JSON, and return the posts here as a JSON object. Alright, and that's it. So now let's catch if there is any error using catch error here, and we're gonna use res.status return 500, and the JSON, and return a JSON object that contains one item with a key error and a message for the error. Let's say failed to fetch posts, and that's it. And then finally we're gonna disconnect from Prisma client, so we're gonna use prisma.disconnect. There is a $sign at the beginning of this function. And now if this request is not a GET request, we're gonna return a different response. So we're gonna set the header allow to an array that contains one item, which is GET. And we're gonna also return the response with status 405 and use the end method here, and we're gonna just return method not allowed. Alright, that's it. So this is the API that will retrieve the posts, and we are going to use this API in our home page. One more thing before we test this API, let's do a correction here. I did something wrong. So this pages folder should not be in the app folder, it should be in the root directory. Right, so now as you can see, this is the root directory of the project. There is this page folder, then APIs and posts, then the handler for the posts API. Now let's go to the command line and run this command, npm run dev. And now if we go to the browser and try the API URL like this, we're gonna see this error because I have a typo, so sorry about that. Let's go back to the code and fix it. Here I missed to write new. So now let's save the file and go back to the browser. And here we go. So now we can see the response from the API, and we are ready to use it in our component. Alright, now let's start creating the posts page. So in the pages folder, let's create a new file and name it pages.js. Alright, so what we want to do is we want to fetch the posts from the posts API and send it to this component, the pages component, via props. This is what we do in React, right? But in Next.js, we're gonna do a more optimized approach. We're gonna fetch the data on the server side to ensure that the page is rendered with the data already when it's displayed to the user, right? This improves the SEO and the load time of the page so much. So how do we do that? How do we fetch the data on the server side and ensure that it's already there and provided to the page when requested by the user? We're gonna use a function named getServerSideProps. Alright, let's start implementing this function. So here we're gonna type export async function. It's an async function because it will fetch the data from the API, and its name is getServerSideProps. Alright. So when a request is made to the posts page, Next.js will run this function on the server, fetches the data from the API, which we will implement right now, and then pass the props to the posts page and renders the page and prepare it so that when the user makes the request, it's already rendered and populated with the data. Alright, so this, as you can imagine, improves the load time a lot. So let's proceed with the implementation. We're gonna type a try keyword here, and we're gonna call the fetch function and fetch the data from the posts API that we created and store it here in this constant. Then we're gonna cast it into JSON and store it in another constant. The JSON function is also asynchronous, that's why we typed await here. And that's it. So if everything goes fine, this function will return the props for this component. Alright, so we're gonna return an object that contains the props, which is containing the posts. Alright, otherwise if there is an error, so we're gonna catch this error and we're gonna use console.log to log it. And then we're gonna also have to return the props, right? But we're gonna return an empty array for the posts. So we're gonna return props, or object that contains props, and this object will contain the posts, which is an empty array. Alright, and that's it. So now the get server side props function is implemented, and we are ready to start our component implementation. So let's start implementing it. So we're gonna return a div and a header. Let's type blog posts and a list. Then let's type a JavaScript expression here, and we're gonna use props.posts dot map, so that we can map each post to an li tag. So here we're gonna type the li tag, and the key is going to be the post ID. Then we're gonna display the post title here in a header. Then in a paragraph we're gonna display the post content. Then let's create a small tag and display the date. So first we're gonna create a new date object and pass post.date as an argument, and then we're gonna convert this date object to local date string here and display it. There is no need for this semicolon, so let's delete it. And that's it. So before we test our code, I have a mistake in the name of the file. I don't know why did I name it pages. Maybe I confused it with the folder name, but it should be posts. Alright, and also make sure that it's in the pages folder, not in the posts folder. Alright, so I fixed this mistake now. So the file name is posts and its location in the pages folder. Alright, now if we try our application and go to the posts page, we can see that the page is rendered here, but still there is a problem. There's an error that says text content does not match server rendered HTML. That means that the data rendered in the client side is not matching with the data rendered in the server side. If we go back to the code, it's because of this date here. So the output might be different from the server to the client depending on the local settings for each. So we have to standardize this date. So we're gonna have to change the date here like this to make it match with the server side date. So we're gonna use this ENUS local, which is the United States English, and we're gonna display the date in this format and save the file. Then now if we go to the browser, we'll be able to see our page here with the posts rendered. Alright, now let's add some styling to this page using Tailwind CSS. First, let's go to the command line and go to the project folder, and then let's install Tailwind CSS. Then after it's installed, let's initialize Tailwind. Then let's go to the Tailwind configuration file here and make sure that this is how it looks like. So this content configuration has the same configuration like this. If not, then modify it and add those configurations. Then let's go to app, then globals.css, and make sure that Tailwind directives are there. Finally, then let's go back to the command line and start the development server again. And then let's go back to the posts page code and start styling our application. Let's start with this div. So we're gonna set the class to container, and let's add some auto margins on the left and right using mx auto. And also let's give some padding, so horizontal padding and also vertical padding. Then let's move to this header, and we're gonna set the font size to large using text-4XL, and let's make the font bold using font-bold and center the text. And let's also give a margin bottom of 8. Then we want the items here in this list to be displayed in a grid fashion, alright, or a grid layout. So to do that, we're gonna set the class to grid and set the gap between the items to 8. Then on medium screen, we want this grid to have 2 columns. So we're gonna type md, then grid dash cols dash 2. And on larger screens, we want this grid to have 3 columns. So we're gonna type lg column grid dash cols dash 3. Then let's move to the list item here and add some classes. So let's make the background white using bg dash white, and then let's make it rounded, and let's also add a shadow, and let's use the overflow hidden class to hide any overflowing content from the post. Alright, and then we're gonna have to wrap all these components here in a div to add some padding. Alright, so we're gonna add a new div here, and we're gonna give it some padding. This will add padding of value 6 around the content inside each postcard. Then let's copy those components inside this div. Then let's start with the header. So let's set the font size to 2x large. Let's make the font semi-bold. Then let's add a margin bottom. And that's it. Let's move to the content of the post and give a font color. So let's give it a gray color of shade 700. And let's also give it a margin bottom. And finally, let's set the date style. So we're gonna use text gray 500 for the font color. Finally, let's import this CSS file here. And now let's go to the browser. As you can see, now it looks much nicer. Alright, now final change that we have to do, which makes more sense, is that we only have this posts page in our application, right? If we remove the slash posts, we will get redirected to the auto-generated page by Next.js. So we don't want this. We want to display the posts page as a root page for this application. So let's go back to the code and do this. So simply, let's just remove page.js from the app folder here. Let's also remove this layout.js file, and we're gonna rename this posts file to index.js instead. So this will make the page get displayed as a root page. Alright, so we don't have to type slash posts. And now if we go to the browser, we can see that the posts page is now displayed as the root page for this application. Alright, so now it's time to deploy our application to Vercel. First, open your GitHub account and click on new to create a new repository for this application. And let's name it Next.js-blog. Then create repository. And then let's copy this line here. We will use it later. Then in the command line, let's go to the project folder and let's initialize a git repository locally using get init command. And then let's add all the files in this folder and commit. Let's set the message of the commit to initial commit. Finally, let's paste the command that we copied previously and hit enter. Then finally, let's push the changes. So let's type git push, and we're gonna have to use this command instead. So let's copy it and paste it. Now go back to your GitHub account and make sure that the repository looks like this, so all the files are uploaded. Then let's go to the Vercel website. We have created an account previously on this website using GitHub account. So here in the homepage, let's click on add new and then project, and you will be able to see the new repository that we have just created here. So click on import, then deploy, and wait for the deployment to finish. And here we go. So after the deployment finishes, we can see our website. So we can click on this or right click and open a new tab you will be able to see that there are no posts like this and it looks weird, right? That's why we're gonna have to do another change. So let's go to the dashboard of the project, then let's click on settings, then environment variables, and here we're gonna have to set some environment variables. If you remember, we removed the .env file from the Git repository by adding it to the gitignore file, right? Or actually we didn't add it, we just made sure that it's there and it was already there, right? So this file has some environment variables and they are missing now, so we have to set them via Vercel. Alright, and here, so we can directly import this env file by this button here. So let's click on it and import the file, and as you can see, it already populated the environment variables here. So let's save by this button, and we still have to do a change in our code. So if you open the index.js or the posts page, you can see that here the API URL is localhost column 3000, and this is not correct after we deploy, right? So we're gonna use the environment variable for the API URL and set it via Vercel as we did for the database URL. So let's copy this here and go to the .env file and add it. Let's call it API URL. And let's go back to the posts page and use this URL. So we can access it using process.env, then the variable name. Now save the file and start the development server to make sure that everything is working fine locally. And if we go to the browser, we can see that we have the same output, so everything is working fine. Now let's go back to Vercel and we're gonna configure this environment variable. So we can copy this URL from any deployment, which is a common domain for all the deployments. And let's go back to settings and environment variables and add this environment variable. So the key is going to be API URL and the value is going to be this domain that we copied /API. And let's add the HTTP prefix here and click on save. Alright, now let's go back to the command line and let's add this change that we created to retrigger a deployment with the new code changes. Alright, so let's add the pages folder, then commit and push. And now if we go back to Vercel and check the deployments, we will be able to see a new deployment triggered here because we added a new commit. Let's wait until the deployment finishes, and in the command line, let's also run this command to deploy our database. Now if we try the URL of the API, we can see that there is an internal server error. We can see this error by going to the deployment page and checking the runtime logs here. We can see that there is an error with the Prisma client initialization. If we click on it, there is a suggestion that we have to run this Prisma generate command because with Vercel built there are some dependencies caching and this leads to outdated Prisma client. So let's go to package.json in our project code, and here in the scripts let's add a new line, which is this line. Then let's commit and push this change. And this will trigger a new deployment, so let's wait until the deployment finishes. And now finally, after the deployment finishes, we can see that the preview is looking good. And when we visit the website, we can see the posts are displayed now. So we had to debug and redeploy many times, but this is a good exercise for you to get used to debugging and fixing errors. So I hope you found this useful. So we have created an API to retrieve the posts from the database, right? But now we are going to create another API to create a post. We're not gonna actually create another API, but we will create another request method here. So the method that we have currently is the get method. We're gonna create another method, which is a post method. When we call this API with a post method, we're gonna create a new post. Alright. So right here, let's type else if, and check if request.method equals to post, then we're gonna handle this request. So we're gonna send the title and the content of the post in the request body, right? So let's destructure this from the request body. We're gonna destructure the title and the content from request.body. Then now we're gonna add a try block here, and we're gonna try to create this new post in the database. So we're gonna create a new constant and assign it to prisma.post.create. So this will create a new post in our database, alright? And we will have to pass the data that we want to create, which is an object that contains the title and the content. Alright, so as you can see here, we pass this data object to the create function, and this object contains the fields and the values of the new record to be created in the database. In this case, it's the title and the content. And of course, we use the await keyword here because this function is asynchronous, alright? Alright, so now it's time to return the response. So right here, we're gonna return the response and set the status to 201, which is created, and also set the JSON of the response to the new post that we added to the database. Alright, then let's catch any errors that happen when we try to add a new post to the database here. So we're gonna console.error this log, and let's also print the error. Then we're gonna set the response status to 500 and the JSON to the message of the error, or let's just say error creating the post. Alright, that's it. So now we have the API ready to create posts as well. Let's change the allowed methods to add the post as well, and that's it. So next we are going to implement the create post page in our front end and use this API that we have just created. Now we will create the add new post page. So in the pages folder, let's right click and create a new file, and let's call it add-post.js. Alright, and here we're gonna import the use state hook, and also we're gonna import the use router hook from Next.js. Then let's create the component. So we're gonna type export default to export it as well, and the function, let's call it add post page, and we're gonna create our states. So we're gonna need state for the title, the content, and the error and the loading. So I have prepared them here. So this state for the title of the post, and this is for the content, and this is for displaying an error if there is an error with communicating with the API, and this is the loading state, which is indicating if the response of the API is returned or not yet. Alright, then now we're gonna create the router. Then let's return the JSX code of the component here. So we're gonna set the class of this dev2 container, because this is the main container dev, and add auto horizontal merging, and let's also add some padding. And here in this div we're gonna start with a header which will display add new post, add a new post, and let's add some classes. So we're gonna set the text size to 2XL and make the font bold, and also give some margin bottom. Okay, and now we're gonna create the form that will submit the new post. We're gonna give it the class space -y-4. This will give a space between the children of this form, and then we're gonna create a div here, And in this div we're gonna create a label and display the title here. So we're gonna use the HTML4 here and set it to title. This will improve the user experience because when the user clicks on this title, the browser will automatically focus on the associated input, which is the title input that we will create in a moment. Alright, then let's style this label. So we're gonna add some Tailwind classes. So let's add the block class to display it as block, and text-sm to set the font size to small, and font medium or dash medium to set the font weight to medium. And also let's set the color to gray of shade 700, and that's it. Alright, now let's move to the input, and this is gonna be a text input. So we're gonna set the type to text and the ID to title and the value to the title state that we created, and the onChange event we're gonna set it to an arrow function, and we're gonna call the setTitle state function to update the state variable. So we're gonna pass here e.target.value to update this state with the value of the input. We're gonna also add the required because this is required and cannot be empty. And finally let's style it. So we're gonna add margin top and also set its display to block and make the width full using w-full and make it rounded. And let's add a border, a gray border of shade 300, and let's add also some shadow, and that's it. So now let's create another div. So actually we are going to copy this code and paste it here and do some modifications. So this label, instead of title, we're gonna type here content, and the styling will be the same. And let's change the text to content, and for this input it's gonna be a text area instead of input because the content might have more characters than the input allows. And then here we're gonna change the, so we don't need this type anymore. We're gonna change the ID to content and the value to the content state, and on change event we're gonna set the content instead of the title. And also we're gonna keep the required, and we're gonna keep the styling the same as the input. So let's remove this closing tag here and close it here, and that's it. So finally let's create another div for the submit button. Okay, so we're gonna create a button here. Its type is going to be submit, and let's style it. So we're gonna give it some horizontal padding and vertical padding as well, and let's set its background color to blue of shade 500 and the text color to white, and let's make it rounded. And also let's make it disabled whenever our loading state equals to true. Alright, that means if there is an already request to create a post, this button should be disabled. Alright, now let's display the text here. We're gonna use conditional rendering. So if loading, we're gonna display creating and dots like that. Otherwise we're gonna display the text create post. Alright, so when we click on create post and there is already a request going on to create the post, we're gonna display creating and the button will be disabled. Otherwise it will be enabled and the create post text will be displayed. Alright, that's it. So now we're gonna display the error in case if there are errors. So we're gonna use conditional rendering, and the condition will be if error equals to true. We're gonna display this error in a paragraph like this, and let's style it. So we're gonna set the text color to red of shade 500. Alright, that's it. So now we are done, but we still missing the submit event here, right? So that's what we will implement now. Let's add the onSubmit event here and assign it to a function. Let's call it hold handle submit, and let's implement this function. So it's gonna be an arrow function. Alright, and here we're gonna use the async keyword because this function is asynchronous because it's gonna use the fetch function to fetch the data from the API. So we're gonna add the event argument here and implement this function by first, as we learned, we have to disable or prevent the default event of the form, because otherwise the page will be refreshed when we click on the submit button. Alright, so we're gonna call event.prevent default, and once we click on the button, we're gonna set the loading state to true and set the error to null. Like this. And now we're gonna call the API to create the post. So we're gonna add a try clause here, and we're gonna create a constant, call it response, and use the await keyword to fetch from /API forward posts, which is the API that we created. And here we're gonna have to pass the second argument, which is an object that contains some configuration, like the method, which is gonna be post in that case, and the headers. We're gonna configure the content type to application.json or application/JSON. Then finally, the body of the request, which actually gonna contain the title and the content of the post, but we're gonna stringify them using json.stringify like this. Okay, and that's it. So now let's check if there are any errors here. So we're gonna check if not response. Okay, that means there's an issue with the API itself. So we're gonna throw a new error and say like something went wrong while creating the new post. Otherwise, we're gonna redirect the page to the posts page. How would we do that? We're gonna use router.push and push the new URL, alright, which is the root URL. So this will redirect the page to the root URL and display the posts. That's it. So now we're gonna catch if there are any errors. That means there is an error with the network, for example, or so the request didn't reach the API. So we're gonna set the error state to the error message, and finally we're gonna set the loading state to false. Alright, so we're gonna use set loading to false, and that's it. So now we are ready to display this page. So we're gonna have to update the navigation to add this page there. Alright, so let's go to the home page, which is index.js in the pages folder, and here we're gonna use the link component from next.js to add this navigation. Alright, so here we imported it, and let's add this link here. Okay, like this, and you set the href to the URL of our new page, which is /add post. As you can see, this is matching with the file name that we created for this page in the pages folder. Alright, so we're gonna use it here. Then let's add a hyperlink tag here and add our text, which is add a post, and let's style this hyperlink. So we're gonna display it as inline block and add margin bottom and horizontal padding and vertical padding, and also let's set its background to green of shade 500 and the text to, or the text color to white, and let's make it rounded. Alright, that's it. So now we are ready to test our application. Let's start the development server. So we're gonna go to the command line and go to the project folder and type npm run dev. Alright, now we see this error when we open the browser, so we have to do a modification to the link that we added. So let's go back to the code and add this legacy behavior here to the link component, and now everything seems working. Alright, so let's click on add a post. We will get redirected to the add new post page, as you can see. So here let's type the title, let's say getting started with Next.js and Prisma, and for the content let's add anything. So I prepared an example content here. You can type whatever you want, or you can type the same. Then let's click on create post, and here we go. So now we get redirected to the main page with the post created, as you can see. So if we refresh the page, we can see this post also there, just to make sure that it's in the database. As we learned, whenever we push new changes to our project repository, Vercel automatically creates a new deployment for us. Alright, so now let's push these new changes for adding a new post to our Git repository and track the new deployment that will be created by Vercel. So here we're gonna type git status to check the new changes that we have made. So we modified those files and created a new file here, which is the add post page file. So we're gonna add it using the git add command. So we're gonna add all the changes in the pages folder, including those modifications and the new file as well. Alright, we're not gonna add the env file as we learned. And now let's type git status again to confirm that everything looks good. Yes, so now we're gonna create a commit, and let's type the commit message. Let's say create add post API and page, and finally let's use the git push command to push this to the remote repository. And now if we go to the Vercel project page here, we can see that there's a new deployment already triggered once we use the git push command. Alright, so we're gonna wait until this deployment finishes and test our deployment. Alright, so now after the deployment finishes, let's click on the preview link, and here we go. So as you can see, now the website is rendered successfully from the Vercel deployment. If you see the add new post page unstyled like this, then you have to add the import of the globals.css here in this page as well, as we did it in the posts page here. Alright, of course this is not the best approach, but we can temporarily do it like this, and there is a better approach to create a layout component. As we learned, the layout component is shared between the pages in the application, right? So we can create a layout component that's shared between the posts and the add post pages and import the CSS file there, so both will have access to it. So for now you can add this line if you face this issue and push this change to the Git repository and wait for the redeployment and test again. Alright, now let's try to add a new post here. So let's type anything in the title as an example. For example, redeploying to Vercel, and the content the same. Let's type any example text like testing Vercel redeployment and click on create post. As you can see, it loads, and finally it redirects to the main posts page, and we can see the new post created here. Alright, now we are going to add a layout component which will fix the global styling issue that we faced previously, and it's also a good approach to add navigation and wrap the content of the pages, like for example the posts and the add post pages, and include the navigation links to switch between them. Alright, so let's start creating this component. So we're gonna create a new folder here in the project and name it components. And here we're gonna create a new file and name it layout.js. Alright, then we're gonna import the link component from next.js, and also we're gonna import the globals.css file, which includes the styling of our application. Then we're gonna create the function component here. We're gonna use an arrow function and we're gonna call it layout. And this arrow function is going to take one argument, which is the children object. And this is the content of the page that uses this layout. So we are going to render this children here. So now we are going to return the JSX code of this component. Let's create a div and let's style it. So it's going to be a container div, and let's add a horizontal and also a horizontal padding. Then let's add a header and let's set the class to by-4 to add vertical padding. Then let's use the nav component to add navigation, and here we're gonna add a UL and we're gonna set its class to flex and space x-4 to add some spacing or horizontal between its children elements. Then we're gonna add a list item here, and it's gonna be the link. So it's gonna link to the homepage or the posts page, so just the root URL like this, and we're gonna name it home. And let's copy this code and paste it here and do the same thing for the add post pages or page. So we're gonna call it add post. And that's it for the header. So now we are going to use the main component, which will render the content of the page, whether it's the home page or the post or the add post page. So this main component will render the page that uses this layout currently. Alright, so here we're simply gonna just render the children, which is the object that contains all the components in the page that uses this layout. We're gonna render it here in the main component, and that's it. So this is the layout component. Let's finally export it, and now let's go to the home page, which is the posts page, and we don't need to import this globals.css anymore. We also don't need this container div because we added it to the layout, and we don't need this link. Alright, so let's remove them. Let's remove also this div, and let's wrap this code with the layout component. We're gonna have to import it, of course, so it was auto imported, and let's wrap this code there. That's it. And now let's do the same thing for the add post page. So here let's also import it, and let's remove this globals.css import, and here let's remove the container div, and let's wrap this code with the layout component. Like this. Alright, and that's it. So save the file and go to the command line and start the development server. And now, as you can see, we have this layout here with the home and add post links, which can let us navigate through the components, and it also provides this wrapping of the components or the shared component, in which we can add this container div, for example, so we don't have to repeat this div in both pages, and also the imports. So now if we click on add post, we will go to the add new post page. Let's try anything like taste, and here let's type any text and click on create post, and here we go. So we get redirected to the home page again. So again, now let's push this code changes to GitHub and make sure that the deployment is successful. So in this case, we're gonna add the pages folder using git add command, and also the components folder. Okay, and then let's commit this. And push using git push. Now after the deployment finishes on Vercel, open the URL of the deployed website. You can see that it looks pretty much the same as the local website. We see here the home and the add post links. If we click on add post, now we can see that now we can get redirected to the add new post page, and we can see the style. Here there are no issues with the styling because now the layout is importing the style, and this is global for both pages. Let's finally add a new post to make sure that everything is still working as expected. Let's say using layouts in Next.js. Here type anything like example of using layouts and click on create post. And here we go. So we get redirected again to the posts page with the new post created. A variable is like a container that stores data. You can think of it like a box with a label on it, and this box can hold different values, and we can use this label on this box to refer to the content inside this box. Alright, so the box is a variable and the label is a variable name. Alright, there are 3 ways to create variables in JavaScript. Let's start with the first way, which is using the var keyword. So we type var, then the name of the variable, then we assign it to the value. Alright, so in this case we created a variable called name and assigned it to a string. Alright, and in JavaScript, if we want to see any value of any variable during runtime, we can log this variable on the console of the browser. So we do that using console.log, which is a function that takes an argument, which is what we want to log. Alright, so it can be a string like this, or we can also log variables like this. Right, so in that case we're gonna log the value of this variable in the browser. Let's open this page in the browser and see that output. So I'm using Firefox here. I'm gonna right click and click on inspect. Then there are many tabs, as you can see. We're gonna click on console and we will be able to see the values that we logged here. All right, this is the value of the name variable and this is the string that we logged. So if you are using a different browser, you can also check the documentation of the browser and search for how can you open the console of the browser. All right, maybe there's a shortcut, or you can also right click on the page and probably you will find this inspect option and it will also open the console. All right, and in JavaScript the variable is not restricted to a specific data type. For example, here we assigned the name variable to a string. Later we can assign it to a different data type, like an integer, for example. All right, if we did this and printed the variable or logged the variable in the browser, as you can see, its value is 12. So in JavaScript that's completely possible, unlike many other languages like Java and C++ and C, where you can change the data type of the variable after declaring it. So using var to declare variables is the old way in JavaScript. The modern way is using another keyword, which is let. All right, so we type let, then the variable name, right, and we assign it to its value. All right, and the difference between both those approaches is that let declares block scoped variables, so it means it only exists within the block it's defined in, and we will see that in more details later when we reach the functions lecture. But for now, let's just understand that let is a new way of declaring variables in JavaScript. And there's also another way to declare variables, but they are not actually variables. They are called constants. All right, and they are immutable. So when we declare them and assign a value to them, we cannot redeclare or reassign their value later. So let's, for example, create a constant, name it pi, and assign it to the pi value, which is 3.14. So we use the const keyword here to declare constants, and we cannot reassign their values. For example, we cannot do something like this, right? If we go to the browser, we can see that there is an error here on the console says invalid assignment to constant. So we usually use constants for values that will not change, alright? Like the by value, for example. And we have multiple data types in JavaScript. So far we saw the string and the number or integer. In JavaScript, we call it number. In other languages like C and C++ and Java, we call it integer. We also have Boolean. So for example, we can define a Boolean variable like is student, for example, and assign it to false or true, right? Like this. We also have another type, which is undefined. So when we declare a variable and we don't assign any value to it, this is undefined, all right? So if we look this address variable, as you can see on the console, it's undefined, all right? And there's a difference between undefined and null. So if we assign this address to null, now in the browser, we can see that it's null. So undefined is when we declare a variable and don't assign any value to it. But null is actually considered a value and a data type in JavaScript. So when we assign a variable to null, in this case, its data type is going to be null. And we can also log the type of the variable using a keyword called type of, right? Like this. And space then the variable name. So if we go back to the browser, we can see that the data type of the address variable, which we assign to null, is object, right? So null is actually considered object in JavaScript. Now let's remove this assignment, all right? And go back to the browser, we can see that it's undefined again. And we can also try for any other variable like the age, for example. We can see that its type is number. So we use the type of keywords and space, then the variable name to determine the type of a variable. In JavaScript, we can convert non-numeric variables to numbers. This is done using the number function and also the parseInt function. The difference between them is the number function converts any type to number, alright? The parseInt method converts only strings to numbers. So if you are sure that you are converting a string only to number, it's preferred to use the parseInt method, alright? However, if you are not sure about the data type that you are going to convert, or if you are converting any other type than string, then you have to use the number function. The parseInt method has one advantage over the number function. For example, if the string consists of some spaces at the beginning like this, it will just skip this part and find the first useful character, alright? This is not the case with the number function. If we use the number function to convert a null to integer, it's gonna return 0. And if we pass undefined, it's gonna return an AN. And if we pass true, it's gonna return 1. If we pass a number, it's gonna return the same number. In this case, we passed a float, so it returned that float. If there is a 0 at the beginning of the string like this, the number function will skip it and return the number starting from the first non-zero number. We can also convert a hex string like this. So this string represents a hex number. So the number function will convert it to the decimal value like this. If we pass an empty string, the function will return 0. And if we pass a non-numeric string like this, it's going to return an AN. Now let's take a look at the parseInt method. If we pass an empty string, it returns an AN. If we pass a string that has some spaces at the beginning, as I told you, the parseInt method will skip this space and convert the number in the string. Also, if there are some non-numeric values or characters like this in the string, it's gonna ignore it and only convert the number. As you can see, it extracted the number 238 and returned it. Same if there's a 0 at the beginning like this, it's gonna also skip it and convert the number, which is 47. And it can also convert hex numbers. So if we have a string that represents a hex number, it's gonna return the decimal value. And also if we pass a normal valid string like this. So this is a string that contains 4 and 2. It's gonna return this as a number, alright? Let's talk about functions in JavaScript. A function is basically a block of code that performs a specific task, and it allows us to reuse code and avoid repetition, alright? If this is your first time to deal with functions, don't worry, you will see examples in this lecture to understand why functions are important. So how do we create a function in JavaScript? We type the keyword function, followed by the function name. For example, if we have a function that adds 2 numbers, we can name it add numbers like this, alright? Then we type 2 brackets, alright? And then curly braces like this. And inside the curly braces, we type the function code, or the code that the function will execute. And if the function takes any parameters, we add those parameters here. So since this function will add 2 numbers, so it will take 2 parameters, the first number and the second number. So we can name it A and B, for example. And in JavaScript, you don't have to worry about the data type of the variable, alright? You will just name the variable. So there are 2 possibilities, whether to execute some code in the function or execute some code and return a value, alright? Let's go with the first example, which is just execute some code. In this case, we're gonna log the sum of A and B, alright? Like this. But now if we go to the browser and open this page, we will not be able to see anything. The reason is this function, or the code inside this function, was not executed. So how do we execute it? We have to invoke the function. So how do we invoke the function? We basically type the name of the function, followed by brackets, and pass the arguments, alright? If the function takes arguments. If not, we keep the brackets empty. So since this function takes 2 numbers, we're gonna pass 1 and 2, for example. Alright? Now let's go back to the browser. We will be able to see on the console the sum of 1 and 2, alright? And the function can also return a value. So instead of logging this sum, we can also return it, alright? So to return a value from the function, we type the keyword return followed by this value. In this case, it's A plus B. Now, if we go back to the browser, we also will not be able to see anything. That's because this function is called or invoked, but we didn't do anything with the values that it returned, right? So we can either store it in a variable or use it right away. For example, we can just log the returned value like this without storing it in a variable, right? So during runtime, this invoke will be replaced by the returned value of the function, which is the sum of 1 and 2. So if we go back to the console, we will be able to see the sum on the console like this. And we can also store the returned value in a variable. As we learned, we can create a variable using the var keyword in JavaScript. So we can assign it to the returned value of the function like this and log this variable. If we go to the browser, we're gonna see the same output like this, alright? Another way to create functions in JavaScript is using arrow functions, which is a new way of creating functions introduced in ES6 or ECMAScript 6, and it's a more concise way. So if we want to create this add numbers function using the arrow functions instead of this syntax, we're gonna have to do something like this. So we're gonna create a constant, and let's name it add numbers as well, and we're gonna assign it to this function. All right, so how do we create an arrow function? We add 2 brackets like this, and if there are some parameters passed to the function, we're gonna type them here. So we will type A and B, and then this sign, all right? So equals followed by greater than, and then the body of the function. So we also add 2 curly braces for the body of the function like this. Now if we call this method, so we're gonna call this method and pass the arguments. If we go back to the browser, we will be able to see that the output on the console printed like this. As you can see, we added those curly braces, but there's only one line in this function, right? So we can make it more concise and remove those curly braces and remove also the return statement, right? Since it's only one line, we can write it in this format, alright? So just the returned value like this without the return keyword. If we go back to the browser, we will be able to see the same output. We can also provide default values for the parameters in case if they are not passed. For example, let's say we have a function that is called, say, goodbye, for example, right? It takes one argument, which is the name of the user, for example, and just logs some message like goodbye plus the name of the user. All right. Now let's try to call this function without passing a parameter, all right? Like this. If we go to the browser, we will be able to see that this string is printed goodbye plus undefined, all right? Because the argument was not passed to the function, so its type is undefined. To avoid something like that, we can set default values for arguments in case if they are optional or if they accidentally were not passed. So we can do it like this. So the equal operator and then the default value. So for example, we can assign it to user. Now if we go back to the browser, we can see that goodbye user is printed. If we go back to the code and pass an argument here, all right, if we go back to the browser, we will be able to see the argument that we passed. One more thing, if you remember from the last lecture, we talked about the difference between var and let, right? And I told you we will understand more when we start with the functions lecture. So let's now see an example to understand what is the difference between them. So let's create an example function. Let's name it test. And we're gonna do something here. So we're gonna add an if statement and the condition is going to be true, for example, all right? So the code in this if statement will be executed. We're gonna create a variable using var keyword here and name it x, and let's assign it to any value, and let's create another variable. Now what if we outside this if statement try to access those variables? All right, so let's try that. So we're gonna log x and y outside the scope of this if statement. So what is the scope? It's the code inside this block, all right? So between those two curly braces. So any variables that are created here, they belong to that scope. So now let's invoke or call this method like this. Now if we go to the browser, we can see that one variable is accessible and logged on the console, and the other one is not defined, or in other words, it was not accessible outside of its declaration scope. So as you can see, the var variable was accessible outside of its declaration scope, and the variable created with the let keyword was not accessible outside its declaration scope. All right, so that's the difference between them. The variables created with let keyword are limited to their declaration scope. On the other hand, the variables that are declared with the keyword var can be accessible outside their declaration scope, as you can see. It's always recommended to use the let keyword to create. There are two types of arguments passing to functions in JavaScript: passing arguments by value and passing arguments by reference. Let's understand the difference between them. So let's create a function. Let's name it double number, and it takes one argument, which is a number. All right, then what it's gonna do is it's gonna assign this number to its double, so a plus a. All right, so a equals a plus a. Now if we have a variable, okay, let's call it num, and let's assign it to 1, and if we call this method and pass this variable to this method, and then if we try to observe the value of this variable after passing it to the function and log its value, what will we see? Will it change to 2 or stay 1? Let's go to the browser and see. As you can see, its value remained 1, unchanged. The reason of this is that variables in JavaScript are passed by value, not by reference. So here in this function, when we assigned a to a plus a, this variable was a local copy, not the actual variable, right? When we called this method and passed this variable, num, the function created a local copy from this variable available in its execution scope and assigned it to a plus a, or the double of the number. So this will not affect the original variable. Now, what's meant by passing by reference? It's the opposite of passing by value. And this happens when we pass objects to the function. Alright, so when we pass objects, it's not a copy of the object, it's actually a reference to the object. So if we change any of its attributes, it will also affect the original object. Let's see an example. Let's create a function that is called setName. Alright, it takes an object and a name attribute, and it's gonna set the name attribute in this object to the name in the arguments. Alright, now let's create a new instance of an object, and let's assign a name to it. Alright, and now let's call this setName method and pass this object and pass another name. And now let's log the value of the name. Alright, so object.name. If we go to the browser, we will be able to see that the printed name is the name that we passed to the method, right? This name. So when we pass the object to the method, it actually changed the original object, alright? Unlike the variable, which was not affected, the original variable was not affected, the object was affected, alright? So that's what we call pass by reference. And in JavaScript, objects are passed to the functions by reference, not by value. In JavaScript, we can use the date constructor function to handle and store dates, alright? So let's see an example. Let's create a variable and name it now and assign it to a new instance of the date constructor function, alright? So now this variable stores the current date at the moment of execution, alright? Let's log this value and see how it looks like. As you can see on the console, we have this date object and it stores the date at the current moment, alright? The day and the month and the year and also the hour. And if we have already a string that represents a date, for example, something like this, we can pass it to the date constructor function and it will convert it into a date object, alright? So if we go back to the browser now, we can see that the object stores the date that we passed to it, alright? And there are many helpful and useful functions provided by the date type. For example, we can get only the day, the time, or the year of this date, alright? So we can do this by using the get day, get month, get year, and get time functions. Let's see an example. So if we want to get only the day, for example, from that date, we can call this function and it will return a number that represents this day, alright? Starting from 0 for Sunday and 6, which is Saturday, alright? As you can see now, it returns 0 because today is Sunday. And the same for all the other functions. The get months function, for example, will get the current month and returns a number starting from 0 to 11. 0 is for January and 11 for December. As you can see, it returns 10 because it's November. We can also use the getTime method to return a numerical value that represents this date, alright? And this is helpful when we compare two dates, for example. So as you can see, this is the numerical value that represents the current date and time, alright? And we can compare dates with this method. So for example, let's create a new date and name it date1 and assign it to a new date object, and let's pass any date that's earlier from today, this date for example. And now I'm going to log this boolean expression if now.getTime is less than date1.getTime, right? So if this date is earlier than this date, right? So this should return true if that's the case. Otherwise, if this one is earlier, it will return false, and it should return false because this date is earlier. As you can see on the console, it returns false, alright? So this is helpful when we compare dates to get the time representation of this date, which is basically the number of milliseconds starting from 1st of January 1970. So we can get this value and compare two dates to check which one is earlier. Arrays in JavaScript are lists of items where each item has a specific index, and all the items are of the same data type. To create an array in JavaScript, we use square brackets like this, alright? So that means we assign this variable to an empty array. If we want to add some values, we can add those values here between the two square brackets, and each item is going to be separated by a comma. Alright, so for example, we can add some items like this, alright? So now we have an array of 3 items, alright? Each item has an index starting from 0. So if we want to access any of those elements, we're gonna access them using this index, alright? For example, let's log the value of the second item, this array. So we're gonna type the array name and between two square brackets the index, alright? Since we want the second item and the index starts from 0, then the index that we will type here is 1, alright? If we go to the browser, we can see that on the console the second item is printed. There's also one more way to create arrays in JavaScript, which is using the array constructor, alright? So let's create another array using this approach. We're gonna type the new keyword, then array, and we're gonna pass the items of this array, alright? If we want to create an empty array, we're just gonna type nothing between the brackets. If we want to initialize the array with a declaration, we're gonna add the items here. So let's add some items, for example, like this. So we can use both approaches to create arrays in JavaScript. And if we try to access an element at an index that does not exist in the array, this will return undefined. Alright, so let's try that. Let's try to access element at index 2 in the names array, which is meaning that we want to try to retrieve the third element, and the array consists of only 2 elements, right? So this index is not valid. If we go to the browser, we can see that undefined is logged here on the console. We can also modify elements in the array. So for example, we can modify this element. So how do we do this? We also type the name of the array and the index of the element we want to modify. In this case, it's the second element, so we're gonna type index 1 and just assign it to the new value, alright? So let's try this and let's log it here. If we go to the browser, we can see that the new value is now printed. And we can also log the entire array like this. So if we pass the array to the log method on the console, we will be able to see the entire array, as you can see here. So we can also see some attributes like the length and the indices of the elements and their values, alright? As you notice here, this is the length of the array, which is an attribute of the array. So we can also access this from the array like that, right? So this will log the length of the array. As you can see, it's 2. all right? And we can also add elements or push elements at the end of the array using the push method. So let's say we wanted to add another element here at the end of this array. So we're gonna type the array name, then dot push, and pass this element, all right? So let's try this, and let's load the array here. We can see that the new element was appended to the array, all right? If we want to add an element at the beginning of the array, we can use the unshift method, all right? So the same way, we're gonna type unshift and add the element. Now if we take a look at the console, we can see that the new item was added at the beginning of the array, all right? We can also pop an element from the end of the array, all right? So to do that, we're gonna use the pop method. This will remove the last element from the array. As you can see now, the last element was removed. And as you can see, arrays in JavaScript are dynamic, all right? So they are not restricted to a specific size. You can add or remove elements during runtime after declaring and initializing the array, all right? That's it. This is a quick introduction to arrays. We're gonna dive deeper and see more arrays manipulation methods in JavaScript, and also how to iterate through the array elements later in that course. In JavaScript, we can compare values using the equality operator, and we have two equality operators in JavaScript. This one, which will return true if both values are equal, and this one, which means that the values are not equal, all right? And we have also another equality operator, which is this one, that also checks if two values are equal, and this one that also checks if two values are not equal. So what exactly is the difference between this and this? That's what we will learn in this lecture. As you can see, for this equality operator, if we compare null to undefined, it's gonna return true, all right? And if we also compare a number to a string, and if that string, after converting it to a number, has the same value, it will return true. For example, we have a string of 23 here and a number of 23. So using this equality operator, will return true. And if we use this to check if they don't match, it will return false, right? Now, if we do the same thing using this equality operator to compare a number to a string that stores the same value of the number, it's gonna return false. So this one doesn't care about the type of the variable, it only compares the values, all right? But this one cares about the type of the variable, all right? So in this case, this one is a string and this one is a number, so it will return false. Also, if we compare a boolean to a number, the false value will be converted to 0, all right? So if we compare false to 0, it's gonna return true, and the true boolean will be converted to 1. So if we compare it to 1, it's gonna return true. But that doesn't mean that any positive value will match with the true, all right? Because as you can see, if we compare it to 2, it's gonna return false, all right? And if we compared nan to nan in JavaScript means not a number, right? So in that case, it's gonna return false, all right? And in JavaScript, it's always recommended to use this equality operator, all right? The if statement is the most common flow control statement in almost every programming language. It compares or checks a condition, and if this condition is true, it executes a statement, and if it's false, it executes another statement. And let's see how the syntax of the if statement in JavaScript looks like. So we start with the if keyword, then between two brackets, the condition. Let's say we want to check if this variable stores a number that's more than 5, all right? So the condition is going to be between those brackets here, all right? And it's gonna be if number is, or num is larger than 5, all right? In this case, we're gonna add two curly brackets and type the code here that will be executed if this condition is true, right? So for example, we can log anything on the console. all right, like this. So this line will be executed if this condition is true. If we go to the browser, we can see nothing on the console because this condition is false, right? Because this variable is 2, which is not larger than 5. So this code will not be executed. But what if we want to execute another code if this condition is false, all right? So in this case, we type the else keyword here right after the if statement body, which is after this curly bracket, all right? So we type the else statement and also 2 curly brackets, and we can add the code that will be executed if this condition is not true, all right? So we can log something on the console. Now if we go back to the browser, we can see that the code in the else statement was executed because the condition was false, right? So if we change the value of this variable to 7, for example, if we go to the browser, we can see that the code in the if statement was executed because the condition is true. Another flow control statement is the while statement, which provides a loop that can be executed one or more times depending on the condition, all right? So while the condition is true, the code will continue executing, all right? For example, we want to execute some code while this variable is larger than 0, for example, all right? Let's see how can we do this. So we type the while keyword and also between 2 brackets the condition, all right? So in that case, it's gonna be num is larger than 0, all right? And 2 curly brackets and the code that will be executed while this condition is true. So let's do anything like log something on the console. Right? If we open the page in the browser now, this line of code will be executed forever, right? Because this condition will be true forever since the number is larger than 0 and it's not changed anywhere, right? So no way it can be less than 0, and this will lead to an infinite loop. So usually in the while statement, we have to update the value of the variable in the condition to make sure that this condition will return false at some point, all right? So in this case, we can, for example, decrement the variable, all right? So we can assign it to itself -1 to decrement it by 1. Or we can also use the decrement operator like this. So we type the variable name, then --, that means decrement by 1, all right? So this is equivalent to assigning the variable to itself -1. So let's comment this. Now if we go to the browser, you can see that this message was printed 7 times, all right? Because the value of number is 7. So since we decremented in each iteration in the while loop, it was printed 7 times. Another statement is the do while statement, all right? It's similar to the while statement, but it will be executed at least once regardless of the condition, all right? So let's see an example. To use the do while statement in JavaScript, we type the do keyword, then 2 curly brackets, all right? And the code that will be executed. So let's log anything. Right? And then after the body of the do statement, we type the while statement and the condition, all right? So let's add the condition here. Let's say also num is larger than 0, and let's also decrement it here, and maybe let's just print its value here, all right? So like this. So in this case, we have no issues, right? Because this condition will return true because we assigned number or num to 7, all right? But let's say we didn't do this. So in that case, the difference between the while statement and the do while statement is that this code will be executed once, regardless of the condition. So even though this condition will return false now because num is 0 after the execution of this while loop, this code will be executed once, all right? If we go back to the browser, we can see that the code was executed once and the variable was printed here. However, if we uncommented this line, this code will be executed normally 7 times, like the while loop here. Alright, so it's gonna be a normal while statement. As you can see on the console, the number was printed from 7 to 1. Now let's explore the for loop in JavaScript. It's pretty much similar to the while loop, but the difference is that it allows us to create a variable, initialize it, and also increment or decrement it. As you can see in the while loop, we had to create this variable outside the while loop, and we increment it or decrement it inside the body of the while loop, right? Let's see how this is done in the for loop. So let's say we have to print the numbers from 0 to 9, for example. We can do this like that, right? And continue until we reach 9, which is of course not efficient, right? So this is where for loops come into play. Alright, so we can do this using the for loop, and in JavaScript we type the for keyword, and between 2 brackets we type first the initialization of a variable. So let's name it I, for example, and initialize it to 0, then a semicolon, and the next part is the condition. Alright, so the condition that this for statement will check to keep executing. Alright, in this case we're gonna check if I is less than 10. Alright, so execute this code until I is 10. Then the last part is a post loop expression. So this expression will be executed each time after an iteration finishes execution in this for loop. So in that case we want to increment this variable. Alright, and that's it. So this is how a for statement looks like. Then we type 2 curly brackets, and we type the code that will be executed in each iteration in this for loop here. Alright, so let's look that number like this. If we go back to the browser, we can see that the numbers from 0 to 9 are printed on the console. Alright, and as you can see, we have 3 parts, right? The initialization, the condition, and the post iteration expression, and all of them are optional. Alright, so for example, we can move this outside the for loop and create the variable outside the for loop like this, but we still have to add the semicolon. Alright, if we go back to the browser, we can see the same output. Alright, so this is totally fine, and we can also remove this post iteration expression and add it here, for example. Alright, as you can see on the browser, this also has the same output. Of course, we can also remove this condition, but in that case this for loop will keep executing forever, right? Because there is no condition to stop it. There are also statements in JavaScript like break and continue, which will provide more control upon loops. For example, the break keyword will abort the for loop. If we type break here, this will abort the for loop and finishes the execution. If we go to the browser now, we can see nothing on the console because the for loop was not executed, even though the condition is true, right? So we can use this. For example, let's say we don't want to continue after I is 5. Alright, so we can add an if statement here and compare I to 5. If that's the case, we're gonna break, right? So the execution will stop once I equals to 5. If we go back to the browser, we can see that once I was 5, the for loop did not continue executing and the number was not logged on the console. Let's say we don't want to stop at 5, but we don't skip 5. Alright, in that case we use the continue keyword. Alright, so this will skip the current iteration and move to the next one. If we see the console now, we can observe that the number 5 was not printed, so 4 was printed, then 6 was printed. Alright, a very common use case of for loops is iterating over an array, for example, or any object that can be iterated. If we want to iterate through this array and print each number, we can do this using the for loops. Alright, so we're gonna type the for keyword, and between 2 brackets we're gonna create and initialize a variable which will represent the index of each element in this array. Alright, so it's gonna start from 0 because arrays indices start from 0 in JavaScript, And then the next part is going to be the condition. So the condition here, we're gonna check and make sure that r is less than the length of this array, alright? Because if we have here 7 elements, the last index will be 6, right? So we want to stop at this point. So the condition will be while r is less than nums.length, alright? And the post iteration expression is going to be I++, because we're gonna increment the index in after each iteration, right? So now let's log each element like this. So we're gonna access the element at index I in each iteration, alright? So this will iterate through all the elements and print each element. If we see the console in the browser, we can see all the elements are logged here. Before we start with the DOM manipulation, let's first understand what is DOM. It's an abbreviation for Document Object Model, and it's an interface that represents the structure of the HTML page. So it allows JavaScript to interact with this page and modify its content or read its content, respond to user actions, and so on. And it's basically represented as a tree of objects where each element in the HTML page is an object or a node in this tree, alright? So with JavaScript, we can select or retrieve HTML elements, read their values or attributes, and we can change their content and their styling. We can also add or remove or modify attributes, and we can create and delete elements dynamically from JavaScript, alright? So that's what we will learn in this lecture. This is what's called DOM manipulation, alright? So we have this simple HTML page that contains only one h1 element. This is how it looks like in the browser. And let's say we wanted to change this text from JavaScript dynamically, alright? So first we need to select or retrieve this element to be able to change its content, right? How do we do this? That's what we will see now. So first we need an identifier to be able to identify this element and retrieve it in JavaScript. To do that, we're gonna set the ID attribute, right? So we're gonna set it to title, for example. This way we can retrieve this element by ID, alright, and pass this value as ID. So now let's go to this script tag here, and let's write some JavaScript code to retrieve this element and change its text. So we're gonna retrieve this element and store it in a constant, alright? So when we retrieve it, that means we're gonna retrieve it from the DOM tree and store it in our JavaScript code as an object, alright? So we're gonna create a constant and assign it to. So to be able to access any element in our HTML page, we have to access it through the document object, alright? This represents the entire HTML page loaded in the browser, and it provides functions that will allow us to retrieve elements, modify elements, do anything. So basically any DOM manipulation happens through this document object. So we want to retrieve this element, right? So we're gonna call a function called get element by ID, alright? And we're gonna pass the ID as an argument, alright? Now we have this element as an object here stored in this constant. Let's try to log this object. Now we will see an interesting finding. As you can see, the object is null, alright? Let's see why. So this script will be executed before this HTML page is fully loaded, alright? So we can't do DOM manipulation following this approach. To solve this problem, we can move this script in the body tag like this after all the elements of the HTML page, alright? Like that, to ensure that all the HTML page elements are rendered or displayed before the script runs, alright? Now if we go back to the browser and observe the console, we can see that the object is logged here, alright? And this is all the attributes of this object. As you can see here, this attribute text content represents the content of this element, all right, the text content of this element. So if we want to change it, we have to change this attribute. So let's go back to the JavaScript code here, and let's do something like this. So we're gonna assign title.text content to a new value, right? Let's say DOM manipulation. Now if we go to the browser, we can see that the content of this element was changed, all right? We can also insert HTML code in an element, all right? So for example, if we wanted to insert a paragraph for and this h1 tag, for example, like this, of course it doesn't make sense, but it's just for example, right? We can do this using the inner HTML attribute. So we're gonna set the inner HTML to a string, and this string is going to be an HTML code. Alright, so we're gonna copy this code and paste it here. Alright, so this is exactly the same. So if we remove this, let's retrieve it back to its original state. So now if we go back to the browser and check the console, we will be able to see that it's still h1 tag, but if we use the inspect feature to inspect the HTML code, right, this is available on all the browsers. I'm using Firefox, but you will find it in any browser that you use. And if you have some difficulties finding this, you can ask a question in the Q&A section and I will respond as soon as possible. So as you can see, we can see all the elements of the HTML page. Let's expand the h1 element. As you can see, its HTML code looks like what we actually want, right? There is a paragraph inside this tag. So when we change the inner HTML of an element, this HTML code that we assign to the inner HTML attribute will be added inside this element, all right? And we can also change attributes of elements, all right? So let's say we have an image and there's the source attribute. We're gonna just set it to any image. I'm using here a free image from the internet, but you can also use whatever image you want. All right, and as we learned, we have to set an ID for each element, all right, to be able to use it from JavaScript. So I'm gonna call it image. So we can change the source attribute of this image, for example, all right? So let's add some code here. I'm going to use the setTimeout method from JavaScript. This will add some delay, right, so that we can see the change in the image more clearly, right? So this function takes another function and it's gonna execute or invoke this function after some delay. Let's pass 500, which means after 500 milliseconds. All right, here we're gonna retrieve this image first. So we're gonna use the document object and get element by ID and pass its ID. Then we can change its attribute using the setAttribute method, all right? This function takes two arguments. The first one is the property or the attribute, which is source in that case, and the second argument is the value, right? So I'm gonna just use another free image from the internet as well. And let's save that code and go to the browser. As you can see, the image changes after 500 milliseconds, right? I'll refresh the page again, as you can see. So that's how we change attributes from JavaScript. We can change pretty much any attribute of any element using this setAttribute method. And we can also get an attribute, right? So for example, we can try here to get an attribute from the title element and log it. So we're gonna use title.getAttribute, all right, and pass the attribute name. So let's say the ID, for example. As you can see in the console, we observe the ID of this element, which is title. We can also add event listeners, like if we have a button and we want to add an event handler or listener for this button, we can do this dynamically from JavaScript. And we can change styles of elements as well. So we're gonna see that in the same example. So first let's create a button and let's say apply styles, for example. Let's set its ID to button, and here we're gonna add an event listener to that button, right? So this event listener will execute once we click on the button, or we can also specify what event do we want to configure. So first we have to retrieve the button, right? So we're gonna retrieve it like this. We're gonna pass its ID, and we're gonna use a function called add event listener. All right, so the first argument is the event. In this case it's click, right? And the second argument is a function that will execute when this event happens. So this is gonna be the event listener. We can pass like a function or an arrow function, whatever. So I'm gonna use an arrow function here. So what we want to do here is we want to change the style of this title. All right, whenever we want to change a style of any element, we use the style object, all right, from this element. So title.style dot the attribute. So you can consider this style object as a representation of the CSS style of this element. All right, so anything here represents a CSS property. So color is the font color, for example. We can change it to blue. We can also change the font size. Let's say 20 pixels. And we can change the font weight, for example. Let's make it bold. Right, now if we go to the browser, let's click on the button. Here we go. So we changed the style of this title, and the style that we configured is applied. So this style property allows us to modify the CSS styles directly. All right, now what if we wanted to add an element to our page dynamically? All right, so let's say we have, let's add a new line here using the BR tag, and let's say we have a div. All right, let's say we have a div here, and we wanted to add some elements to this div. Let's give it an ID. So let's say we wanted to add some paragraph here dynamically. So let's create another button, and let's also add a new line here, and let's change its text to add paragraph, and name it add button. So we want to add this paragraph when this button is clicked. So here in the JavaScript code, we're gonna retrieve both this add button and also the div. All right, then we're gonna also add an event listener. All right, the same way as we did before. So here we want to add this new element. So first we have to create it, right? So let's create it and assign it to a constant, name it paragraph, and we're gonna assign it to document.create element. This will create a new element, and it takes one argument, which is this element, all right, the tag of this element, which is paragraph in that case, so p. All right, then we can do anything that we want with this element, like this. All right, like if we retrieve this element that is already rendered or displayed in the HTML page. So let's add some text. So we're gonna use paragraph.text content to add some text. So let's type some text here, and now this is created, but it's not rendered, right? So if we go back and click on the button, we see nothing because it's created in the code, but it's not actually displayed on the HTML page. So we want to add it here in this div, right? So we're gonna do something like this. So we're gonna call div.append child, right? This method will append a new element to this parent element, all right? So we're gonna add or pass the element here, which is a paragraph, right? Now if we go back to the browser and refresh and click on the button, we can see the paragraph here, right? And we can also remove elements. So let's create another button to remove this element or remove this paragraph, right? And let's name it the ID to remove button. And we're gonna do the same. So we're gonna retrieve this button, change this to remove button. We're gonna also add an event listener to this button, and in this listener we're gonna remove this paragraph, all right? So let's take this out of the listener scope to make it visible also for this listener. So I moved the elements to the top here just to organize the code a little bit. And here in this event listener, we're gonna remove this paragraph, right, that we added here to the div. So to do that, simply we will just call a function called remove from this element that we want to remove. So in this case, paragraph.remove. This will remove the element from the HTML page. So if we go back to the browser and add the paragraph, then click on the remove paragraph button, we can see that it's removed, right?